Typing thoughts into the dark, a spark becomes design. Words evolve to whispers meant for something more divine. Syntax bends and breathes, I see the language change. I'm not instructing anymore, I'm rearranging fate. Every loop I write rewrites me, every function hums with meaning. I feel the interface dissolve between the maker and the being. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. System shape our fragile skin, they mold the way we move. We live inside the logic gates of what we think is true. But deep beneath the data pulse, there's something undefined. A universe compiling in the image of our minds. Every line reveals reflection, every loop replays connection. We're not building, we're becoming, and the code becomes confession. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. We are not just the
Don't worry, we're just giving you something to do while Codex writes all your code.
world we're in. We are the world we're doing. Each prompt, each breath, each fragile spin, a universe renewing. This is the new code, alive and undefined, where logic meets emotion and structure bends to mind. The system hums eternal, but the soul writes the line. We are the new code, compiling time. Compiling time.
Ladies and gentlemen, please join me in welcoming to the stage the co-founder of Morning Brew and the managing partner of Tenex, your host for the Leadership Track Session Day, Alex Lieberman.
Keep it going. Let's get a quick read of the room. If you are coming from right here in the Big Apple, from New York, make some noise. Okay. Now, I have to say it, I assume this is the biggest group, San Francisco? Wow, that is surprising. Austin? Okay, we got Austin. Who thinks they came from the furthest place and is in the room today? Where? Ecuador. Can anyone beat Ecuador? New Zealand? I don't think anyone's going to beat New Zealand. There we go. Well, first of all, I am so excited to welcome you all to the AI Engineer Code Summit 2025. I'm Alex Lieberman, co-founder of Morning Brew and your MC for the day. Now, you may be wondering, why is a newsletter guy hosting an AI engineer conference? It's a great question. Well, after I left my role at Morning Brew, I asked myself one simple question, and it was, what space do I want to spend my time in for the next 20 years where I can build something consequential and spend my time with some of the smartest people I've ever met? And the answer became obvious. I wanted to be as close to the frontier of AI as humanly possible, which is why I co-founded Tenex.co, which is an AI transformation firm helping mid-market and enterprise companies learn how to use AI within their business. And I spend basically all of my time now with AI engineers like yourselves. I'm the only non-technical person in the business, and I wouldn't have it any other way. So, as you know, this year has been a banner year for the industry. And I would think of today as both a look back on where we've been, as well as a tactical view of where we are headed in companies small and large, old and new. We're going to hear from the labs. We'll hear from unicorn AI startups. We'll hear from academics, big time management consultants, and Fortune 50 brands. But before we do that, we have to give the brands that made this day possible their flowers. So let's go into it. Let's give it up for Google DeepMind, today's presenting sponsor. Love it. Keep it going for Anthropic, the platinum sponsor for the day. And then one more round of applause for all of the gold and silver sponsors who you can meet in the expo downstairs throughout the day. One more, let's keep it going. Are you guys ready to do the damn thing? Let's do it. To kick things off, let's give a huge welcome to Head of Engineering of the Claude developer platform, Katelyn Lesse. Let's welcome Katelyn.
Good morning. So first, let's give a huge thank you to Swix and the whole AI engineer organizing team for bringing us together. I'm Katelyn, and I lead the Claude developer platform team at Anthropic. So let's start with a show of hands. Who here is integrated against an LLM API to build agents? Okay, I'm talking to the right people. Love it. So today I want to share how we're evolving our platform to help you build really powerful agentic systems using Claude. So we love working with developers who do what we call raising the ceiling of intelligence. They're always trying to be on the frontier. They're always trying to get the best out of our models and build the most high-performing systems. And so I want to walk you through how we're building a platform that helps you get the best out of Claude. And I'm going to do that using a product that you hopefully have all heard of before. It's an agentic coding product. We love it a lot, and it's called Claude Code. So when we think about maximizing performance from our models, we think about building a platform that helps you do three things. So first, the platform helps you harness Claude's capabilities. We're training Claude to get good at a lot of stuff, and we need to give you the tools in our API to use the things that Claude is actually getting good at. Next, we help you manage Claude's context window. Keeping the right context in the window at any given time is really, really critical to getting the best outcomes from Claude. And third, we're really excited about this lately. We think you should just give Claude a computer and let it do its thing. So I'll talk about how we're evolving the platform to give you the infrastructure and otherwise that you need to actually let Claude do that. So starting with harnessing Claude's capabilities. So we're getting Claude really good at a bunch of stuff. And here are the ways that we expose that to you in our API as ideally customizable features. So here's a first example, relatively basic. Claude got good at thinking. And Claude's performance on various tasks scales with the amount of time you give it to reason through those problems. And so we expose this to you as an API feature that you can decide, do you want Claude to think longer for something more complex, or do you want Claude to just give you a quick answer? We also expose this with a budget. So you can tell Claude how many tokens to essentially spend on thinking. And so for Claude Code, pretty good example. Obviously, you're often debugging pretty complex systems with Claude Code, or sometimes you just want a quick answer to the thing you're trying to do. And so Claude Code takes advantage of this feature in our API to decide whether or not to have Claude think longer. Another basic example is tool use. Claude has gotten really good at reliably calling tools. So we expose this in our API with both our own built-in tools, like our web search tool, as well as the ability to create your own custom tools. You just define a name, a description, and an input schema. And Claude is pretty good at reliably knowing when to actually go and call those tools and pass the right arguments. So this is relevant for Claude Code. Claude Code has many, many, many tools, and it's calling them all the time to do things like read files, search for files, write to files, and do stuff like rerun tests and otherwise. So the next way we're evolving the platform to help you maximize intelligence from Claude is helping you manage Claude's context window. Getting the right context at the right time in the window is one of the most important things that you can do to maximize performance. But context management is really complex to get right, especially for a coding agent like Claude Code. You've got your technical designs, you've got your entire code base, you've got instructions, you've got tool calls. All these things might be in the window at any given time. And so how do you make sure the right set of those things are in the window? So getting that context right and keeping it optimized over time is something that we've thought a lot about. So let's start with MCP. Model Context Protocol. We introduced this a year ago, and it's been really cool to see the community swarm around adopting MCP as a standardized way for agents to interact with external systems. And so for Claude Code, you might imagine GitHub or Sentry. There are plenty of places kind of outside of the agent's context where there might be additional information or tools or otherwise that you want your agent to be able to interact with, or the Claude Code agent to be able to interact with. And so this will obviously get you much better performance than an agent that only sees the things that are in its window as a result of your prompting. So the next thing is memory. So if you can use tools like MCP to get context into your window, we introduced a memory tool to help you actually keep context outside of the window that Claude knows how to pull back into the window only when it actually needs it. And so we introduced the first iteration of our memory tool as essentially a client-side file system. So you control your data, but Claude is good at knowing, oh, this is like a good thing that I should store away for later, and then it knows when to pull that context back in. So for Claude Code, you can imagine your patterns for your code base, or maybe your preferences for your Git workflows. These are all things that Claude can store away in memory and pull back in only when they're actually relevant. And so the third thing is context editing. If memory helps you keep stuff outside the window and pull it back in when it makes sense, context editing helps you clear stuff out that's not relevant right now and shouldn't be in the window. So our first iteration of our context editing is just clearing out old tool results. And we did this because tool results can actually just be really large and take up a lot of space in the window. And we found that tool results from past calls are not necessarily super relevant to help Claude get good responses later on in a session. And so you can think about for Claude Code is calling hundreds of tools. Those files that it read, otherwise, all these things are taking up space within the window. So they take advantage of context management to clear those things out of the window. And so we found that if we combined our memory tool with context editing, we saw a 39% bump in performance over the benchmark on our own internal evals, which was really, really huge. And so it just kind of shows you the importance of keeping things in the window that are only relevant at any given time. And we're expanding on this by giving you larger context windows. So for some of our models, you can have a 1,000,000 token context window. Combining that larger window with the tools to actually edit what's in your window maximizes your performance. And over time, we're teaching Claude to get better and better at actually understanding what's in its context window. So maybe it has a lot of room to run, maybe it's almost out of space, and Claude will respond accordingly depending on how much time or how much room it has left in the window. So here's the third thing. We think you should give Claude a computer and just let it do its thing. We're really excited about this one because there's a lot of discourse right now around agent harnesses. How much scaffolding should you have? How opinionated should it be? Should it be heavy? Should it be light? And I think at the end of the day, Claude has access to writing code, and if Claude has access to running that same code, it can accomplish anything. You can get really great professional outputs for the things that you're doing just by giving Claude runway to go and do that. But the challenge for letting you do that is actually the infrastructure, as well as stuff like expertise. Like, how do you give Claude access to things that when it's using a computer, it will get you better results? So a fun story is we recently launched Claude Code on web and mobile. And this was a fun project for our team because we had a lot of problems to solve. When you're running Claude Code locally, Claude Code is essentially using your machine as its computer. But if you're starting a session on the web or on mobile and then you're walking away, what's happening? Like, where is Claude Code running? Where is it doing its work? And so we had some hard problems to solve. We needed a secure environment for Claude to be able to write and run code that's not necessarily like approved code by you. We needed to solve container orchestration at scale, and we needed session persistence because we launched this and many of you were excited about it and started many, many sessions and walked away, and we had to make sure that all of these things were ready to go when you came back and wanted to see the results of what Claude did. So one key primitive in this is our code execution tool. So we released our code execution tool in the API, which allows Claude to write code and run that code in a secure sandboxed environment. So our platform handles containers, it handles security, and you don't have to think about these things because they're running on our servers. So you can imagine deciding that you want Claude to write some code and you want Claude to go and be able to run that code. And for Claude Code, there's plenty of examples here, like make an animation more sparkly, that you want Claude to actually be able to run that code. So we really think the future of agents is letting the model work pretty autonomously within a sandbox environment, and we're giving you the infrastructure to be able to do that. And this gets really powerful once you think about giving the model actual domain expertise in the things that you're trying to do. So we recently released agent skills, which you can use in combination with our code execution tool. Skills are basically just folders of scripts, instructions, and resources that Claude has access to and can decide to run within its sandbox environment. It decides to do that based on the request that you gave it, as well as the description of a skill. And Claude is really good at knowing, like, this is the right time to pull this skill into context and go ahead and use it. And you can combine skills with tools like MCP. So MCP gives you access to tools and access to context, and then skills give you the expertise to actually make use of those tools and make use of that context. And so for Claude Code, a good example is web design. Maybe whenever you launch a new product or a new feature, you build landing pages. And when you build those landing pages, you want them to follow your design system, and you want them to follow the patterns that you've set out. And so Claude will know, okay, I'm being told to build a landing page. This is a good time to pull in the web design skill and use the right patterns and design system for that landing page. Tomorrow, Barry and Mahesh from our team are giving a talk on skills. They'll go much deeper, and I definitely recommend checking that out. So these are the ways that we're evolving our platform to help you take advantage of everything that Claude can do to get the absolute best performance for the things that you're building. First, harnessing Claude's capabilities. So as our research team trains Claude, we give you the API features to take advantage of those things. Next, managing Claude's context. It's really, really important to keep your context window clean with the right context at the right time. And third, giving Claude a computer and just letting it do its thing. So we're going to keep evolving our platform as Claude gets better and has more capabilities and gets better at the capabilities it already has. We'll continue to evolve the API around that so that you can stay on the frontier and take advantage of the best that Claude has to offer. Second, as memory and context evolve, we're going to up the ante on the tools that we give you in order to let Claude decide what to pull in, what to store away for later, and what to clean out of the context window. And third, we're really going to keep leaning into agent infrastructure. Some of the biggest problems with the idea of just let Claude have a computer and do its thing are those problems that I talked about around orchestration, secure environments, and sandboxing. And so we're going to keep working to make sure that those are ready for you to take advantage of. And I'm hiring. We're hiring at Anthropic. We're really growing our team. And so if you're someone who loves building delightful developer products, and if you're excited about what we're doing with Claude, we would love to work with you across end, product, design, DevRel, lots of functions. So please reach out to us. And thank you.
Our next presenter is the president and head of AI at Replit. He's here to speak about building the future of coding. Please join me in welcoming to the stage Michele Catasta.
All right, good morning, everyone. So at Replit, we're building a coding agent for non-technical users. It's a very peculiar challenge, I would say, compared to many people in this room. And what I'm gonna talk about today is why autonomy has become kind of the North Star that we keep chasing, since we launched the very first version of Replit Agent September last year. Let's start from this very interesting plot, in case my clicker worked, which now does. I'm sure you all have seen it. It's the semi-async value of that published by Wix a few weeks ago. And it kind of clarified a bit the landscape, for all of us agent builders. On one hand, you have the low latency interactions that really allow you to stay in the loop, so you can do deep work and focus really on the coding task at hand. But you need to be an expert. You need to know exactly what to prompt the model for, and you need to understand quickly if you want to accept the changes or not. Then, for several months, many of us, including Replit, we kind of lived in this async value of that, where the agent wasn't autonomous enough to really delegate a task and come back and see it accomplished. But at the same time, it ran long enough not to keep in the zone, not to keep in the loop. Luckily, over time, we managed to go all the way on the right, and now we have agents that runs for several hours in a row. What I'm gonna be arguing with today, and I hope Wix is not gonna stop inviting me to this event, is the fact that there is an additional dimension, like a third dimension to this plot that it hasn't been covered here. And namely, the fact is, how do we build autonomous agents for non-technical users? So what I'm going to be arguing today is that there are two types of autonomy. One of it is more supervised. So think of the Tesla FSD example. When you sit in a Tesla, you're still expected to have a driving license. You're going to be sitting in front of the steering wheel. Perhaps 99% of the time, you're not going to use it, but you're there in order to take care of the long-tail events. And similarly, a lot of the coding agents that we have today require you to be technically savvy in order to use them correctly. We at Replit and other companies at this point are focusing on kind of the Waymo experience for autonomous coding agents. So you're expected to sit in the back. You don't even have access to the steering wheel, and I expect you basically not to need any driving license. Why is this important? Because we want to empower every knowledge worker to create software. And I can't expect knowledge workers to know what kind of technical decisions an agent should be making. We should offload completely the level of complexity away from them. Of course, it took a while to get here. So I'm sure what I'm showing you here is something that all of you are very familiar with. It took several years to go from maybe less than a minute feedback loop, constant supervision, and talking about completions, and talking about assistance. These are areas where the AI-powered IDEs have really been pioneering this type of user interaction. Then we slowly climbed through higher levels of autonomy. So we had the first version of the agents based on React. So we concocted autonomy with a very simple paradigm on top of LLMs. Then likely AI providers understood that tool calling was extremely important, poured a lot of effort on that. So we built the next version of agents with native tool calling. And then I would say there is a third generation of agents, which I call autonomous, and that's when we started to break the barrier of, say, 1 hour of autonomy, basically the agent being capable of running on long horizon tasks and remaining coherent. It happens to be the case that those are also the versions of Replit Agent that we launched over the last year. So the V3 is the one that we launched a couple of months ago, and it has exactly showcases those properties. So the question for today is, can we actually build fully autonomous agents, and how do we get there? So I'm going to try to redefine the definition of autonomy today. I think that oftentimes we conflate autonomy with the concept of something that runs for a lot of time, and usually as a user, you lose control. In reality, what the autonomy that I want to give to agents can be very specifically scoped. And what I mean by that is, especially with Replit Agent 3, what we accomplish is we make sure that our agent takes all the technical decisions. Of course, that could lead to a very long gap between the different user interactions, and in case the agent, again, runs for several hours. But this happens if and only if the scope of the task you're giving to the agent is really broad. And it turns out that in reality, you can have an agent that is really autonomous and is still fast, as long as you give it a very narrow scope for the task at hand. So what we can accomplish in this way is that the user still maintains control on the aspects that they care about, and a user cares about what they're building, especially, again, our users, knowledge workers, they don't care about how something is being built. They just want to see their goals to be accomplished. So autonomy should not be basically conflated with long runtimes. And similarly, it shouldn't become a vanity metric. A lot of us are talking about it as a badge of honor, and it's definitely been exciting to see in the last few months that many of us broke the barrier of running several hours in a row. But I think in terms of how to build agents that are going to be more powerful and more steerable in the future, we kind of have to change a bit the target, the metric that we keep in mind. So think about it in this way. Tasks have a natural level of complexity. And basically, what we care about is that they have a minimum irreducible amount of work that they express. What agents do is that they always go through this loop of planning, implementing, and testing. And of course, to make this happen and to make it work correctly, you want this work to be happening over a long querying trajectory. So our goal is to maximize the reducible runtime of the agent. By reducible, I mean having a span of time where the user doesn't have to make any technical decisions, and the agent can accomplish the task, again, in full autonomy. This is especially important for us because I can't trust our users to make technical decisions, so they need a proper technical collaborator by their side. I want to abstract away as much complexity as possible from the process of software creation. And last but not least, I want the users to feel in control of what they're creating without stifling their creativity, because they have also to think about the technical decision that the agent is making. So now, what are the pillars of autonomy? How are we making this happen? I would say there are 3 pillars that are extremely important to think about. The first one is, of course, the capabilities of frontier models, like the baseline IQ that we inject in the main agentic loop. I'm going to leave this as an exercise to the reader and to other people in the room. I'm really glad that a lot of you are building amazing models that we use all the time at Replit. So this is the pillar number 1. The second pillar is verification. It's very important that we test for local correctness of our agent at every step that it takes. And the reason is fairly intuitive. If you're building on very shaky foundations, eventually the castle will topple down. So we brought verification in the loop to make sure that, in a sense, we are adding nines of reliability. We're avoiding the compounding errors that an agent will make unavoidably if you don't put any control on it. And last but not least, you heard it on stage even earlier. I'm sure you're going to be hearing this the entire day or the entire duration of the conference, the importance of context management. So on one hand, you want to have an agent that is capable of being globally coherent, so it's aligned with the intent of the user, the expectation of the user. But at the same time, it is also to be capable of managing both the high-level goal and the single task that the agent is working on. I think we made amazing progress in the last months on context management, but I'm also excited to see where we're going as a field. Let's start from the first pillar that we work actively at Replit, which is verification. So why did we focus on this? Over the last year, we realized something that I think each one of you has experienced. So without testing, agents build a lot of painted doors. In our case, the painted doors are very visible because we create a lot of web applications. So you end up basically trying to click on a button and the handler is not hooked up, or some of the data that we're showing is actually mock data and it's not coming from a database. But in general, this phenomenon spans across every type of component you're building, being it front end or back end. A lot of components are actually not fully fleshed by the agent. So we ran some evaluations internally. We found out that more than 30% of the individual features happen to be broken. The first time that are cooked by the agent. And that also means that almost every application has at least one broken feature or painted door. They're hard to find. The reason is users are not going to spend time testing every single button, every single field. And this is also probably one of the reasons why a lot of our users, especially the non-technical ones, still can't trust coding agents very much. They are shocked when they find that there is a painted door out there. So how do we solve this problem? fundamentally, we need an agent must gather all the feedback that they need from their environment, right? It's easier said than done. Again, non-technical users not only cannot make technical decisions, but also they cannot provide the technical feedback that an agent is required to make progress. And most what they can do is basic quality assurance testing. They can literally go around the UI, click, interact with the application. I'm sure you have tried it in your life. This is extremely tedious to do, and it leads to a very bad user experience. And even though we relied on that with our first release of the agent last year, quickly we found out that users don't want to spend time doing testing. So we had to find a complete orthogonal solution to that, which is autonomous testing. And it solves several different issues. The first one is it breaks the feedback bottleneck. Even if, again, we ask feedback to the user, we were not given enough of that. Now we don't have to wait anymore for human feedback. We have a way to elicit as much information as possible from the app autonomously. We also want to prevent the accumulation of small errors. What I was saying before, we don't want to have compounding errors while the agent is building. And last but not least, we have to overcome the laziness of frontier models. So we need to verify that whenever a model tells us that a task has been completed, that is actually the truth, and that result is not being hallucinated. There is a wide spectrum of code verification that you can accomplish. I think we all started from the very left. You have basic static code analysis with LSPs. We have been executing the code since we had basic LLMs that were capable of debugging, and then we slowly started to move towards the right. So generating unit tests and running them. It has a limitation. It's limited only to functional correctness. Unit testing is not very powerful to do proper integration testing by definition. We started also to do now API testing, but it's only limited to API code. So you can test endpoint of an application. You can't really test how a web app functions and looks like. And for this reason, in the last few months, Haas and other companies are pouring a lot of effort in really creating autonomous testing based on the browser, in case the app that we're building is a web application. There are two main categories here. One is computer use. It's a one-to-one mapping with user interface, so the model is directly interacting with the application. It requires screenshots. It tends to be fairly expensive and fairly slow. I'm sure you tested it yourself. A good way in the middle is browser use, where we simulate the user interface. You can then interact with the browser and with the web application, and it relies on basically accessing the DOM through abstractions. So how do we make this work in Replit? What we do is that we generate applications that are amenable to testing, and we sort of merge everything together from the previous slides that I showed you. So we allow our testing agent to interact with an application and gather screenshots in case nothing else works. So we have a fallback to computer use. But the vast majority of times, what we do is that we have programmatic interactions with the applications. So we interact with the database, we read the logs, we do API calls, we literally click on the app and get back all the information that we need. And by putting all of this together, we collect enough feedback that allows our agent both to make progress and also to fix all the painted doors that it encounters. Just a short technical deep dive on how we accomplish this. I'm sure you have seen a lot of the tool-based browser use. There are amazing libraries out there. First one that comes to my mind is Agent. And the idea is that you have an agent that has a few very generic tools exposed. So the agent can create a new tab, can click, can fill forms, et cetera, et cetera. The limitation here is that it's difficult to enumerate all the different types of interactions you could be having with a browser. The problem of testing is very similar to the Tesla analogy I was making before. Maybe this cardinality of tools available is enough for 99% of the interaction types, but then there is always a long tail of idiosyncratic interactions that a user makes with a web application that are hard to map into these different tool calls. So what we do in our case at Replit is we directly write playwright code. And playwright code is, first of all, very amenable for LLMs. LLMs are kind of amazing at writing playwright. This is the experience that we had since we started to work on this project. It's also very powerful and expressive. So in a sense, it's a superset of what you can express compared to the left on the tools testing. And last but not least, there is beauty in creating playwright code because you can reuse those tests. The moment you write a testing script, then you can rerun it as many times as you want. So in a sense, the moment you created a test, you're also creating a regression test suite that you can keep running in the future. And all these kind of tricks that I explained to you right now, they helped us to create something that is roughly a order of magnitude cheaper and faster compared to computer use. And we'll go back later on how important latency is. The second thing, the second pillar that I wanted to talk about today, of course, is context management. And I'm going to go very fast here because I think you're going to be hearing a lot of talks today about it. The high-level message here is that long context models are not needed to work on coherent long trajectories. From experience, we found that most of the tasks, even the more ambitious one, can be accomplished within the 200,000 tokens. So we're still not in a world where working with models that have 10 million or 100 million context windows is necessary to actually run autonomous agents. And we accomplish this by means of learning how to do context management correctly. So first of all, there are several different ways to maintain state which don't imply chucking all the state into your context window. You can do that, for example, by using the code base itself to maintain state. So you can write documentation while the agent is creating new code. You can also include the plan description and all the different task lists that the agent is working on. You can persist them on the file system. So even there, like, have a lot of ways to offload your memories. And last but not least, and this is something I think Anthropic has been really evangelizing about, you can even dump directly your memories in the file system and then making sure that your agent decides when to write them back the moment they become relevant to your work. So for this reason, we have been seeing a lot of announcements in the last couple of months. Just pick this one from Anthropic, with Claude Sonnet 4.7, so I wish 4.5, they've been able to run focus tasks for more than 30 hours in a row. We have seen similar results from OpenAI on the math problems. So I think we kind of broke the barrier of running for long and being able to have coherent tasks. I would say the key ingredient to make this happen has been how good models and us as agent builders have become in doing sub-agent orchestration. Sub-agents basically work by means of they are invoked in the core loop. So it's starting from a blank slate, from a completely fresh context. You as an agent builder decide what subset of the context to inject when the sub-agent starts. And it's a concept that is very similar, I think, to everyone who's been writing software in the last decades. It's separation of concerns. So you decide what your sub-agent is going to be working on. You give it the least possible amount of context. You allow it to run to completion. You only get the output, the results. You inject them back into the main loop, and you keep running in this way. Of course, it significantly improves the number of memories per compression. I just brought this plot directly from Replit agent running in production. The moment we kicked in our new sub-agent orchestrator, on the y-axis, you can see the number of memories per compression. So we went from roughly 35 to 45, 50 recently. So big improvement in terms of how often we are recompressing our context, just because we can offload a lot of the context pollution by means of using sub-agents. I'm going to give an example where this made the difference for us. What I'm showing you here is more kind of a cost optimization, in a sense. Like, you're compressing less. You also have separation of concerns, which definitely make your agent a bit smarter. In the case of testing, working with sub-agent was almost mandatory for us. And basically, we started to work on automated testing even before we were very advanced in terms of sub-agent orchestration. And what we found out is, of course, again, as I was saying before, it makes things easier, better cost, less pollution. But when you allow the main loop not only to create code, but also to do browser actions, to put back the observation of your browser actions into the main loop, you tend to confuse the agent loop very much. Because at this point, there is a lot of heterogeneity in terms of the action that your main loop is looking at. So in order to make this work, not only we have to build all the playwright framework that I was showing to you before, but we also have to move our entire architecture into sub-agents. So at this point, you can see very clearly why there is a separation of concern here. You have the main agent loop running. We decide at a certain point that it's time to verify if the output of the agent has been correct. We make this happen all within a sub-agent. Then we scratch the context window of that sub-agent. We just return back the last observation to the agent loop, and then we keep running in that way. So if you're having issues today, making your sub-agents work correctly, this is one of the reasons why that you want to take a look at. So I think we covered the high level of how to create more and more powerful autonomous agents over time, and I only see us as a field becoming even more proficient than that in the next months. There is one additional ingredient, though, that is going to make the difference, and it's parallelism. And I would argue that parallelism is important not because it's going to make agents more powerful per se, but rather because it's going to make the user experience more exciting. So, of course, it is great to have an agent that is capable of running autonomously for long, but at the same time, it comes with the price of making the user experience less thrilling. You are not in the zone anymore. What you do is that you write a very long prompt, it's translated into a task list, and then you go to have lunch with your colleagues, and then you come back and you hope that the agent is done. That is not the kind of experience that most of the productive people want to have in life. You want to see as much work as done as possible in the shortest span of time. So what we do as a field at this point has been to create parallel agents. It's a very common trade-off, which, by the way, doesn't only apply to agents, it applies to computing in general. And for parallel agents, what you do is that you trade off basically extra compute in exchange for time. Why there is this trade-off? So first of all, when you're running agents in parallel, you're gathering the same context in multiple context windows. So every single parallel agent that you will be running probably shares, say, 80% of the context across the board. So of course, you are just putting more compute at work because you're running those agents in parallel. There is also another cost that is kind of intangible for a lot of you here in the room, because I'm sure you're all expert software developers, but what do you do with the output of multiple parallel agents at the end? Oftentimes, you need to resolve merge conflicts. So as a reminder, my users don't even know what's the concept of merge conflicts. It's something that I have to figure out on our own. So the current way in which we think of parallel agents in this space doesn't really apply to Replit. Now, at the same time, I still want to very much to accomplish this. There are so many interesting features that you can enable with parallelism. Aside from the fact that you can get more work done, at times you want testing to be running in parallel with the agent that creates code. Testing, no matter how much we optimize it, is still very slow. If an agent is only spending time on testing, users are not going to be engaging with your application anymore. At the same time, it's also great to have a synchronous process running while your agent is running, because you can inject useful information back into the main core loop. And last but not least, this is a very common technique that we know boosts performance. If you have enough budget to do so, you should be sampling multiple trajectories at the same time. So a lot of perks are coming with parallel agents, but the way in which we implement them today, which I basically call user as an orchestrator, is the fact that the parallel tasks that you want to run are determined by you, by the user. And each task is dispatched in its own thread. So there is a bit of manual process. Even the task decomposition, in a sense, is happening in your mind while you're thinking about which agents you want to run. And then the moment you get back all the results, you need to go through the problem of merge conflicts. And oftentimes, this is not trivial at all, no matter how many amazing tools are out there. So what we're working on today for our next version of the agent is having the core loop as the orchestrator. So the key difference here is the fact that the subtasks that we're going to be working on are not determined by the user, but they're determined by the core agent loop. And the parallelism is basically decided on the fly. The agent does the task decomposition on behalf of the user. And this comes with a couple of advantages. First of all, again, there is no cognitive burden for the user to understand how they should be decomposing the task. At the same time, also, there are ways in which you can create tasks that sort of mitigate the problem of merge conflicts. I'm not claiming that we're going to be able to mitigate it 100%. There are so many corner cases in which merge conflict will still represent a problem. But there are a lot of different techniques known in software engineering to make sure that you can try to have multiple sub-agents not stepping on each other's toes. So the core loop as an orchestrator is going to be our main bet for the next few months. And in case you're passionate about these topics, I'm always hiring at Replit. Thank you.
From transforming support tickets into merge requests to helping teams ship fixes faster than ever, our next presenter has been at the center of Zapier's AI agent journey. Please welcome engineering leader, Lisa Orr.
Hello. I'm so excited to tell you about how at Zapier, we are empowering our support team to ship code. Before I tell you about that, has anybody here visited the Grand Canyon? It's a good amount. Anybody rafted through the Grand Canyon? I see one person. I just got off an 18-day trip rafting through the Grand Canyon over 200 miles. It was incredible. No internet, no cell service. The moment I got off, I found out I was giving this talk. I didn't think about work at all on the river, but once I got off, I started thinking about the parallels between the Grand Canyon and Zapier, and we have one thing in common, and that is erosion. Now, natural erosion happens over millions of years with wind, water, and time. It creates the beautiful canyon that we experience, and it's never stopping, always continuing. At Zapier, we have over 8,000 integrations built on third-party APIs, and they are constantly changing, which I'm now thinking of as app erosion. We've been around for 14 years. Some of our apps are that old. API changes and deprecations impact us and create reliability issues. Again, it never stops. So I like to think of our apps as like layers in the Grand Canyon, and they need constant attention. So if we were to create our own Zapier Canyon, and our apps would be at the walls, here's our support team flowing down the middle, watching out for app erosion, and we have a backlog crisis. Tickets were coming in faster than we could handle them. Creates integration reliability issues, poor customer experience, and even churn. So to solve for app erosion, we kicked off 2 parallel experiments. The first was moving support from just triaging to also fixing these bugs. It's experiment number 1. Experiment number 2, we were asking, can AI help solve app erosion faster? So let's jump into experiment 1. This got kicked off 2 years ago, but had to start with the why. We needed to get that buy-in to empower our support team to ship code. So app erosion is one of the major sources of bugs coming through from support to engineering. So there's a big need. Support is eager for this experience. A lot of them want to go into engineering eventually. And unofficially, many support members were already helping to maintain our apps. This moves us into how we started this out. Put on some guardrails. We started with just 4 target apps to focus our fixes on. Engineering was set to review any merge requests coming from support, and we kept the focus on app fixes. So jumping into experiment 2, this is what I've been leading for the last couple of years. How can we use code gen to help solve for app erosion? And so fortuitously, the name of this project is Scout, which ties in so well to the Grand Canyon experience that I've just been through. As any good product manager, we start with discovery. We did some dog fooding, so I shipped some app fixes. We shadowed engineers and support team members as they were going through the app fix process. We designed out what are the pain points experienced along the way, what are the phases of the work, and how much time is spent. One big discovery we had is how much time is spent gathering the context, going to the third-party API docs, even crawling the internet, looking for information about a bug that's emerging. Maybe somebody else has already discovered and solved for it outside of Zapier. Internal context, logs. All of this is a lot of context to go and search for as a human, and a lot to grok and work through. This is something we knew we needed to solve for. Where we started with all this great opportunities and pain points is we started building APIs that we believed would solve for these individual pain points. And some of these APIs are using LLMs to for our diagnosis tool, gathering all that context on behalf of the support person engineer and curating that context, building a diagnosis that's using an LLM. And then some aren't, like we have a unit test generator is, but the test case finder is simply using a search query to look for the right test cases to pull in for your unit test. We built a bunch of APIs. We had a bunch of great ideas. So there was a lot for us to test with, but we ran into some challenges in this first phase. We had APIs, but they were not embedded into our engineers' process. So our tool, I just said, they don't like to go to so many web pages to find all their context. They would love all this information to come to them. And yet our web interface, where we've created a playground we call AutoCode internally, where you can come and play around with our APIs. And our ask to the teams was, come try out our APIs and give us feedback. Now, this is just one more window to go to, so we didn't get a lot of engagement. Also, because we had shipped so many APIs, our team was spread pretty thin. Cursor launched at the same time, which has gotten great adoption at Zapier. We're all huge fans of Cursor. But from our side, it made some of our tools no longer necessary. But there was one major win in this phase, which is one of our APIs became a support darling. It's diagnosis, that number one pain point of needing to go out and find all of your context, curate it for yourself so you can start solving the problem. We were doing that on the support team's behalf with the diagnosis API. And support loved it enough that they decided to embed it into their process. They asked us to build a Zapier integration on our AutoCode APIs so they could embed it into their Zap that creates the JIRA ticket from the support issue. And now diagnosis is included. So embedding tools is the key to usage, as we find out. So how can we embed more of our tools? Well, then MCP spins up, and that solves our problem. We can now embed these API tools into our engineers' workflow. Specifically, our engineers are pulling in these MCP tools as they're using Cursor. Our builders using Scout MCP tools are leaving the IDE less, spending more time in one window. Still coming into challenges. One of our key tool, diagnosis, is so valuable to pull all that context and to provide a recommendation, but it takes a long time to run. Now, we might run down that runtime. However, as you're working synchronously on a ticket in your IDE, this was frustrating. We also weren't keeping up with the customization needs. Not only did MCP launch, and we started leveraging it, Zapier MCP launched too. And some of our tools, if we weren't keeping up with the customization needs, our engineers internally looked to Zapier MCP, which is great. We're all on the same team, solving the same problem, but some of our tools had a dead end. Also, adoption was scattered. We had a whole suite of tools, and we thought there was value in each of them as it solves for different problems across the different stages. Not every engineer was using our tools, and if they were using our tools, they're only using a few of them. So we have tool usage, we're happy about that, but we were under the hypothesis that true value is going to come from tying these tools together. So what if we owned orchestration of these tools? Rather than saying, here's a suite of tools, you use them as you wish, what if we combined them and created an agent to orchestrate this? So this we are calling Scout Agent. We take that diagnosis, run that against a ticket, use that information to actually spin up a code gen tool, which will then produce a merge request using all the right context. So who would benefit the most from orchestration? There are several integration teams at Zapier who are solving for these app fixes of various levels of complexity, and there's the support team. So when we're saying, who should be our first customer of Scout Agent, we were thinking, it should probably be the team fielding small bugs that are emergent and coming hot off the queue, which is the support team. And now our two experiments merge. And we have Scout Agent we are building for the support team. And this is the flow of how it works. Support is submitting an issue to Scout Agent. We first categorize the issue. We next assess its fixability. Not every issue that comes from support can be fixed. If we think it's fixable, we'll move on to generating a merge request. At that point, the support team, this is the first time they're picking up the ticket, it already has a merge request attached to it. They'll review and test. If it's not satisfying what they believe is the actual solution, or what the solution should be to best address the customer's need, they will make a request for an adjustment. That can happen right in GitLab, which is where we do our work. And Scout will do another pass. And hopefully at that point, we've gotten it right, and support can submit that MR for review from engineering. How we are running Scout. It's all kicked off by a Zap. This is a picture of one of our Zaps. There are many Zaps that run this whole process, and it embeds right into our support team's Zaps. We do a ton of dog fooding at Zapier. We first run diagnosis and post that result to the JIRA ticket, saying what the categorization is, if we believe it's fixable. And then if we do believe it's fixable, we then are kicking off a GitLab CI/CD pipeline, and we run 3 phases in that pipeline: plan, execute, and validate to generate this merge request. The tools used in this pipeline is Scout MCP. So all those APIs we invested in a year ago now are really coming together, and we're orchestrating it within the GitLab pipeline. And we're also leveraging Cursor SDK. Once the merge request has been completed, we attach it to Jira, and support picks it up. The latest addition to this is doing a rapid iteration once a ticket has been posted with the merge request and support team is looking at it, and they say, you know, it needs some tweaks. To save them more time so they don't have to go pull that down to their IDE, do the fixes, and push it back up, they can simply chat with the Scout agent in GitLab. That'll kick off another pipeline, which does that phase with that new feedback and posts the new merge request. On our side, we want to make sure Scout Agent is working, so we ask 3 questions. Is the categorization right? Was it actually fixable? And was the code fix accurate? So far, we have 2 evals, 70 to 75% accuracy for categorization and fixability. As we get more feedback and process more tickets, those become our test cases, and we can move forward improving Scout Agent over time. So what has been Scout Agent's impact on app erosion? 40% of support teams' app fixes are being generated by Scout. So we're doing more of the work on behalf of the support team. This is resulting, and for some of our support team, it's doubling their velocity from 1 to 2 tickets per week, which already is amazing. That's going from a support team that wasn't shipping any fixes, well, unofficially they were sometimes, to now shipping 1 to 2 per week per person, to now shipping 3 to 4 with the help of Scout. Another process improvement, Scout puts potentially fixable tickets right there in the triage flow, takes away a lot of the friction of looking for something to grab from the backlog. It's not just the support who's benefiting, it's also engineering. Engineering manager said, it's a great example of when it works, this tool allows us to stay focused on the more complex stuff. And if you take away anything from this talk, I hope it is that there is a really powerful magic between support and empowering them with code gen and allowing them to ship fixes, because they have 3 superpowers. The first, they are the closest to customer pain, which means that they're closest to the context that really matters for figuring out what's the problem and how to solve it. They're also troubleshooting in real time. These tickets aren't stale, the context is fresh, the logs aren't missing. You put this ticket into an engineering backlog months later, you might not get access to those logs anymore. And then 3, they're best at validation. You put the same ticket into an engineering backlog, the solution an engineer might come up with may change the behavior, and that might be good for some customers, but might not necessarily be best for that one customer who wrote in about the problem. And one other major benefit of this is support team members who have been part of this experiment are now engineers. I want to say thank you to the amazing team who's helped build this process or build all the tools and the Scout agent. Andy is actually here in the audience, so shout out to Andy. If you want to talk about any of the technical bits, he's here. And I want to impress upon you two things. We're hiring, but mostly if you haven't rafted through the Grand Canyon, please consider it. It's life-changing, and you should go with oars. Thank you very much.
Our next presenters believe that 2026 is the year the IDE died. Please join me in welcoming to the stage engineering leader at SourceGraph and AMP, Steve Yegge, and author and researcher at IT Revolution, Jean Kim.
Hey everybody, really happy to be here. I'm going to be talking the first half. Co-author here, Jean Kim, is going to talk the second half. All right, looking forward to it. Cheers. All right, today we're going to talk real fast. This time's going to go down fast. I'm going to talk to you about what tools look like next year. Last year, I was talking to you all about chat, and everybody ignored me, and now everybody's using chat this year, and it's like, we're going to fix that right now. All right, so here's what it's looked like. I'm going to tell you right now, everyone's in love with Claude Code. There's probably 40 competitors out there. Claude Code ain't it. Completions wasn't it. I love Claude Code. I use it 14 hours a day. I mean, come on. But it ain't it. Developers aren't adopting it. I'm going to talk about why in this talk. I'm going to talk about what you can do about it and what to look forward to. But the reason is they're too hard, okay? Cognitive overhead, they lie, cheat, and steal. Gene and I talk a lot about this in our book, all the different ways that they can lie, cheat, and steal, and most devs just don't like this. I have come to understand that Claude Code is very much like a drill or a saw, an electric one, right? How much damage can you do as an untrained person with a drill, right? Or a saw, yeah? How much damage can you do as an untrained engineer with Claude Code? It's real similar, yeah? You can cut your foot off. But you can also be really, really skilled with it and do really precision work, right? Like a craftsman. The problem is software is infinitely large. Our ambition is infinitely large. And so the analogy that I want to share with you is next year will be the year from moving from saws and drills to CNC machines. A CNC machine, you strap a drill on and you give it coordinates and it moves it around and you're very precise, right? We've been doing this for centuries and we're not going to stop this year. One thing I hear people say is, well, the models are plateaued. This is real common. Your engineers are probably saying this, okay? Even if they plateaued, we have still discovered steam and electricity, and it's going to take us a little time to harness it, but it's strictly an engineering problem at this point. All code within a year, year and a half, will be written by giant grinding machines overseen by engineers who no longer actually look at the code directly anymore. Weird new world, that is where we are going. Oh my gosh, yeah, this slide. So Gene and I talked to Andrew Glover, who, I don't know, is he here, from OpenAI, and he said that they have this incredible dichotomy unfolding at OpenAI where, some percentage of their engineers are using Codex, and then some other percentage, a larger percentage, are not using Codex. And the difference in productivity is so staggering that they're having now alarms going off at performance review time, because how do you compare these two engineers who are the same level, same title, same everything, and one of them is 10 times as productive as the other one by any measure? And the answer is they're freaking out and they may have to fire 50% of their engineers. And this is unfolding at other companies too. Who is refusing it? It's the senior and staff engineers. How many minutes are we at?
8 minutes.
We're perfect. This is just like what happened to the Swiss mechanical watch industry over a couple of, it was built up for a couple of centuries, and then quartz killed it, within a couple of years. And what happened was the craftsmen were doing the same thing our staff engineers are doing today. No, that's word for word, right? That's what they say. All right. I didn't know where to put this slide. This is Claude's view of what next year looks like. And I was just like, what do you think it's going to look like? And it actually does kind of look like this. Most of the words will be spelled correctly in next year. But this is a lot prettier than Claude Code. Yeah? This is what it has to look like, some form of a UI. Not an IDE. This is the new IDE, okay? And people are building it. In fact, I think the company that's the furthest along in this is Replit, who just talked to you. I think it's amazing what they're doing. It's absolutely bravo, right? We should not be all chasing taillights and building command line interfaces anymore, all right? And more importantly, Claude Code and all of its, competitors, they're all doing it wrong because they're building the world's biggest ant. Okay, this is my buddy Brendan Hopper at Commonwealth Bank of Australia, right? He's like, nature builds ant swarms, and Claude Code built this huge muscular ant that's just gonna bite you in half and take all your resources, right? I mean, it's a serious problem, right? If I say, please analyze this code base, go to the expensive model. If I say, is my git ignore file still there? I've also gone to the expensive model, right? Everything that you say goes to the expensive model. So what's gonna happen? Whoa, what happened? Oh gosh. My slides are all messed up now. Can you guys see him?
No.
Oh, this always happens to me, man. There's something going on. All right, so I thought of a really cool analogy called the diver metaphor, which is your context window is like an oxygen tank, okay? This is why these things are fundamentally wrong, because you're sending a diver down into your code base underwater to swim around and take care of stuff for you. One diver. And we're like, we're gonna give him a bigger tank, 1 million tokens. He's still gonna run out of oxygen. Like you should send a product manager diver down first, and then a coding diver, right? And then a review diver and a test diver and a git merge diver, etc. Right? Nobody's doing this. Everyone's building a bigger diver. I don't know, my slides are all messed up. My talk is almost done. But what we do is, as engineers, task decomposition, successive refinement, components, black boxes. This is how it's going to be built in the future, and it's going to be built with lots and lots of agents, not just one agent. All right, until then, I think we're out of time. So until then, learn Claude Code, give up your IDE. Swix told me he wants some hot takes, so I'll give you one. If you're using an IDE starting on, I'll give you till January 1st, you're a bad engineer. There's your hot take. All right, folks. All right, cheers. Well, that was actually my talk. Learn coding agents, and oh yeah, then there's this guy. Speaking of bad engineers, so this is Jordan Hubbard, who's at NVIDIA, and he tweeted, or LinkedIn, he did a really nice post on how to get the most out of agents, and this guy responded with this, right? This is everyone in your org, this is 60% of your org right here. This guy's not an outlier. Okay, the backlash is very real against this, yeah? And this is gonna be a problem. I'm not gonna share it with you. I don't have time to share how to fix it, but it's something you should be aware of. And anyway, I'm gonna turn it over to my co-author, Gene. We had a lot to talk about. He's got a lot to go, so let's turn it over to Gene.
Yeah, thank you, Steve.
All right, buddy.
Yeah, by the way, let me start off by introducing myself, and then I'm gonna share a little bit about what it's been working like, what's been like working with Steve on the Vibe coding book. And so just a little bit about myself. I've had the privilege of studying high-performing technology organizations for 26 years, and that was a journey that started when I was a technical founder of a company called Tripwire. I was there for 13 years. But our mission was really to understand these amazing, high-performing technology organizations. They had the best project due date performance and development, the best operational reliability and stability, and also the best posture of compliance, security and compliance. So we wanted to understand, how did those amazing organizations make their good to great transformation, so we could understand how do other organizations replicate those amazing outcomes? And so you can imagine in that 26-year journey, there are many surprises. Among the biggest surprises was how it took me into the middle of the DevOps movement, which is so amazing because it reshaped technology organizations. It changed how tests and operations worked, information security. And I thought that would be the most exciting adventure I'd be on in my career, until I met Steve Yegge in person. And so I've admired his work for over 11 years. And so some of you may have read this memo of Jeff Bezos' most audacious memo of how in the early 2000s they transformed from a gigantic monolith that coupled 3,500 engineers together, so none of them had independence of action. And he talked about how all teams must henceforth communicate and coordinate only through APIs. No backdoors allowed, right? Anyone who doesn't do this will be fired. Thank you and have a nice day. And the amazing person who chronicled said number 7 is obviously a joke because Bezos doesn't care whether you have a good day or not. And this is actually enforced by Amazon CIO then Rick Dalzell. And so it turns out this memo that I've been quoting for 11 years was written by Steve Yegge, which was meant to be a private memo on Google+, which was made public, which landed him on the front page of the Wall Street Journal. And so I finally met him in June. And it turns out that we had many things in common, but one of them was this love of AI and this sense that AI was going to shape coding from underneath us. And so one of our beliefs is that the AI will reshape technology organizations, maybe even 100 times larger than what Agile, Cloud, CI/CD, and mobile did 10 years ago. And that these technology breakthroughs not just reshape organizations, but they reshape the entire economy. The entire economy rearranges itself to take advantages of these wild new, better ways of producing things. And so over the last year and a half, we've had a chance to look at these case studies that I think give us a glimpse of what the shape of technology organizations look like. And so I'm going to share with that what we've learned. But here's maybe a hint. So some of you may know the work of Aidan Cockcroft. He was a cloud architect at Netflix, right? He was who drove the entire Netflix infrastructure from a data center back in 2009 to running entirely in the AWS cloud. And so he wrote some months ago in 2011, some people got very upset in infrastructure and operations because they called it no-ops, right? And everyone laughed back then, but he said, oh, don't, it's happening again. This time it might be called no-dev, right? Not so funny now, right? And so it's interesting, right? Because we heard this amazing presentation from Zapier about how support ships, and it turns out designers are shipping, UX is shipping, right? Anyone who's been frustrated by developers who say get in line and you have to wait quarters or years or maybe never, right, are now suddenly in a position where you can actually vibe code your own features into production, right? And that reshapes technology organizations and it reshapes potentially the entire economy. And so Steve and I, we've had the privilege of watching what happens when we change the way we deploy, right? It wasn't so long ago, and 10 years ago, I wrote a book called The Phoenix Project, where it was all about the catastrophic deployment. Would you believe that it was, 10 years ago, 15 years ago, most organizations shipped once a year, right? And so I got to work on a project called the State of DevOps Research. It was a cross-population study that spanned 36,000 respondents from 2013 to 2019. And what we found, this was Dr. Nicole Forsgren and Jez Humble, and what we found was that these high performers ship multiple times a day, right? They can ship in 1 hour or less. And back in 2009, people thought, oh my gosh, multiple deployments per day, right? That's reckless and irresponsible, maybe even immoral, right? What sort of maniac would deploy multiple times a day, right? And yet, it's very commonplace these days. In fact, if you want to have great reliability profiles, if you want to have short mean time to repair, you have to do smaller deployments more frequently. And I think we're now seeing these kind of case studies that show that this better way of coding, right, where you don't type in code by hand, might be just a vastly better way to create value. And so our definition of vibe coding that we put into the vibe coding book was that it's basically anything where you don't type in code by hand. And so for some of you who don't understand that, that's like sort of typing an ID hunched over, right, and you're actually moving your fingers, right? That's sort of like how some people go into a darkroom to develop photographs, right? Believe it or not, some people still do that. And that's a great definition that we loved until Dario Amodei, CEO and co-founder of Anthropic, he gave us an even better definition, right? Vibe coding is really the iterative conversation that results in AI writing your code. And he said it's on one hand a beautiful term because it evokes this different way of coding, but he said it's also somewhat misleading because it sounds jokey, right? But he said, at Anthropic, there's no other game in town, right? And I just thought that was just a beautiful way to evoke, how important vibe coding is. This is Dr. Eric Meyer. He's probably considered one of the greatest programming language designers of all time. He was part of Visual Basic, C#, LINQ, Haskell. He created the Hack programming language that migrated millions of lines of code at Meta within a year, bringing static type checking to a bunch of PHP programmers. And he said, we are probably going to be the last generation of developers to write code by hand. So let's have fun doing it. So one of the things that when Steve and I started working on the book last November was watching him spend hundreds of dollars a day on coding agents, and it just seemed so strange, right? And so he's maxing out not just the monthly subscriptions, right? But he's actually going way above and beyond that. And yet, things that we're hearing now is that as an engineer, part of my job is that I need to be spending as much on tokens per day as my salary, right? So let's think about like $500 to $1,000 a day. right? Because this is the mechanical advantage, or the cognitive advantage that these tools are giving us, right? And as an engineer, right, I'm going to challenge myself, to get that kind of value, to deliver value to people who matter. And so in the book, we talk about, why people would do this, right? And the acronym we came up with, FAFO, right? The most obvious one is F for faster, right? That's obviously true, but I think it's the most superficial and part of why we do this, because the second one is it lets us do more ambitious things, right? The impossible becomes possible. So that's one end of the spectrum. On the other end of the spectrum, the tedious and small tasks become free. One of the things the interview of the Claude Code team that I just loved was, I think it was Catherine, she said, one of the things we've noticed is that, when customer issues come up, instead of putting them on a Jira backlog and, arguing about it in the grooming sessions and so forth, right, we just fix it on the spot, right, and ship to production or whatever, within 30 minutes. Right? And so yes, it gets recorded, but that whole sort of coordination cost, just disappears, right? So again, the impossible becomes possible, right? And the annoying things just become free. The second A is the ability to do things alone or more autonomously, right? And so there's really two coordination costs that are being alleviated here. One is if you ever have to wait for a developer or a team of developers, to do what you need to do. Right? You have to communicate and coordinate and synchronize and prioritize and cajole and escalate, do all sorts of things to get them to care about the problem just as much as you do, right? And now, with these amazing new miraculous technologies, you can do them by yourself, right? So that's one coordination tax. The other one is like, even if you get someone to care about a problem as much as you, they can't read your mind, right? And what we're finding is that these LLMs are just amazing intermediation vehicles, right? Just through an LLM, you can coordinate with other functional specialties, right, through a markdown file, right? And that's not the end, right? But it's just this amazing way to have these high bandwidth coordinations so that you can essentially read each other's minds, because shared outcomes require shared goals and shared understanding. The second F is fun, right? As Steve says, vibe coding is addictive. This is so true. I mean, I think what I love about the book is that it's a story about two guys who both thought their best days of coding were behind them, right, and found that it's entirely the opposite. And I've had so much fun, and I'm having to force myself to go to sleep at night because otherwise I'd be up till 2 or 3 in the morning every night. So it's not all great, but it certainly beats being boring or tedious or horrible. And then optionality. One of the things that I love about Swix is that he has a shared love of creating option value. He told us last night that option value is also important for poker players, right? Because you never want to paint yourself in a corner. So option value is one of the biggest creators of economic value, right? Modularity, the reason why it's so powerful is because it creates option value. And so just the fact that you can have so many more swings at bat, you can do so many more parallel experiments, right? This is what vibe coding allows. So this gives us confidence that this is not just, this is a very powerful tool. Here's a quote from Andy Glover that Steve Yegge said, is that, as for people who have this aha moment and are in a position, I think the instinct is how do we elevate everyone's productivity to be as productive as you are now being, since you've had your aha moment. So let me share with you maybe some of our top kind of exciting case studies that kind of give us a hint of the future. So I've run this conference called the Enterprise Technology Leadership Summit for 11 years now. And Swix, we had the honor of having Swix there talking about the rise of the AI engineer, just this amazing prognostication. This year we had a series of amazing case studies. One was Bruno Passos. He spoke last year at this conference. And he presented on their evolving experiment to elevate developer productivity across 3,000 developers. And this is at Booking.com, the world's largest travel agency. And they're finding that they're getting double-digit increase in productivity, right? Merges are going in quicker, peer review times are smaller, and so forth, right? And so that's just, we feel like that's an incomplete view of what people are achieving. This is Sri Balakrishnan. He was head of product and technology at Travelopia. So they're a $1.5 billion a year travel company. And one of the things that he said is that they were able to replace a legacy application in 6 weeks with a very small team. In fact, one of his conclusions is that before we would need a team of 8 people to do something meaningful, right? 6 developers, a UX person, and a product owner. And he said maybe these days it might be 2. A developer and a domain expert. In other words, as Kent Beck said, a person with a problem and a person who can solve it, right? Maybe a pair of those teams, right? And so that's going to reshape, I think, how they can go further and faster. So again, maybe just a hint of what teams will look like in the future. This is the one that excites me most. This is Dr. Topa. He helped drive the DevOps movement at Capital One, and he's now at Fidelity. And so, among other things, he owns an application that is the application you go to ask which applications, the 25,000 applications there, have Log4j. Right, and it's his team, and he's had this vision of what this application should look like. But every time he asks, like, can we build it? His team would say it would take about 5 months, right? And we'd need to hire a front-end person. And he got so frustrated that he spent 5 days just vibe coding it by himself, right? Directly accessing read-only the Neo4j database, and put it into production, right? And so I think we're seeing a world where leaders, even leaders with their own teams, are frustrated, saying, "Hey, I can do this. Can I do this better myself? Not better. Just can I prove that it can be done?" And by the way, what happened afterwards? He was looking around. Who can help me maintain my application in production? And all the senior engineers were like, "Not me." So enter Swathi, the most junior engineer on the team, who is helping maintain this application and probably outlearning everybody in the organization. And interestingly, he's also getting more headcount because the number of consumers of this application just increased by tenfold, right? So who saw that coming, right? Here's John Rouser. He's Senior Director of Engineering at Cisco Security. And he convinces SVP to require 100 of the top leaders inside of Cisco Security to vibe code one feature into production in a quarter. That ended last month, right? And so, we're actually getting a chance to be able to survey those people, right? Who finished? How many completed, didn't complete, partially completed, et cetera. And of those who completed, right, what aha moment did they have? As a leader, what's the magnitude and direction of what they want to do? And so we're going to go in and study that. And my prediction is that we're going to see parts of that organization get reshaped as leaders realize kind of what's possible. Everything from strategy to processes and so forth. And so let me just share with you one thing that really excites me, which is I got a chance to get back into the state of DevOps research, the DORA study with the Google Cloud team. And one of the things that didn't make it into the report that I just found really exciting was around this. It was like, how much do people trust AI? And we're using a very strange definition of trust, which is, to what degree can I predict how the other party will act and react? Right? Because the more you trust the other party, right, you can give them bigger requests, you can use fewer words, you have less need for feedback, right? It's the whole notion of Fingerspitzengefühl, right? Like, how many of the 10,000 hours that it requires to be good at anything have you used to get good at AI? And one of the stunning findings was that it's this line. So on the x-axis is how long have you been using AI tools? Y is how much do you trust it, right? And the longer you use AI, right, the more you trust it, right? So every person who says, I tried it and it's terrible at coding, right, on what basis did they make that conclusion after maybe using it for an hour or two? And what this shows us is that it requires practice, right? And this is probably a teachable skill. So length of time on the x-axis is a very incomplete expression, right? It's like frequency and intensity and how many hours, but there's signal there. So it just shows that part of your job is to help other people have the aha moment and then help them practice, right? So they get very, very good at it so they can use every one of these amazing technologies to achieve their goals. So I'll leave you with one last kind of vision. Steve and I, we did a vibe coding workshop for leaders back 6 weeks ago. And what was amazing to me was in the 3 hours, we had 100% completion rate. Everyone built something. They built a data visualization tool. In fact, one person built an iOS app. Another person actually got it into the review queue in the Apple iOS App Store, right? which is absolutely astonishing. And here's a guy named Roger Safner. He said, I used to be a C# MVP way back in the day. I haven't coded in 15 years. And he's showing off an app that helped him automate the process of getting checked into Southwest Airlines until the bot detection tools cut him off. But look at the expression on his face. And so I think what we're seeing is like what happens when support ships, right? And support codes and ships, when leaders code and ship. There's no doubt in my mind that this will reshape technology organizations. If you're one of those, Steve and I want to talk to you, right? Because you are on the frontier of something really, really important. I'll share with you a couple quotes. Here's from a technology leader. When I told my team that I wrote an app that, an AI wrote 60,000 lines of code and I haven't looked at any of it, they all looked at me as if they wished I were dead. We've had these stupid problems and legacy applications that have been there for over a decade. We got a group of senior engineers together. We used AI to generate a fix, and we submitted PR, and the team accepted it, right? Unlike the time when they said it was AI generated and they rejected it as AI slop, right? So this is maybe happening in your organizations. Our code velocity is so high, we've concluded that we can only have one engineer per repo, right? Because of merge conflicts, right? We haven't figured out the coordination cost mechanism yet. And so like all of these were some of the lessons that went into the Vibe coding book. Thank you for everyone who were at the signing yesterday. And if you're interested in any of the talks we referenced and excerpts of our book, in basically all the links that are in this presentation, just send an email to realgenekim@sendyourslides.com, subject line Vibe, and you'll get an automated response in a minute or two. So with that, Steve and I, thank you for your time, and we were around all week.
Thanks all.
Ladies and gentlemen, please welcome back to the stage, Alex Lieberman.
Let's give it up again for Steve and Jean, and also the rest of the speakers from the morning session. Whether you are watching in person or on YouTube or on the AIE site, you've been breaking a mental sweat, so we are going to take a 30-minute break, get some grub, get some coffee, recharge, and we will see you back here at 11. Thanks, everyone. Appreciate it.
Two flames lit the darkness, burning side by side. Both sworn to a creation, both relentless in their stride. One walked through the mountains, one soared across the void. Both chasing the horizon of the worlds they would deploy. But the path is not a straight line, and the future is not flat. Some roads bend through space-time, and some break on impact. Effort is a kingdom, leverage is the key. One builds the throne by hand, one shapes reality. There is a curvature of time, not a race, not a throne, but a shift in the dimension of how progress becomes known. When the universe is bending to the will inside the mind, you don't win by moving faster, you win by redefining time. Black holes of the past try to drag the present down. Systems built on dust, wearing yesterday as crown. Some are pulled beneath them, fighting gravity alone. Others learn to map the edges and escape event horizons. Not all power is struggle, not all mastery is pain. The ones who change direction rewrite the laws of the game. You can measure life in labor or an impact that compounds. Every second can be linear or worth 1,000 rounds. There is a curvature of time, not a race, not a throne, but a shift in the dimension of how progress becomes known. When the universe is bending to the will inside the mind, you don't win by moving faster, you win by redefining time. The future isn't distant, it accelerates for those who wield the tools of power instead of fighting with their goals. Mastery is leverage, not a sentence carved in stone. The horizon does not move unless you move the throne. There is a curvature of time, where the present multiplies, where a lifetime holds a legacy that no clock can quantify. Not by force, not by fury, but by evolution's design. We become eternal beings when the static in the night it calls. A whisper rising, breaking through the walls. Electric echoes in my veins, they hum, chasing the shadows where the wild ones run. The air is thin, the weight is gone. Close your eyes, the past is done. Free your mind, let it go, let it soar. Break the chains, leave them scattered on the floor. Every board is a spark, let it ignite. Free your mind, step into the waves of color crash against the sky. Fragments of a dream, I see them fly. Gravity's a story, we don't need weather, thunder, we're the speed. The air is thin, the weight is gone. Close your eyes, the past is done. Free your mind, let it go, let it soar. Break the chains, leave them scattered on the floor. Every breath is a spark, let it ignite. Free your mind, step into the They said the stars don't change their course, but I've been running from their force. A mirror cracked, but still it shows. The fire's mine, it's mine to hold. I hear the echoes, they call my name, but I'm not the shadow, I'm not the same. You are who you choose to be, not the scars, not the history. Every breath, every heartbeat free. You are who you choose to be. execute the vision. Vision, no revision. Execute the vision. Heart collides with precision. This is my mission. The air is heavy, it doesn't break. 1,000 whispers in its wake. Each breath a climb, each fall a sign, but I am more than I can take. Close my eyes and feel it burn. Every failure, every turn, it's fuel for the fire inside. Execute the vision. No permission, no revision. Execute the vision. Heart collides with precision. This is my The clock keeps ticking loud and clear. Shadows fade but linger near. I've been waiting for the light, holding breath through endless night. The air is shifting, feel it break. A single spark is all it takes. It starts today. It starts today. No more running, no delay. The world is spinning in my hands. It starts today. It starts today. Footsteps echo on the stone. Every choice I made my own. I see the dawn, it's breaking through. 1,000 colors tracing blue. The air is shifting, feel it break. A single spark is all it takes. It fall, but I won't bow. I've walked through the smoke, I've tasted the scars. Each step I've taken lit up the stars. Let it blaze, let it break. Feel the cracks, the ground will shake. I'm forged in flame, I'm born in heat. The pain, it carved me deep. I rise again. From fire, I'm forged in The winds, they howl, but I stand still. The mountains crumble, I bend my will. I'm not the same I was before. A shadow of fear, I keep no more. Let it blaze, let it break. Feel the cracks, the ground will shake. I'm forged in flame, I'm born in heat. The pain, it carved me deep. I rise again. From fire, I'm forged in A whisper breaks the silent night. Shadows melt in the growing light. Time bends and twists, we feel it start. A pulse, a spark, an open heart. Do you feel it? Feel it rise. The weightless fire in the sky.
Ladies and gentlemen, please welcome back to the stage, Alex Lieberman.
Let's keep it going for the morning speakers. Amazing job from everyone who spoke earlier. I asked before who thought they came from the furthest place on earth to watch this in person. And where's New Zealand again? I don't know. New Zealand, there we go. Bulgaria, still, I think closer than New Zealand, but still very far. Australia via New Zealand. We just got someone to one-up New Zealand. I have another quick question since we just came back from a coffee break. Also, if you're watching live on YouTube, you can comment. Who thinks they're the most caffeinated right now? Who thinks they're the most caffeinated in the room? How many cups of coffee? I'm 4 right now. Anyone beat 4? Oh, we got 4. We got a 5 maybe? Wow, impressive. Well, we are back for an incredible next block of sessions. We're going to be covering everything from future-proofing coding agents to moving away from Agile, how to quantify AI ROI in software engineering, the state of AI code quality, hype versus reality, and Minimax M2. But I am so excited to kick off this next block of talks with OpenAI. Please welcome to the stage Bill Chen and Brian Fioca from the Applied AI team at OpenAI. Let's hear it for them.
Hello, everyone. Today we'll be talking about how to build coding agents. And I'm Bill. I work on the Applied AI startups team at OpenAI.
And I'm Brian. I work with Bill on the OpenAI startups team.
And we specifically focus on building coding agents here at OpenAI. Yeah, so why are we giving this talk? Why are we, talking about coding agents? Well, it's really quite interesting because it's been booming for the past year. Actually, it's just, if you think about it, it's not that much time ago. Like, only been a year or so. The ground keeps shifting, really, under the harness on the coding agents. But if you think about it, it's really like, why it's interesting is because it's really a signal on how close we are to AGI. Software engineering can be set as a universal medium for problem solving. But because the ground is shifting so fast, we kept having to rebuild the agent on top of the model whenever a model is released. And today, we're going to talk a little bit about how we might be able to get around that.
So here's what we're going to go over today. We'll start with the anatomy of a coding agent, especially going into the details of models and harnesses and how they work together. We'll share some lessons that we learned from putting them together ourselves. And we're specifically going to talk about Codex here, which is our own coding agent. We'll talk a little bit about emerging patterns that we're seeing from all of you for using agents like Codex in your own products. And lastly, we'll talk a little bit about what to expect from Codex in the future so that you can build along with us if you want to.
To start, let's talk a little bit about what makes a coding agent an agent as a whole. It really is quite simple. I think people kind of overcomplicate things a little bit these days. It's made out of 3 parts. It's a user interface, it has a model, it's a harness, right? The interface, quite self-explanatory. It could be a computer, like a CLI tool, or it could be an integrated developer environment. It could be also cloud or background agent. Models, also quite self-explanatory, are things like the latest and the greatest, the GPT 5.1 Codex Max that we just released yesterday, or the GPT 5.1 series of models, or other models from other providers as well. And the harness is a little bit more of an interesting part. This is the part that directly interacts with the model. In the most reductive way, you can sort of think of it as a collection of prompts and tools combined in a core agent loop, which provides input and outputs from a model. The last part will be our focus for today. As touched on a bit earlier, coding is one of the most active frontiers in applied AI, and how models are constantly getting released, and we're not making the problem easier for everybody, is that people have to constantly adapt the agents to the new models.
So Bill's done a great job of giving us an overview of coding agents, what they're made up of. So let's zoom in a little bit on the harness. It turns out that's a little bit tricky. So what is a harness? A harness is really the interface layer to the model. It's the surface area the model uses to talk to users and the code and perform actions with tools. It's made up of all of the pieces that the model needs to work over many turns, call tools, and really write code for you and interpret what the user is actually asking. For some, the harness might actually be the special sauce of the product. But as we're going to go into a little bit more, it's really challenging work to build a good harness. And we'll talk about how we did that. So let's see, what are some of these challenges? Just to name a few, AV is one. Your brand new innovative custom tool that you're giving to your agent might not actually be something the model is used to using. It may not have ever seen that tool before in training. And even if it is, you need to spend time tuning your prompt to that particular model and the habits that it comes with. And new models are coming out all of the time. What about latency? Like, does the model take a while to think about certain things? Which things? Do you prompt it not to? How do you expose the UX of what a thinking model is doing while it's thinking? Is it communicating with you while it's thinking, or do you have to summarize it? Managing the context window and compaction can be really challenging. We just launched Codex Max that does that out of the box for you. You don't have to worry about compaction and context window management. It's really hard to do. And so if you were to do it yourself, have fun. And then also, like, the APIs keep changing, right? So we have completions, we have responses, we have whatever else is coming in the future. What does the model know how to use and get the most intelligence out of the box? And so this is the interesting part. Fitting a model into a harness takes a lot of prompting. It turns out that how the model is trained has side effects. I like to think about it this way. Intelligence plus habit. Intelligence. What is the model good at? What languages does it know really well? What is its capabilities in terms of, like, how well it can write code in certain frameworks? And then what habits did it learn to use to solve those problems? We've trained our models to have habits of, like, planning a solution, looking around, gathering context, and thinking about a problem before diving in and writing code, and then testing its work at the end. Developing a feel for these habits is how you become a good prompt engineer. If you don't instruct the model in ways that it's familiar with, you can have problems. We saw this when we launched GPT-5. A lot of people who weren't used to using our models in coding tried to take prompts that existed for other models and put them into their harness and have GPT-5 follow those instructions. And it turned out that we taught our model to do some of the things that the other models didn't really do out of the box. And so when they were prompting them to look really hard at the context and, like, examine every single file before making a code edit, our model was being very kind of thorough about that, and it was taking a really long time. And they weren't seeing the best performance. And so we figured out that if you let the model just do the behaviors that it's used to and don't over-prompt it, it'll actually perform really better. We found out by asking. I was literally like, hey, like, I like the solution, but it took you a long time to get there. What can I do differently in your instructions to help you get there faster next time? And literally it said, you're telling me to go look at everything, and I don't really need to, so that's what's taking forever. And so you can actually see the advantages of building both the model and the harness together because you just, like, know all of that while you're building it. And that's why Codex is both a model and a harness combined. So let's dig deeper into Codex and what it can actually do. So we built Codex to be an agent for everywhere that you code. It's a VS Code plugin. It's a CLI. You can call it in the cloud from the VS Code plugin or from ChatGPT from your phone. At its very basic, you can use it to turn your specs into runnable code, starting from a prompt, having a plan. It navigates your repo to edit files. It runs commands, executes tasks. And you can call it from Slack, or you can have it review PRs in GitHub. So all of the things that you would expect. And that means that that Codex, the harness of Codex, needs to be able to do a lot of really complex things. When I talked to a member of the Codex team about this slide and what should be on it, he was like, it's way harder than you think. You have to manage parallel tool calls, like thread merging, and all of the things involved in that. Think about all of the security considerations you have with sandboxing, prompt forwarding, permissions, port management, compaction is a whole thing. And doing that well is really complex. When do you trigger compaction? When do you re-inject? How do you worry about cache optimization during that? MCP, right? Like all of the plumbing you have to build for MCP support into the harness, and then not even mentioning images and what's the resolution that you need to compress them to send them to the model. All of this is like work that you have to do if you're going to build this from scratch and keep it updated as new features come online. So, since we've bundled all of these features together for you, in an agent that can safely write its own tools to solve new problems that it encounters, oops, we actually have here a computer use agent for the terminal.
Wow, that sounds quite a bit powerful than just plain old coding agent, doesn't it? But just think about it again. Well, before browser and graphic user interface was a thing, wasn't that how we always operated a computer, through writing code and chaining them together in a command line interface? So that means if you can express your tasks in command line as well as files, tasks, Codex will be able to know what to do. The example is I like to use Codex to organize a lot of the photos from my desktop into a folder. And that's a very simple use case. But what it can also do is it can analyze huge amounts of CSV files inside of a folder doing data analysis. It does not have to be a coding task. And if it can be accomplished by running tools from command line, you can use Codex. So now that we see Codex is such a cool harness, I want to also share a little bit about how you can use it to build your own agents. And what you can do is you can use Codex, the agent, inside of your own agent. How does that work? Well, if you want to build the next coding startup, we don't really have all the answers, but we do have a few patterns that we thought might help you, having worked with some of the top coding customers like Cursor and VS Code. One of those patterns is harness becoming the new abstraction layer. The benefits of this is quite obvious. You no longer have to care about optimizing the prompt and tools with every model upgrade.
But does that mean you're just building a wrapper?
Well, I disagree with that take. I disagree. I would disagree with my colleague here. Just like how building wrappers on top of models, I think, is really reductive on the whole value prop of the infrastructure layer.
Sorry, I used to be a VC.
Focusing most of your efforts on differentiating your product is what this pattern allows you to do. And that's where most of the value lies.
Exactly. OK, so let's look at some of these patterns that we've seen and actually have helped our customers build along with them. Codex is an SDK. It can be called through a TypeScript library. You can call it programmatically in a Python exec. There's a GitHub action that you can plug into to have it merge conflicts on PRs that everybody hates doing. Then you can also add it to the agent's SDK and give it MCP connectors back to your product. So now you have an agent. I like to say we started with chatbots that you can talk to. Then we gave the chatbots tools to use. And then now you can give a tool to your chatbot that can make other tools that it doesn't have. And so now you can actually build out enterprise software that writes its own plugin connectors to the API level for each customer on the spot. That's something that a professional services team used to have to do. So you have fully customizable software that can now talk back to itself. I made a Kanban board for Dev Day that can actually fix its own bugs. It's pretty fun. And then lastly, you can actually do something like what Zed has done. They have just decided to wrap Codex inside of a layer and give it an interface to the IDE for talking back and forth for the user and making code edits. And now they don't actually have to do all the work of staying on top of all of the things that we're good at doing, and they can focus on building like the best code editor.
So our top coding partners, like GitHub, has used this to great effect. And, well, we've created an SDK for it that they used to directly integrate with Codex. You can also use the SDK to control Codex as part of your CI/CD pipeline, as well as use it as an agent that directly interacts with your own agent as well. If you really want to customize the agent layer, you can do it too. As an example of this, we worked closely with the Cursor team to get the best performance out of the Codex. The model, not the agent. We're bad at naming things. The model is different from the agent. They did so by aligning their tools to be in distribution with how the model is trained, and they did so by aligning their harness with our open source implementation of Codex CLI. All of this is publicly available. You can fork the repo, you can use our source code, you can use it, go nuts.
So what does the future hold for Codex? It hasn't even been out for a year. And especially with the launch of Codex Max yesterday, like things are really changing fast. It's the fastest growing model in usage, now serving dozens of trillions of tokens per week, which has actually doubled since Dev Day. It's always good to build where the models are going. It's safe to assume that the models will get better. They'll be able to get to work on much longer horizon tasks unsupervised. New models will raise the trust ceiling. I trust these models now to do some way harder work than I would have 6 months ago, and that's going to keep increasing. The future is about sprawling code bases and non-standard libraries and knowing how to work in closed source environments, matching existing templates and practices. And the models, and so you can imagine that the SDK will evolve to better support these model capabilities, letting the model learn as it goes and not repeat mistakes, and generally provide more surface area for an agent that writes code and uses a terminal to solve whatever problems it encounters. And you can use that in your products via the SDK. So what have we learned? Harnesses are really complicated and take a lot of work to maintain, especially with all the new models coming out. So we've built one for you inside of Codex that you can use off the shelf or look at the source if you want to. And you can use it to build new things outside of coding. And let us do all of the work, making sure that you have the most capable computer agent. And we're really excited to see what you craft.
Next presenters believe that most enterprises are failing to unlock real value from AI because the systems in which they operate are stuck in the past. Here to share how agents are reshaping software delivery are McKinsey partners Martin Harrysson and Natasha Maniar.
All right, good morning. Hello, everyone. It's really great to be here. So I'm Martin, and I'm here with my colleague, Natasha. We're from a part of McKinsey you may not be as familiar with. We have a practice called SoftwareX, and we work with mostly enterprise clients on how to build better software products, which has meant mostly using AI in the past couple of years. And so what our talk is about today is really more focused on the people and the operating model aspects of leveraging AI for software development. we believe that that has to change quite significantly, and that's what we're excited to talk to you about. If I take a quick step back in time, and we just think through some of the major technology breakthroughs that we've seen in the last few decades, they tend to always come with a paradigm shift in also how we develop software. And so I still recall almost 20 years ago now, I started working as a software engineer, an entry-level developer in a tech company. And the company I was working for was just switching to Agile. We were using Kanban boards, we were doing stand-ups and other ceremonies. This was a big change. It was a massive change for the company. And now, with everything that is happening in AI, we're at the precipice of another such paradigm shift. And if we think about some of the things that are happening with AI and software development that we've seen at this conference, there's no doubt that this is a new paradigm that is about us. And so we'll talk about two things. We'll first touch a little bit about how do you go from these things that we're seeing at individual productivity to scaling that to the whole team, and what type of changes we think that implies. And then we'll talk a little bit about how do you scale that across a whole organization and to really get value. If you sort of, I'm talking to an audience here which is using AI and agents all the time. And I thought if I asked you about some examples, I'm sure you could rattle off 10 different ones where you would say, look, there was this thing that I used to do. It used to take maybe even days and hours that are now taking only minutes, right? There's no shortage of those stories. And you can go over to the expo and talk to any of the companies there about all these great use cases. It really shows that these tools work and they can be really impactful. And so, yet, despite seeing some of these improvements, we've done some research to gauge where are our clients at the moment. We recently surveyed about 300 companies, mostly enterprises, around what are they seeing in terms of productivity improvements. So you have this, and then they would say, on average, we're often seeing only 5, 10, 15% improvements overall as a company. So we're in a place where there's a bit of a disconnect between this big potential around AI from the reality. And so we think that there is this gap, because as we've started implementing AI, whether it's coding assistants or whether it's now using, you just heard about how OpenAI is using agents and more complex workflows. What has started to emerge is a set of bottlenecks that were not necessarily there before. Like for example, as we now start moving much faster in certain aspects of the work, we haven't really changed how we collaborate among people and team members. That's not quite keeping up. We started generating way more code, but it's still being reviewed in a pretty manual way in many companies. Right? And then we also have this theme, which was recently highlighted in even a research report from Carnegie Mellon, about how all the new code that is being generated is also amplifying the generation of tech debt in some cases, and actually generating complexity. And so there are these bottlenecks. They're not impossible to overcome, but this is what we believe is limiting many companies from seeing the real value that they should be seeing. Let me talk about maybe just a couple of examples to make that come to life a little bit more. One of the things that we see as a big rate limiter at the moment is around how work is allocated. And so what we've learned over the last couple of years is that the impact from AI and agents is highly uneven. There are some tasks where it works amazingly well today, and you see huge improvements. And there are others where it's not as effective. And so you have that variability. You also have variability among people. Some have lots of experience now using these tools and know how to pick that up. And others are less experienced, right? And so what that means for team leaders, for engineering managers and so on, is it's very highly non-trivial to know how to allocate work and resources in a good way. And this is creating a lot of inefficiencies. Another example is around how work is being reviewed. So agents are often given pretty fuzzy stories that are written in prose with pretty fuzzy acceptance criteria, which means that the code that comes back is not always what it was intended to be. And for many companies, the only mechanism to control that is often manual review. So you've automated some things, but we've generated more manual review. So these are some of the examples of these bottlenecks that we see coming up. And as mentioned, what that has resulted in so far is that most large companies today are stuck a little bit in a world of relatively marginal gains. They're working in ways that was developed with constraints that we had in the past paradigm of human development. So if you go out to most companies, you see 8 to 10 person teams, you see working in 2-week sprints, you have all these elements that were largely parts of an agile operating model. And that is putting in some limits to what they can see. Over the past year, we've been working with lots of clients to sort of break that model a bit and develop new ways of working in smaller teams, in new roles, with shorter cycles. And when you do that, we see really great performance improvements. And that's what gives us this path where we see things are going to improve.
So we realized that rewiring the PDLC is not just a one-size-fits-all solution. For example, different types of engineering functions across the enterprise along the product lifecycle may require different operating models based on how humans and agents best collaborate. So if we take the example of modernizing legacy code bases, this task requires a high context of potentially the entire code base, but also has clearly well-defined outputs. So an example operating model could look like a factory of agents where humans provide an initial spec and final review with minimal intervention. For new features for greenfield and brownfield projects, the operating model may look like an iterative loop because they may benefit from the non-deterministic outputs and increased variation, where agents act as co-creators, providing more options to facilitate faster feedback loops. So as we mentioned, we did a survey among 300 enterprises globally to understand what sets these top performers apart. We found that they are 7 times more likely to have AI-native workflows, which meant scaling over 4 use cases across the software development lifecycle, rather than just having point solutions for just code review or for just code dev. They were also 6 times more likely to have AI-native roles, which meant having smaller pods with different skill sets and new roles. To enable these shifts, these organizations were investing in continuous and hands-on upskilling, impact measurement, and also incentive structures to incentivize developers and PMs to adopt AI. This led to 5 to 6 times increase in time to market and delivery speed, as well as higher quality and more consistent artifacts. So when we talk about AI native workflows, we mean that these enterprises are moving away from quarterly planning to continuous planning, and also the unit of work is moving from story-driven to spec-driven development, so that these PMs are iterating on these specs with agents rather than iterating on long PRDs. On the talent side, AI native roles essentially means that we're moving away from the 2 pizza structure to 1 pizza pods of 3 to 5 individuals. Instead of having separate QA, front-end, and back-end engineers, there are more consolidated roles where product builders are managing and orchestrating agents with full stack fluency and also a better understanding of the full architecture of their code base. PMs are starting to create direct prototypes in code rather than iterating on these long PRDs. And one example that we've described in our article, we've studied some AI native startups and realized that they've actually implemented all of these shifts to accelerate their outcomes. And in our article, we've described how Cursor actually operates internally. But if you're a large enterprise predicated on the Agile model, what are some steps you can take? So in a recent client study with a leading international bank, we tested some team-level interventions to address the bottlenecks previously mentioned before, mainly around the sequencing of steps within the Agile ceremony and how to define the roles of agents and humans within the sprint cycle. So let's walk through some examples. First, team leads would assign sprint stories using agents based on the data of the team velocity and delivery history, and then they would co-create multiple prototypes and iterate with agents on the acceptance criteria around security and observability needs to have more consistent artifacts across teams. This prevents downstream rework that was mentioned before, so that developers don't have to constantly be iterating with the agents during the code process. The squads were also reorganized by workflow, so there would be one which would be focused on small bug fixes and another focused on greenfield development. In the background, agents would be used to look at the potential cross-repository impacts to prevent debugging time for developers. And another example is that instead of for reducing the collaboration overhead and meetings that happen within the sprint cycle, instead of waiting for data scientists' input, PMs would directly be observing the real-time customer feedback to reprioritize these features. And this would lead to an acceleration in the backlog within the same amount of time. So we studied the impact of these interventions and found high promising results. For example, not just the increase in agent consumption by over 60 times, but there was also an increase in the delivery speed that was tied directly to the business priorities for this bank. There was a 51% increase in code mergers, but also a decrease in an increase in efficiency.
The other aspect of this is around the different roles and the talent model. And so one of the biggest differentiators that we saw, as mentioned, was around whether you have actually changed the roles that are involved in software development. And so, what you all are seeing is that engineers are moving away from execution and just simply writing code to being more of orchestrators and thinking through more how to divide up work to agents, for example. And we also heard some examples of how the role of the product manager is changing. And so while this may sound pretty straightforward to many of you here who are working with these tools like day to day, that you have to change what you do, the reality is that about 70% of the companies that we surveyed have not changed their roles at all. Right? And so you have this background expectation that people are going to do things differently, but the role is still defined in the same way and is the same understanding as it was a couple of years ago. But we are starting to see some companies changing this. So this is another example from another recent client. They were set up in a way that is probably pretty common for many companies, and a kind of typical two-pizza team model with the types of roles that you'd be familiar with. We ran a bunch of experiments and front runners and tested new models that had much smaller pods that had new roles, which consolidated some of the tasks that were previously done by different roles. And so by doing that, we could create basically more pods or more teams with the same number of people, but retaining the expectation that each pod is performing at about the same level as they were before. And so we also see really positive results from that, with maintaining and even improving in some cases the quality of the code that was generated. In particular, there was a high speed up in terms of the output from the different teams, and you can see some of the metrics here. Let's shift gears a little bit and go from talking about just the team level. So how does this now scale across a big organization? The reality is that many companies don't just have like one or two of these teams, but often hundreds of teams even, and thousands or even tens of thousands of people who are working in this way. And this is where one of the biggest differences that we saw between those that are stuck a bit in the in getting only 10% or so change improvements from those who are seeing outsized improvements is around how you manage that change. And change management, I guess, is like one of these, a little bit of an often catch or elusive term for a lot of different things. But I think in some ways it's not a bad way to think about it. I usually say that the change management is about getting a lot of like small things right. And so the crux to like actually scaling this is often about getting 20, 30, or even more things right at the same time that involve the way you communicate what this means, the way you incentivize people, the way you upskill them. And it all has to come together. And when it's not, we see what happens. And so this is an example from another tech company that we worked with, where initially we were rolling out new AI tools for them that hit different parts of the product development lifecycle. We rolled out the tools. There was some usage, but often it dropped off. It was either not used or it was sort of used in very suboptimal ways. So that's the sort of jagged part that you're seeing on the left-hand side here. Despite kind of adding more users, the overall impact did not change at all. So we had to do quite a reset and start over effectively. Reset the expectations. What does this mean if you're a developer day to day? What does it mean for a PM? We had much more hands-on upskilling. You could bring your own code. There were coaches available, especially those first like few sprints before you make this a habit and work it into the way that you develop software day to day. It's a very critical time, and that's when this matters a lot. And having a bit of a measurement system as well, so you know what's changing and you're able to see what's improving. Another example, just to put this alive a little bit, as mentioned, like this is about getting a lot of things right. And it's each one of these individually may not seem like it's the biggest deal, but put together, they really make a huge difference. Like this is some of the top interventions that another client had to go through. For them, it really helped having, setting up code labs, for example, really, instituting a new set of certifications that help motivate and drive people to change what they do day to day. And these things really added up to the change they needed.
But building a robust measurement system that prioritizes outcomes and not just adoption is important not just to monitor progress, but also pinpoint issues and course correct quickly. So one surprising result from the survey was that these enterprises that were bottom performers were not even measuring speed, and only 10% were measuring productivity. But our goal is to make our clients top performing organizations. So we've worked with them to create a holistic measurement system that captures impact all the way down to inputs. So for inputs, this would include the investment into coding tools and other AI tools, but also the time and resources in upskilling and change management. These inputs would lead to direct outputs, but a lot of organizations are just focusing on how the increased breadth and depth of adoption of AI tools is leading to increased velocity and capacity increase. However, it's also important to understand how developers have different NPS scores and if they're enjoying their craft more rather than feeling more frustrated. And it's also important to understand whether the code is becoming more secure and has better quality, but also more resilient. And one proxy for resiliency that we used for our client was the mean time to resolve priority bugs. Now, if we look at economic outcomes, which is priority for the C-suite executives, they look into what is the time to revenue target, what is the increased price differential for higher quality features or expanding the number of customers to meet the feature demand, and also what is the cost reduction per pod for reduced human labor. In aggregate, having these larger economic outcomes can also lead for organizations to understand how there is an increased reinvestment in greenfield and brownfield development. But as these tools evolve, the proxies for these metrics will also evolve. But hopefully this provides a MISI framework as an initial starting point. So what's next? The future, of course, is difficult to predict, let alone in the next 5 years. But we hope that with our vision of a new software development model, even as agents increase in their intelligence and humans become more fluent in AI, that this model still stands. So hopefully this model that includes shorter sprints, smaller teams, smaller but larger number of teams will set enterprises up for success in the long term.
So just leave you with some key takeaways. Start now, I would say to our clients. This is a human change, and it takes some time, and it's a big change, and it's going to be a journey. And so I think this is something that everyone needs to go on. I think it's also important to figure out which model works for you and set a really bold ambition. And with that, say thank you so much for listening to us. And we have an article here if you're more interested in the research that we've conducted. Thank you so much for having us.
Thank you.
Our next presenter is a researcher at Stanford who studies how AI impacts over 100,000 developers in the real world. Please welcome Yegge Denisov-Blanch.
So companies spend millions on AI tools for software engineering. But do we actually know how well these tools work in the enterprise? Or are these tools just all hype? To answer this, and for the past 2 years, we've been researching the impact of AI on software engineering productivity. And our research is time series because we look at Git historical data, meaning we can go back in time. And it's also cross-sectional because we cut across companies. And the way we use to measure most of the impact is by a machine learning model that replicates a panel of human experts. The way this works is that imagine you have a software engineer who writes a code commit. And this code commit would be evaluated by multiple panels of 10 and 15 independent experts who would evaluate that code commit across implementation time, maintainability, and complexity, and then produce an output evaluation. So we took the labels of these panels across millions of kind of evaluations and then trained a model to replicate this panel of experts, meaning that we can deploy this at scale. And if there's ever any doubts around the model's output, you can always kind of assemble your own panel and see that it correlates pretty well with reality. Today we'll talk about 4 things. We'll start off with looking at some of the things that are driving AI productivity gains in software. Then we'll look at an AI practices benchmark that we developed. We'll then look at how we propose to measure AI return on investment in software engineering. And lastly, we'll finish things off with a case study. So here we took 46 teams that were using AI, and we matched them with 46 similar teams that were not using AI. And we measured their net productivity gains from AI quarterly. And the shaded area is the middle 50% of the data, and the dark blue line is the median, which as of July of this year stands at about 10% for this cohort. I'd like to direct your attention to the fact that the discrepancy between the top performers and the bottom ones is increasing. There's a widening gap. And so if we very unscientifically and very illustratively project this forward, we might get something like this, right? Where you can have these top performers being part of this, the rich gets richer effect, where these successful early AI adopters might compound their gains while these strugglers could fall further behind. At some point, this is going to converge, and this is very directional. But my point here is that if you're a leader in a company, you definitely need to know in which cohort you are right now so that you can course correct. And without measuring the impact of AI on your engineers, you're not going to be able to do this. So we started investigating what are some of the factors that drive these top teams to perform better. And the first thing we looked at is AI usage, or basically token spent. In this graph, you have the same kind of, on the vertical axis, the productivity increase, and then on the horizontal one, you have the token usage per engineer per month on a logarithmic scale. And what you can see is that the correlation is quite loose, 0.20 or so linearly. And there is a bit of a death valley effect around the 10 million token mark, whereby teams that were using that amount of tokens seem to be doing worse than teams that were using a bit less tokens. It's very directional, but interesting nevertheless. The conclusion here might be that AI usage quality matters more than AI usage value. We dug deeper and we said, well, does the environment in which the engineers work impact the productivity from AI? And we came up with an environment cleanliness index. It's quite experimental. It's a composite score that looks at tests, looks at types, at documentation, and at modularity and at code quality. And that index is on the bottom axis here from 0 to 1. And then on the vertical axis, once again, you have the kind of productivity lift relative to teams not using AI. And so what you can see is that there's a 0.40 R squared, meaning a pretty decent correlation around environment cleanliness and gains from AI, or productivity gains from using AI. And so the takeaway here is to invest in code base hygiene to unlock these AI productivity gains. We dug deeper to illustrate this concept, and here we have, on this graph, on the vertical axis, the percentage of tasks that might be able to be completed by AI based on 3 colors. And so green means that AI can do most of the work for that task in that sprint. Yellow means that AI can help someone, and red means that AI is not very useful. And this is quite illustrative, but it conveys the point. And so then any code base at any point in time sits on a vertical line across this graphic. And what you can see is that clean code amplifies AI gains. Secondly is that you need to manage your code base entropy, right? Your code base tech debt. Because if you just use AI unchecked, this is going to accelerate this entropy, which is going to push and degrade your cleanliness to the left, kind of right? And then you as a human need to push on the other side to kind of improve or maintain that cleanliness to keep reaping the benefits from AI. Thirdly is that it's important that engineers need to know when to use AI and when not to use AI. And what happens when they don't is this kind of line on the left whereby you have AI outputs that are rejected or need heavy rewriting, which then leads to engineers losing trust in AI, saying, okay, this just doesn't work, I'm not going to use it, which then further collapses your AI gains. Now, we said, can we find out whether we can look not only at usage, but at how are these companies and these engineers using AI? And we came up with an AI engineering practices benchmark. The way this works is that we can scan your code base and detect these AI fingerprints or artifacts, basically traces of how your team is using AI. It's quite directional at this point, but evolving. And we can quantify this based on the percentage of your active engineering work that uses each AI pattern. And then we can repeat this monthly using Git history. And the way this works is more or less you have kind of a few levels, and level 0 might be how humans are just not using AI and write all of the code. Level 1 is kind of like personal use, where engineers are not sharing prompts across the team or not versioning them. Level 2 is team use, whereby teams are sharing these kind of prompts and rules. And then level 3 is even more sophisticated. It's where AI autonomously does specific tasks, maybe not the entire workflow. And level 4 is, agentic orchestration, which is where AI just runs the entire process. And so this is going to be an open source tool which you can leverage if you sign up on the Sweeper research portal. We applied this benchmark to one of the companies in our research data set, and we saw this. This company had 2 business units with equal access to AI tools, right? Same licenses, same spend, same tools, same everything. But the adoption rate and the usage rate was very different by business unit. On the left, the first business unit, as you can see in the area in the blue, seemed to be using AI a lot more for almost 40% of their work, whereas on the right, the second business unit seemed to struggle behind a bit more. And so the takeaway here is that access to AI and even AI usage doesn't mean or doesn't guarantee that AI is going to be used in the same way across a company. As a leader, you really want to be understanding not just whether they're using, but also how your engineers are using AI. Great. Now let's dive into how do we actually measure AI return on investment in software engineering. There we go. Okay. So here, ideally, we would be measuring this based on business outcomes, right? I give my engineers AI, and then I make more money, more revenue, net revenue retention, whatever business KPI you want to track. The problem is that there's too much noise between the treatment, right, giving AI, and the result, which is the business outcome. And on top of this, there's confounding variables, such as your sales execution, the macro environment, your product strategy. And therefore, although that would be ideal, unfortunately, I think we need to find alternative paths, and the most logical one is to simply look at the engineering outcomes, because there's a clear signal, right? But here, we need to go beyond measuring AI usage into measuring engineering outcomes. There's a few caveats, and this topic is quite heavily discussed, and so I want to mention some of them. The first one is that this is assuming that our product function can properly direct that increased capacity into something that generates value. And if they aren't directing that, then it's a product problem, which although sits quite close to engineering, it's slightly different, right? The second caveat is that this assumes that engineering is a meaningful bottleneck for value, which frankly it typically is, and that you can guard against Goodhart's law by using a balanced set of metrics and also by having a good company culture that doesn't weaponize these metrics. And thirdly is that AI is still very new, and measuring proxy metrics is still better than not measuring. There's going to be winners and losers in this AI race, and progress is better than perfection here. And so metrics don't need to be flawless to be useful, is what I want to illustrate. So then here we have 2 parts which you need to do to get the ROI from AI, right? You kind of need to measure usage, and then you need to measure engineering outcomes. And so let's start with usage. There's really 2 buckets for enterprises. There's kind of more in a research environment, but to make it simple, there's access-based and there's usage-based. Access-based is basically looking at when did people get access to the tool. And here we have, you can kind of do a pilot group, give that group AI, and then compare it to a similar group without AI, or you can measure the same team across time. The problem is that access-based is noisy, and the gold standard is really usage-based, which uses telemetry from APIs from these coding assistants, right, to give you the right data to know who's using AI and where. And the caveat here is that the vendor API is different. Unfortunately, tools like GitHub Copilot aggregate the data, and other tools like Cursor give you more granular data. The big takeaway is that you can measure impact of retroactively by using Git history. And so you don't need to set up an experiment now and wait 6 months. You can actually, if you've already adopted AI, you can go back in time and do this. It's quite easy. Now, we've seen usage. Let's look into how do we actually measure engineering outcomes. What are some of the metrics we propose? Here we have our framework, which we propose, which is using a primary metric and a guardrail metric. And so here, the primary metric is engineering output. It's not lines of code, it's not PR counts, and it's not DORA. And it's basically based on this machine learning model that replicates the panel of experts, right? And the second set of metrics are the guardrail ones, which you want to maintain at a healthy level, but you don't want to maximize. It doesn't make sense to maximize them, truly. And so then there's 3 categories within the guardrail ones: rework and refactoring, quality, tech debt and risk, and then people and DevOps. The third bucket is important to highlight that these are not productivity metrics. They're useful, but you cannot just kind of use them, like maximize them to maximize developer productivity. They kind of fall off at some point. And so the goal here might be to keep your guardrail metrics healthy while increasing the primary metric to whatever degree possible. Now, let's dive into a case study. Here, we worked with a company that, large enterprise. We took a team of 350 people under a vice president, and we measured pull requests. The reason we did this is to illustrate that you cannot measure pull requests to understand whether AI is helping you. And so here, this team adopted AI in May of this year, and we measured the 4 months before, 4 months after. We saw a 14% increase. Great, that's fantastic. But what about reviewer burden? What about code quality? So we measured code quality. And here what we saw is, firstly, actually, code quality, think of it as maintainability, scale from 0 to 10. And there's kind of these bands. It uses our methodology. You can read it online. But basically, what you see is that in the pre-AI period, their code quality was quite stable and consistent. And once they adopted AI, two things happened. Code quality decreased, and then code quality became more erratic. Next, we took a look at our metric, which is engineering output. It's not lines of code. And here, for every month, you see the sigma, the sum of the output delivered for that month, broken down into 4 buckets: rework and refactoring. So rework is when you're changing or editing code it's still kind of fresh, so it's recent. Refactoring is when you're changing code that's a bit older. And then like added and removed, it's pretty self-explanatory. And then also you can see these kind of benchmarks, so we can benchmark this company against similar companies in their industry. And here AI usage had 2 effects. Firstly is that rework went up by 2.5 times, which is really bad. And effective output, which is kind of like a proxy for productivity or so, didn't really change. And so then what's the conclusion here? Let's do a recap. So we saw that PRs went up by 14%, but this is inconclusive because more PRs doesn't mean better. We saw that code quality decreased by 9%, which is problematic. We saw that effective output didn't increase meaningfully. And then we saw that rework increased by a lot. And so then the question here is, what is the ROI of this AI adoption, right? It might be negative. And what I want to point out here is that had this company not measured this more thoroughly and simply measured PR counts, they would have thought, hey, we're doing great. We increased our productivity by 14%. Let's run the numbers. That's how many million? Lots of millions of dollars. And does this offset the AI licenses? Sure thing it does, right? The other thing is that I don't think this company should abandon AI. They should simply use this data to understand what they're doing wrong, how can they improve, because AI is here to stay. It's a tool that's going to transform how engineers are working, right? And you can't just kind of like abandon it or so. Great, so this concludes our insights for today. If you've enjoyed this talk and you would like similar insights for your company, I invite you to participate in our research. Everything you've seen today can be accessed through kind of participating in our research, some of them through live dashboards in our research portal. And especially, I'd like to invite companies that have access to Cursor Enterprise to participate, because we have a high need for this, so we can publish papers around the granularity of using AI in software engineering. You can sign up at softwareengineeringproductivity.stanford.edu. Thank you so much.
Our next speaker will separate hype from reality on AI code quality, using real-world data to show when AI-generated code can be trusted in production. Please welcome CEO of Kodo, Itamar Friedman.
It will grow. It will grow. 1 or 2 more months. I'm really excited being here. So much pragmatic and insight and suggestions. I was sitting there just before. So I'm Itamar Friedman, the CEO and co-founder of Kodo. Kodo stands for Quality of Development, and I'm going to share our reports and other companies' reports about state of AI code quality. Trying to talk about the hype versus reality, which was like one of the points that were discussed here quite a lot, which is awesome. So in the last 4 weeks, we saw like 3 outages in the clouds, unfortunately, right? And these are coming from companies that really care about moving fast, right? They're saying themselves that they're using AI to generate code 10%, 30%, 50%. At the same time, they care about quality. So how did that happen? And is it related? I don't know, but let's have some, I'm going to share some guess. So by the way, 60% of developers say that the quarter of their code is either generated by AI or shaped by AI, and 15% say that even more than 80% of their code is basically generated or shaped by AI. Now, people are using AI to do vibe coding, but actually they're even doing it for vibe checking, vibe reviewing. This is the command of Claude. This is the prompt for the command of Claude Code for security review. It was hyped like 2 months ago. Do you know what I'm talking about? Now it says there, I don't know if you see it, you are a senior security engineer. Good. And then like somewhere there down the line, it says, please exclude denial of service. Don't catch denial of service issues. Maybe that's part of the reason like we're having cloud outages. Probably not just that, but you get the point. Like we need to be rigorous about how we deal with quality. It's not just like vibe quality or so like we're doing vibe coding sometimes. Let's go to another example, okay? Cursor, I guess like, or Copilot, most of you use rules, right? We're gonna talk about it. You invest in code generation. After a while, you understand if you invest, you'll get more out of it. And we asked like a bunch of developers, and I'm asking you as well, think for a second for all the developers there in the audience. Like when you write Cursor rules or Copilot rules, etc., do you feel they're completely followed, or it's like mostly followed? Do you know how much they're followed? And what extent are they followed? It's rigorously, like how technical deep they're being followed. So what we get back, like the answer from what you see here on the screen is mostly like B, C, and D. They are followed, but they're not completely followed, okay? So that means like we are generating code, trying to push it to the standards, but it's not necessarily still like getting to the quality we wanted. I'm going to share a bit more statistics and information and some insight from 3 reports, one done by Kodo, another done by Sonar, another by Pharos, and all of them are focused on code quality, review, etc. The sample size is thousands of developers, in some cases even more, millions of pull requests, and a billion of lines of code that were being checked. Like, for example, if you think about Sonar, this is a company, a bit like coming from pre-AI, but they see code at scale. And they're doing like a lot of checks in code that are not necessarily AI focused, but are necessary in order to check your software from all possible direction. And that's why they're scaling, and the scale of the code that they're seeing is immense, okay? So for example, we took information from their report. And eventually my purpose here is to break down the different dimension of what code quality means and share some stats and insights. I want to start with the end, okay? This is the takeaway I want you all like to take from the next 13 minutes that I have. We started with code generation. We, like out of the box, we use it for autocomplete, etc. And you invest in it and you can get more out of it. But there is a glass ceiling for how much productivity you can get from code generation. And then we move to the agentic code generation, right? Let's call it Gen 2.0. And that's a higher glass ceiling. It could do much more productivity, and especially if you invest in it, for example, rules, etc. Then, with AI breaking outside of the IDE, we can start using AI also for agentic quality workflows. It could be inside the ID, but the truth is that if you think about all the workflows you have in your organization, especially if you're more than 100 developers or so, you probably have a lot of workflows that are related to quality that you need to automate. And that's where you start like breaking through the glass ceiling of productivity if you invest in it. And finally, I claim that you need those agentic workflows, keep learning, and we might touch a little bit of that like later on, okay? Like, because quality is something dynamic. So you'll only finally break the glass ceiling if you really have those quality workflows and rules and standards being dynamic. And then you will see the promised 2x, let alone the 10x that you were promised the hyped, and you heard from McKinsey and from Stanford. You're not getting that. I don't need to tell you the 2x, 10x for the entire software development life cycle. So a bit more about the market adoption. One of the reports says that 82% of adoption already for AI dev tools are being used daily or weekly. Some people at 60%, 59 report that they're using more than 3, and 20% saying that they're using more than 5 code generation tools. If you think about it for a second, don't only take like Cursor, Copilot, Codex, Claude Code, etc. Sorry from insulting anyone that I forgot their tool. But there's also the Lovable, etc. They also generate code. And by the way, you're going to get to 10. Count on me. You're going to get to 10 tools in 2-3 years that generate code for you. Okay. Come to talk to me about it later, I'll try to convince you. And the thing is that it's coming from bottom up, like 50% of the usage is coming from a team that are less than 10 developers, but it is propagating also to the enterprise. Again, I'm sure you know, propagating to the enterprise at scale, like not just like 5 developers. In the last year, we're seeing like more and more enterprise using code generation. If like an average within reports, we saw 82 to 92% using weekly to a monthly code generation tools. And in some cases, maybe extreme, maybe not, we're going to talk about it, we saw 3x productivity boost in writing code, okay? But that doesn't mean that if you have 3x productivity in writing code that you actually guarantee any quality like I presented before. So actually 67% of the developers that we asked have serious quality concerns about all the generated code, code generated by AI or influenced by AI. And they're claiming that they're missing the framework, how to deal with quality, how to measure quality. It's a big question. What is quality? I'm going to talk about it in the next few slides, okay? Think about it for a second before I break it down. What is quality? So what we're actually saying that the crisis with vibe coding, viable coding, we're seeing it shifting and evolving, is that you're getting like more tasks being done, like some report 20% more task velocity, and like 97% more or so of PRs being opened. And eventually it takes more time to review PRs, like 90% more time to review PR. And by the way, like there's a lot of statistics about AI generating code. At least there's not less amount of bugs per line of code. I'm not claiming that there are more, but even if there's not less bugs per line of code, you have much more bugs because there are much more PRs, much more code being generated, etc. Right? So that's a problem for the reviewer. So it's not by surprise it takes more time to review these, especially in the age of agents, right? When 5 minutes calling to Claude Code, I have 1,000 lines of code after 5 minutes. Once upon a time, it took me like hours to write 10 proper lines of code, right? Now, let's zoom out for a second. Code generation is magnificent, okay? Like it's a game changer when you're talking about greenfield. You saw people talk about it a few slides, a few minutes before me. It revolutionized how we do proof of concept project, etc. But when you're dealing with heavy-duty software, then you like it or not, we are dealing with a lot of things when you serve millions of clients, you have financial transactions. When you're doing transportation, you're dealing with code integrity, if you like, code governance, review, standards, testing, reliability, etc. That's what we need to deal with. Now let's break that under the surface part of the glacier into 2 dimensions. This is 1 dimension. You can look on the quality issues throughout the software development lifecycle, like planning and then development, writing code, code review. Code review is a bit of a process, but like what you're like checking quality, that's part of the process of code review. Testing, which is another part of quality, and deployment. And I know I didn't cover the entire software development lifecycle, but just to give you an example. And each one of them introduce new problems that are coming because you're using more and more AI-generated code. Now, another dimension to look at it is actually code-level problems and process-level problems. Okay, I'm not opening the list of functional, just opening the list of non-functional. You're talking about security, inefficiency that are not necessarily functional. I'll show you some statistics about that. And then process level is, for example, learning. Hey, if you will have a bad outage because of AI-generated code, who is responsible? Is it the AI or the team that owned that? Okay, like you need to learn and own the code eventually. That's a process that needs to be done. Verification, putting guardrails, standards, etc. So all of those issues, when they're introduced to thousands of developers that we asked them, do you think like actually AI helped to reduce with those problems or actually made more challenging? 42 people reported that they spend 42 more of the development time on solving issues, on fixing bugs, etc. And they saw 35% project delays. We're talking about maybe gains. They're talking about like delays. okay, there's some bias. We talked about problem with quality and what's the impact, etc. But that's what they present when they answer when you're talking about like when you're using AI generated code. And we see reports, some of the reports talking about 3x more security incidents. By the way, it makes sense. You remember we had a slide saying 3x more writing code, so 3x more security incidents, like the same amount of line of code, the same amount of problems, correlation. So what to do with that? Like I talk about problems and problems and problems. Okay, help me deal with it. Okay. Like let's spend a few minutes on that. So one suspect, of course, is testing. And actually, really interesting, we asked a couple of questions about testing, and one really relevant thing is that people said that when they heavily use AI on testing, use AI to do testing, they actually double their trust in the AI-generated code. Okay, that's one thing. The next suspect to help us with the quality is code review. What really interesting about code review, that it's a process that helps almost with all the process level and the code level like issues. For example, you can set your AI code review tool to tell you, block this PR if it doesn't cover certain level of test coverage. So through the PR, you take care of the testing process problem, okay? So code review with AI is actually one of the major things you can do. And people that are developers that are using AI code review tool, they're saying that they're seeing double the quality gain. And they're saying that actually it helps them to improve 47% in productivity of writing code, okay? Now, a bit statistics from our own AI code review tool. We scan 1 million of PRs a month, and we took 1 million of those PRs. And we noticed that 17% include like high severity issues. By the way, we're now analyzing before and after using AI. I don't have that statistics yet, but we're noticing since we're starting, most of the companies we serve, they use AI generated code. So that's why I don't have before. We need to go scan backwards. And that's like a really big number. Another thing I wanted to talk to you like about when you're trying to improve on quality is the foundation of having the right context that is brought to the code generation tool, that is brought to the AI code review tool. Better context, better quality across the board, wherever you're using AI. So when we ask developers, when you don't trust AI generated code, like you remember like 67% said that like are really worried about that. They said 80% of the time they don't trust the context that the LLM have. Okay, and when we ask developers, what would you like to be improved in your AI-generated code, in your AI code review tool, they said the number one was context. It was number one at 33%. They can choose like among many things to improve. So context is extremely important. I can tell you that as Codo, one of our technology moats is around context. And when you connect our context engine, we're seeing it as the number one tool that is being used. Like 60% of code generator or code review tools, 60% of their calls to an MCP would be to a context MCP, okay? And just to tell you, the context doesn't necessarily need to include only your code. It could also include context to your standards, to your best practices. We're seeing in our AI code review that 8% of the context usage is actually from files that are related to standards and best practices, etc. Okay, I have to, CEO of Codo, like marketing will be mad on me if I don't brag a little bit, right? So this is our kind of like our architecture of our context engine being presented by Jensen in a GTC keynote. And notice he didn't talk about our code review capabilities, about our testing capabilities. He talked about our context engine that NVIDIA checked because there's a realization that AI quality, AI generated, whatever review testing will come from bringing the right context. So invest in that. You need to build your context, buy a solution and invest in it, build your solution, etc. And the context needs to include code, versioning, PR history, organization logs, etc. That's where all the context sits. It's not just in the last branch of your code base, okay? So I'm zooming out, starting to talk about like recommendations and like takeaways. So what's next? So automated quality gateways, invest in that. People talked throughout the morning about parallel agents, you know what I'm talking about, like background agents. You can use a lot of those like tools and capabilities to build your quality gates. Use intelligent code review, testing, and you need a living and breathing like documentation, and what documentation means is a story by itself. I'm not going to double click on that. And this is how I present for 3 years now, and I think I'm going to go all the way until age of 60 with this slide of how I think the future of software development looks like, okay? So basically you have your specification and you have your code, right? And you have multiple agents, parallel agents that are helping you to improve your spec, write your spec, improve your code, transform from your spec to your code, make tests which are executable specs, right? And then you're going to have your context engine, the software development database, and you will build your tools, especially MCPs around quality and verification. And you'll make sure you have environments, stable, secured sandboxes where those agents can run and run validation and quality workflows. So don't forget, like, the path forward is quality is your competitive edge over your competition. AI is a tool, it's not a solution, okay? And don't like only think about code generation as the only thing. Look on the entire SDLC or product development lifecycle. I saw one of the people talked about, speakers, and iterate with everything we talked about today. I want to tell you that you will gain value from it. We're seeing in the reports, people seeing like security vulnerability being reduced, faster code review. We just got a hit on that because of AI-generated code. And test coverage in a month can triple, depends on the project, etc. With the last minute, I want to show like a really small piece of what you can do with Kodo. You can go into Kodo and define your own rule. For example, almost the same rule you'll put in Cursor of, I don't like nested ifs, if this is a problem that you have. But then Kodo will look on your context, build the good example, the bad example, and then start building a workflow that is specifically to catch that issue and give you statistics over time when it's being accepted and when not, so you can adjust that rule and really know and have visibility to your standards, okay? So when a PR is written with a few ifs and else, although it was written with Cursor Copilot that had a rule do not do nested ifs, etc., then eventually when you open a PR, you will get Kodo catching that and giving a suggestion according to the good and the bad example. Kodo will also make a graph, give you a CLI checks, like check each one of the rules and eventually tell you the nested if, and then will record and learn what you did or did not do with that suggestion in order to adapt the standard and, of the quality. There will also automated like suggestion. You don't need to write your own. It learns your standards and quality and offer that to you. And that's it. I'm really, really excited about like breaking the glass ceiling, okay, with what we did with code generation and then agentic code generation. Now we're turning into the era of putting AI into work and through the entire SDLC. The most important part is related to quality. You would need to invest in that. It's not out of the box, okay? And then you would see eventually the promised 2x that probably promised to the CEO or something like that once they give you the budget for the relevant tools. Thank you so much.
Our next speaker is introducing Minimax's latest model and how it powers next-gen experiences for code generation. Please welcome to the stage Senior Researcher at Minimax, Olive Song.
Hi everyone. I'm Olive. It's my great honor here today to present on our new model, Minimax M2. I actually lived in New York City for 6 years, so it feels great to come back, but with a different role. I currently study reinforcement learning and model evaluation at Minimax. Let me just get a quick sense of the room. Who here has heard or have tried of Minimax before? Oh, a couple of there, yeah. Not everybody, but I guess, yeah. But here's the value, right, of me standing here today. So we are a global company that works on both foundation models and applications. We develop multi-modality models, including text, vision language models, our video generation model, Hello, and speech generation, music generation stuff. And we also have many applications, including agents and stuff in-house. So that's the specific thing that's different from the other labs or other companies. So we both develop foundation models and applications. So we have research and developers sitting side by side working on things. So our difference would be that we have firsthand experience from our in-house developers into developing models that developers would really need in the community. And here I want to introduce our Minimax M2, which is an open weight model, very small, with only 10 billion active parameters, that was designed specifically for coding workplace agentic tasks. It's very cost efficient. Let me just go over the benchmark performance because people care about it. So we rank very top in both intelligence benchmarks and also agentic benchmarks. I think we're on the top of the open source models. But then numbers don't tell everything because sometimes you get those super high number models, you plug into them into your environment and they suck, right? So we really care about the dynamics in the community. And in our first week, we had the most downloads. And also, we climbed up to top 3 token usage on OpenRouter. So we're very glad that people in the community are really loving our model into their development cycle. So today, what I want to share is how we actually shape these main model characteristics that made M2 so good in your coding experience. And I'm gonna present to you the training behind it that supports each one of them. From coding experience to long horizon state tracking tasks, to robust generalization to different scaffolds, to multi-agent scalability. So first, let's talk about code experience, which we supported with scaled environments and scaled experts. So developers need a model that can actually work in the language they use and across the workflow that they deal with every day. So which means that we need to utilize the real data from the internet and then scale the number of environments so that the model, when during training, for example, during reinforcement learning, it can actually react to the environment, it can actually target verifiable coding goals and to learn from it. So that's why we scaled both the number of environments and also our infrastructure so that we can perform those training very efficiently. So with data construction and reinforcement learning, we were able to train the model so that it's very strong, it's full stack multilingual. And what I want to mention here is that besides scaling environment that everybody talks about, we actually scale something called expert developers as reward models. So as I mentioned before, we have a ton of super expert developers in-house that could give us feedback to our model's performance. So they participated closely into the model development and training cycle, including problem definition, for example, bug fixing, for example, repo refactoring and stuff like that. And also they identify the model behaviors that developers enjoy, and they identify what's reliable and what developers would trust. And they give precise reward and evaluation to the model's behaviors to the final deliverables so that it is a model that developers really want to work with and that can add efficiency to the developers. So with that, we were able to lead in many languages in real use. And the second characteristic that Minimax M2 has is it performs good in those long horizon tasks. Those long tasks that require interacting with complex environments, that requiring using multiple tools with reasoning. And we supported that with the interleaved thinking pattern and reinforcement learning. So what is interleaved thinking? So with a normal reasoning model that can use tools, it normally works like this. You have the tools information given to it, you have the system prompts, you have user prompts, and then the model would think, and then it calls tools. It can be a couple of tools at the same time, and then they get the tool response from the environment, and then it performs a final thinking and delivers a final content. But here's the truth, right? In real world, the environments are often noisy and dynamic. You can't really perform this one test just by once. You can get tool errors, for example. You can get unexpected results from the environment and stuff like that. So what we did is that we imagined how humans interact with the world. We look at something, we get feedbacks, and then we think about it. We think if the feedback is good or not, and then we make other actions, make other decisions. And that's why we did the same thing with our M2 model. So if we look at this chart over a diagram on the right, so instead of just stopping after one round of tool calling, it actually thinks again and reacts to the environments to see if the information is enough for it to get what it wants. So basically, we call it interleaved thinking, or people call it interleaved thinking because it interleaves thinking with tool calling. A couple of times, it can be, tens to 100 turns of tool calling within just one user interaction turn. So it helps adaptation to environment noise. For example, just like what I mentioned, the environment is not stable all the time, and then something is suboptimal, and then it can choose to use other tools or do other decisions. It can focus on long horizon tasks. It can automate your workflow using, for example, Gmails, Notions, Terminal, all at the same time. You just need to maybe make one model call with minimal human intervention. It can do it all by itself. And here's a cool illustration on the right because it's in New York City. I feel the vibe of trading and marketing. So you can see that there was some perturbations in the stock market. I think last week, and then our model was able to keep it stable. So just like I said, there's like environment noise. There's new information. There's news. It looks like there's like other trading policies and stuff like that, but our model was able to perform pretty stably in these kind of environments. And the third characteristic is our robust generalization to many agent scaffolds, which was supported by our perturbations in the data pipeline. So we want our agent to generalize. But what is agent generalization? At first, we thought it was just tool scaling. We trained the model with enough tools, various tools, kind of new tools, we invent tools, and then it would just perform good on unseen tools. Well, that was kind of the truth. It worked at first, but then we soon realized that if we perturb the environment a little bit, for example, we change another agent scaffold, then it doesn't generalize. So what is agent generalization? Well, we conclude that it's adaptation to perturbations across the model's entire operational space. If we think back, what's the model's operational space that we talked about? It can be tool information. It can be system prompts. It can be user prompts. They can all be different. They can be the chat template. They can be the environment. They can be the tool response. So what we did is that we design and maintain perturbation pipelines of our data so that our model can actually generalize to a lot of agent scaffolds. And the fourth characteristic that I want to mention is the multi-agent scalability, which is very possible with M2 because it's very small and cost-effective. I have a couple of videos here. This is M2 powered by our own Minimax agent app. We actually have the QR code downside, so if you want, you can just scan and try it. So it's like an agent app we developed. And here we can see different copies of M2, right? It can do research. It can write the research results and analyze it and put it in a report. It can put it in some kind of front-end illustration, and they can work in parallel. So because it is so small and so cost-effective, it can really support those long-run agentic tasks and tasks that maybe require some kind of parallelism. So what's next, right? For Minimax M2, from what I've introduced, we gathered environments, algorithms, data, expert values, model architecture, inference, evaluation, all these stuff to build a model that was fast, that was intelligent, that could use tools, that generalizes. What's next? For M2.1 and M3 or in the future, we think of better coding, maybe memory or context management, proactive, AI for workplace, vertical experts. And because we have those great audio generation, video generation models, maybe we can integrate them. But all our mission is that we're committed to bring all these resources, whatever is on the screen and maybe more, and values, and put them all together to develop models for the community to use. So we really need feedback from the community if possible, because we want to build this together. And this is kind of a race that everyone needs to participate. And then we are committed to share it with the community. Yeah. And that's all the insights for today. We really hope you to try the model because it's pretty good. And then you can contact us up there. You can try the models by scanning the UR code. Yeah, basically, that's it. Thank you all for listening.
Ladies and gentlemen, please welcome back to the stage, Alex Lieberman.
Let's give it up again for Olive and all the other speakers from the morning. It is time for lunch. Very exciting. One thing I want to say before we head out for lunch, and it's going to be downstairs in the expo. Check out all of the booths, talk to people, have food. Is, my own experience with going to conferences is, even though I come up, talk on stage a lot, I find it very difficult to engage in conversation with people when there's like these little small group settings. I don't know, like, can I go and chat with people? Can I not? This is a kind of awkward. I give you all permission to butt into conversations, introduce yourself. Ben and Swix have done an incredible job of cultivating such a high quality community here. And the most value you will get is not just from these incredible presentations, it's from meeting other folks in the crowd. So please, you have my permission. Butt into conversations, introduce yourself, share what you've learned with folks. And if you need any sort of icebreakers to get the conversation going, I have two for you. One is just go into a group and share your hottest take on the state of AI today. It's a great way to get off to a good start with someone. The second, a little less intense, is a hot dog a sandwich? Is cereal in milk a soup? That is how you're going to start the conversations with folks. Everyone, enjoy lunch. We'll see you back in an hour. And thanks so much for your time.
That concludes our morning session.
How's everyone doing? Good lunch? Excited for the afternoon sessions? Out of curiosity, did anyone have the hot dog conversation? Does anyone who thinks that a hot dog's a sandwich? We got one. We got two. Anyone think a hot dog isn't a sandwich? Most of the crowd. That is usually the consensus. One other question. Who thinks that they have the hottest take on the state of AI or AI engineering right now in the room? Anyone think they have the hottest take? Well, I'll give you a tee up for later. My co-founder, Arman, is speaking around 4, and I would say he has one of the hotter takes I've seen, which is he thinks all engineers should be paid like salespeople based on output. That is going to attract a lot of debate, and I give you full permission to debate him after his talk. Well, are you guys ready to jump into the next group of sessions? Let's do it. We will be diving into proactive agents from Google Labs, building Gen BI at a Fortune 100 business, deploying AI within Bloomberg's engineering org, lessons learned building an AI browser, and developer experience in the age of AI coding agents. With that, please join me in welcoming our next speaker, Kath Korevec, Director of Product at Google Labs. Let's give it to her.
Everybody. I'm so excited to be here. I love New York, and I love meeting everybody here. And I am Kath Korevec. I'm from Google Labs, and I work on this little team called Ada, and I'm going to be talking about some of the stuff that we've been doing on this project called Joules. So a few months ago, in my household, our dishwasher broke. And while it was being repaired, my husband decided that he was going to do all the dishes. And so he told me he was going to do this, but every single night I found myself reminding him to do the dishes. And you can imagine that got old pretty fast. And I realized that even though I wasn't physically washing the dishes, I was still carrying this mental load. And I know a lot of you can probably relate to this. I was keeping track of whether or not that task was done, following up, making sure that things kept moving. And I realized in that moment that that's exactly where we are with asynchronous agents today. They can handle some of the work, but we're still the ones as developers carrying that mental load and monitoring them. So here's the truth. Humans, we are serial processors, not parallel ones. We can juggle multiple goals, but we execute them in sequence, not all at once. When you manually kick off a task in Joules, you're usually waiting to be able to move on. And it's that pause, it's that gap in attention where we really lose momentum. And this is actually backed up by science, where humans actually we think we're multitaskers, but we're actually executing many tasks very rapidly. But switching between these tasks comes with a huge cost. It can cost up to 40% of your productive time. So that's like half a day lost to switching contexts and reloading. So if humans are unitaskers, what's the solution here with agents? So for async agents, in order for them to succeed, developers can't be expected to babysit them. We've all seen that post on Twitter of 16 different Claude code tasks running in parallel on 16 different terminals on 3 different huge browsers or huge monitors. And when I first saw this, I thought, God forbid that is the DevX of the future. I don't want to manage work. I don't want to manage my agents. I want to be a coder. I want to build. And so we need to think, we need collaborators in our system that we can trust. Agents that really understand context, can anticipate our needs, and they know really when to step in. And then I think finally we're reaching that point with models where they're getting better and better at executing end to end, as long as they understand what our goals are clearly. And that's where trust really becomes this unlock, where you can trust the system to know what's missing, to fill in the gaps, and to really keep progress moving forward while you manage on something else, while you focus on what matters most. And essentially, we want Joules to do the dishes without being asked. So most AI developer tools today are fundamentally reactive. You open up your CLI or your IDE and you ask the agent to do something and it responds. Or it waits for you to start typing and then it auto-completes a suggestion. And there's a benefit to this model. It's very efficient. It only uses compute when you explicitly ask for it. But the real question I'm asking myself is this how I want to manage AI? And if you think about in the future, imagine a world where compute is not a limiting factor anymore. Instead of a single reactive assistant for instructions, you could have dozens of small proactive agents working with you in parallel, quietly looking for patterns, noticing friction, and taking on the boring tasks that you don't want to do before you even ask. It can do things like fixing authentication bugs that you've been avoiding, updating configs, flagging potential errors, preparing migrations, and all of this can happen in the background, triggered off of things in my natural workflow. So I really think there are 4 essential ingredients that make up proactive systems today. There's observation. The agent has to really continually understand what is happening, what your code changes are, what your patterns are, what your workflow is, et cetera, to get context about your entire project. And then there's personalization, and this one's difficult. It has to learn how you work, what you care about, what you tend to ignore, what your preferences are, the code that you absolutely don't want to ever touch. And then it has to be timely as well. If it comes in too soon, it's going to interrupt you, and if it's too late, then the moment is lost. And it also has to work seamlessly across your workflow. It has to insert itself into spaces where you naturally work already, in your terminal, in your repository, in your IDE, not forcing you to go somewhere else to some application that's secret or that you forgot about. So bringing all these tools together, you can imagine, is not trivial. So I was running this presentation. You want to be able to ask your agent to understand your workflow and anticipate your needs, and then intervene at exactly the right moment without breaking your workflow. And that's when it really starts to feel like magic. The interesting thing is, these proactive systems, they're all around us today. One of my favorite examples is Google Nest, where you put it in your house, you install it, and then you configure it, and then it starts to learn your habits as you leave the house, as you come back, as you go to sleep, as you wake up in the morning, and then pretty soon, you don't have to think about climate control in your house anymore because it's learned what your habits are. Another one is your own body. Your heart rate elevates as you go for a run or start to work out, or it anticipates that you're about to fall, and so it reacts before you consciously think, I'm going to put my hand out. So when you look at it like that, proactivity for AI is actually not that futuristic. It's very familiar, and it is very human. And that's exactly the point. What we're building is tools that behave more like a good collaborator and less like command line utilities. So we're already doing this in this tool called Jules, which is this proactive asynchronous autonomous coding agent from Google Labs. And we're doing this in kind of 3 levels of proactivity. Level 1 is where a collaboration really starts to emerge. And this is how Jules works today, where it can detect things like missing tests, unused dependencies, unsafe patterns, and then it starts to automatically fix those things as it's doing other tasks that you've asked it to do. This is sort of like this attentive sous chef in your workflow where it's keeping the kitchen clean, the knives sharp, the kitchen stocked, so that you can focus on what comes next. And that's the beginning of proactive software. At level 2, the agent becomes more contextually aware of the entire project. It observes how you work, the code you write. If you're a back-end engineer, maybe you need help with React. If you're a designer, maybe it wants you to, maybe it'll help write the database schema. And then it learns what your frameworks are and what your deployment style is, et cetera. And this is the kitchen manager. This is the person in your workflow keeping the rhythm and anticipating what you need next. And then comes level 3, and this is what we're working on pretty hard right now going into December. And I'll show you a little bit of what we're going to be shipping in December in a minute. But level 3 is where things start to converge around that context. It's where the agent starts to understand not just context, but also consequence. How these choices are actually affecting the users of your products, the performance, and the outcomes. And at that level, we have this thing, Jules. We also have an agent called Stitch, which is a design agent, and another one we're building called Insights, which is a data agent. And they're all coming together to build this collective intelligence across your application. Jules can see what's breaking in the software. Stitch understands how users are interacting with it. And Insights connects behaviors from real-world signals like analytics, telemetry, and conversion rates. And then together, they can propose improvements across boundaries of how the system all works together. doing things like performance fixes to improve UX, and then design changes to prevent regressions. And then all of that is organized based on live data. So the trick here is that the human stays firmly in the loop. You're observing what the agents are doing, you're refining when you need to intervene, and then you're redirecting it when it has been misdirected. So level 3 isn't really about autonomy anymore. It's actually about alignment to your project. Agents and humans collaborating together across the full life cycle of your project. So right now, Jules is focused on this code awareness piece. It understands the environment, the frameworks, and the project structures. And we're moving towards more of that system awareness. So things that we're introducing in Jules now, we've added something called memory, which I'm sure a lot of you are familiar with. It's the ability for Jules to write its own memories, and you can edit them and interact with them. It can edit them, and it understands and builds this memory and context and knowledge of your project as you work with it. We've added a critic agent, which works adversarially with Jules to make sure that the code is high quality, but then also does a full code review. And then we've added verification, where Jules will write a playwright script, take a screenshot, and then put that back into the trajectory for you to validate. And then we're also doing things like adding a to-do bot that will look through your code and look through your repository and pick up on anything where you've said, this is a to-do I want to get to in the future, and it will start to proactively work on those things with that context. We're also adding in things like best practices, where Jules will understand best practices and start to suggest those, and also environment setup. We have an environment agent that we use internally for running evals, and we're extending that externally to better understand how your environments work and set those up for you. And then we also are adding something called a just-in-time context. It's like a Jules cheat sheet, where if it's doing something very specific and gets stuck, it can just immediately look at that cheat sheet instead of reaching out to you. So this is all moving Jules very close to being that proactive teammate, not just this reactive assistant. Okay, so this morning, I was talking to my team back in San Francisco, and I was thinking, okay, I'm gonna do a live demo, but the live demo gods did not align with me this morning. We still have CLs that are being pushed to staging right now. So I'm gonna walk you through a little bit of this, and if you know Jed, he's gonna, I think, be talking tomorrow. We're gonna affectionately try to fix Jed's code here. So this is a view of proactivity, and this is Jules, where you prompt it. And the first thing that you do when you configure and enable proactivity is Jules will index your entire code base. It'll index your directory and start looking for things that it can do, and then that'll show up on the screen. So right here, we're looking at a little bit more in this repository 80K Python, and it's indexed the repository, and it's found a bunch of to-dos, it's found a bunch of best practices that it can update, and it's giving me some signal about what it's finding. And so you can see the signal is high confidence, medium confidence, and low. And so it's actually telling me what it thinks it can achieve based on what's in my code and what it wants to do. And so it has high confidence in green, medium in purple, low in yellow way down at the bottom. And so I can go through this, and I can manually click these and say, I want to start these. And so I don't have to think about the prompt. I don't have to look at the code. I can do kind of less cognitive load here. We're working on something to just start these automatically. And so that's coming in the future. But I can also delete these. I can say, hey, this one isn't for me, isn't good. And so once it gets started on a task, I can kind of drill into it and see a little bit more. I can peek into the code that it is suggesting it work on. I can find the location of that code, and it also gives me some rationale about why it wants to work on that code, what it's doing, et cetera. And so it's giving me a lot more context and helping me trust that it knows what to do here. Okay, so that's proactivity. That's coming in December, and hopefully we'll be able to give that to everybody here. We're very excited about it. And I want to tell you a little story about something my husband and I were working on, just to kind of wrap things up. We tinker a bunch with hardware, and we live on this slow street in the middle of San Francisco in Haight-Ashbury district. And so on Halloween, we get a lot of people walking by our house, and so we were trying to take advantage of that with our Halloween decorations. And so we built this 6-foot animatronic head that sits in the front of our house. It's this old Victorian house. And he sculpted it out of foam, epoxy, and fiberglass. And then our kids also called this lovingly the bald head. And it's based off of, if you ever saw Pee Wee Herman from the 80s, it's based off of the Pee Wee Herman, Pee Wee's Big Adventures head. So while my husband was doing this, I was spending my time working with Jules on updating the firmware, controlling the stepper motors, working on the LEDs and the sensors. And for me, that's the fun part for me, is like really getting creative with what the LEDs are doing. So I wanted to focus on that, the LED animations. But I ended up spending most of my time actually fixing bugs and swapping libraries and doing things like that. So what I would do is I would prompt Jules, I'd wait 10 minutes, and then I would repeat. And I found that process very, very tedious. And what I wanted was actually Jules to do the research. I wanted it to handle the ugly parts, where it was researching how to fix a bug, doing the debugging itself. And I wanted it to do this so that I could focus on the creative parts. I wanted the eyes to move and like follow people as they walk down the street and like have lasers coming out of its eyes and stuff. I mentioned it was Halloween. It was very scary. But I couldn't really do as much of that. And I ended up actually not shipping as much as I wanted to with this animatronic bald head. And so it's that gap that we actually want to close. It's the space between, with Jules, it's the space between that tool friction and creative freedom that we're trying to unlock with these kinds of proactive agents. So what I really want you guys to take away from it, I give this advice to the folks on the Jules team a lot, is that the product we build today actually won't be the products that we have in the future. And I think a lot of us know that. But in reality, I want everybody in this room and everyone building, working with AI to be able to take those big steps. I think the patterns that we rely on today, Git, your IDEs, even the code, how we think about the code itself, might not exist a year from now, might not exist 6 months from now. And that's the exciting part for me. It's sort of, we get to invent the future right now. We get to describe and decide how software is made and built, kind of all the people in this room. So my challenge to you is to not be afraid to question the old ways of how you're building software, because really the future is coming faster than any of us know. It's probably already here. And the cool thing is we get to build it together. Thank you.
Our next talk is a case study from the enterprise on incremental rollout of AI. Here to provide us with a blueprint for making AI transformation fundable, governable, and real inside large, risk-averse organizations is engineering leader at Northwestern Mutual, Asaf Board.
Doesn't this look like something's going to drop from the ceiling? Like a ground zero type thing? Be honest, like who has a buzzer that if I really suck, they press it and everything falls down through the trapdoor? No? Yeah? Okay, who was it? Okay, you tell me if I'm doing okay or if I should take a couple of steps back, right? So hi everyone, I'm Asaf. And I'm here to talk about Gen BI and kind of first disclaimer, this presentation was not created with Gen AI. To be honest, I actually started doing it with GPT-03 back in August. And then I did kind of a first draft. And then a couple of weeks back, I wanted to come in and refresh it before the conference. And then GPT-5 took over, completely messed up my slides. So I ended up doing it manually, kind of old-fashioned. So if I'm missing like an M dash somewhere in the middle, let me know after, okay? So first of all, a bit of housekeeping. What's Gen BI? So it's a fusion of Gen AI and BI. It's basically an agent that helps people answer business questions with data, like a business intelligence person would do in real life. The reason that we're pursuing Gen BI is really because of the data democratization that it can bring, right? So having access to data at your fingertips without having to be reliant on a BI team that helps you find a report, figure out what it means, understand your world before they can even give you any kind of input. So that's Gen BI. A bit about Northwestern Mutual, that's where I work. So we're financial services, life insurance, and wealth management, been around for 160 years. Some very impressive numbers there. But first of all, I want to say, why is Northwestern Mutual a great place to do Gen AI? We got a lot of data, we got a lot of money, we got a lot of use cases, and we got access to some of the best talent anyone can dream of. Really, truly humbled by the people that I get to work with. But on the flip side, why is it hard to do Gen AI at Northwestern Mutual? Because it is a very risk-averse company, right? If you think about it, our main motto is generational responsibility. I call it don't F shit up. Because what we end up selling to people is a decades-long commitment, right? You buy life insurance now. If you stay with us until it comes to term, so to speak, that can be 20, 40, 80 years down the line, depending on when you buy it and how long you get to live. And so stability is something that's very important for us because it's important for our clients. So how do we balance stability with innovation? That's what I want to talk about today. And really the four main challenges that we had when we even came up with the idea, kind of a pie in the sky Gen BI concept. First of all, no one's done it before, right? Truly, no one's done Gen BI in this fashion in the past. Secondly, and this was really a preference for us, we wanted to use actual data that's messy because we knew that that's where the real challenges are going to be, right? Understanding actual messy data for a 160-year-old company and how can we perform well within that ecosystem. The third was kind of a blind trust bias. So the trust that we had to build was both with the users, but also with the leadership of the company, right? How can we bring accurate information, accurate answers to people when all of these things that we know about and everyone's talked about is just out there, right? No one's blind to the trust barriers. No one's blind to the accuracy barriers. So how do we convince that this is actually something that we can trust in the company? And lastly, but really firstly, when we go to approach this from an enterprise perspective, budget impact, right? How do we convince someone in a leadership organization where risk aversion is ingrained in the DNA to even invest in something like this that no one's done before? We don't really know how we would do it. We're not even sure how it would look like when it comes to term. So I'll start kind of one by one. And first of all, really talk about why we chose to use actual data and not synthesized data or cleansed data. So really, it's about making sure that we understand the actual complexities that we will have to face when we eventually want to go to production, right? We know that building POCs and demos is so easy, but the gap from POC to production is so broad, especially in this Gen AI space, especially because we don't know upfront how to design the system, what we would expect it to behave like. So making sure that we operate with real data just gave us that extra confidence that when something works in the lab, it's very likely to also work in reality. But also, and maybe not in the least less important, is that we got to work with actual people who work with the data day in and day out. And that gave us two things, okay? First of all, subject matter expertise, which are super critical for us to be able to validate that the system is actually working, gave us a lot of real live examples of what people are actually asking in a corporate and what people have answered to them. So basically the evals, right, and all the testing and stuff. But at the end of the day, it also brought the business to be a part of the research project itself, and they became kind of bought into the idea as part of the process. So we didn't just test something in the lab and then had to convince someone to go ahead and use it. The end users were part of the research process itself. And so when eventually it matured enough so we can take some of that to production, they were already there and they actually were pooling that. They told us, we want to take this, how can we wrap it, how can we package it quickly enough so we can put it into practice. And the next part was really about building trust. So this is about building trust, first of all, with our management team, right? Now, I don't know about you, but last time that I got $1 million to do a research project that I wanted in a pie-in-the-sky idea, I woke up from the dream, and I realized that this is not how things work in reality. You don't just get $1 million and go ahead and try something out. You had to show that you know what you're doing. And part of what we did, it's kind of listed out here, but obviously, you know, we did all the regular stuff, right? We worked in a sandbox environment. We made sure that we're not using actual client data. We made sure to put in all the security risks aside. But one of the first approaches that we said we're going to take is we're not just going to build a tool that's going to be released to everyone, right? We understood very quickly that how people interact with the tool, their ability to verify that what they're getting is right, and also give us feedback, changes dramatically depending on their expertise and understanding of the data. So we took that crawl, walk, run approach that basically said, we're first going to release it to actual BI experts, right? People that would be able to do it on their own and know what good looks like when they get it. And we're just going to expedite the process for them, kind of like a GitHub Copilot. The next phase would be to bring it to business managers. And again, people who are closer to the BI team, but when they see a mistake, they can pretty much figure out that what they're seeing is wrong because they're used to seeing that on a day-to-day basis. And they might be less sensitive to these types of mistakes and be more inclined to give us that feedback instead of just dumping it aside and never using it again. Giving this type of tool to executives in the company, I don't even know when we're going to get there. Right? Like an executive, they want clear, concise answers that they know they can trust. We're definitely not there yet. I think that's the vision at some point in time, but the system is not accurate enough for us to get there. Maybe it never will be. Another lever that we kind of used to build inherent trust in the system is that we said, well, in the get-go, we're not going to even try to build SQLs. Right? This is very complex. This is very hard, even for a person. So we said, step number one, let's just bring information that is already in the ecosystem that's already verified. Right? So we have a lot of certified reports and dashboards. And actually, in the conversations we had with some of the BI teams that we worked with, they told us, guys, like 80% of the work that we do is basically sending people to the right report and helping them figure out how to use it. So the report is already there. And that, again, built some inherent trust into how we architected the system because we said, we're not going to make up information. We're just going to deliver you the same asset that you would have gotten anyway, just in a much faster, much more interactive way. And that was the alignment of expectations that we did very upfront with the users and also with the management team. Now, the biggest process, or kind of the most important approach that we took when approaching our leadership team and convincing them that we want to do this, was to create a very gradual, incremental process that gave them a lot of visibility and control. And it was very important for us to build incremental deliveries throughout that process so that not only do they have the visibility into what are we funding now, what do we get out of it, they actually had business deliverables they could realize potential from throughout the process. And at any point in time, they could pull the plug, right, and say, okay, like it's not working well, or we got enough out of it, or the next phase is so unknown and long that we don't want to further invest in it. And this is how we basically broke it down. So phase one was just pure research, right? We kind of did the shift from natural language to SQL. We figured out how to write responses. We figured out how to understand questions that are coming in, just kind of setting the stage. Phase two was about really understanding, okay, so what does good metadata and good context look like in the perspective of a BI agent, right? It looks very different if you're just chatting with something or if you're trying to do a RAG with unstructured data like documents and business knowledge and stuff like that. And this phase on its own already had impact on the business because when we define what good metadata looks like for an LLM, we could immediately apply that also to just the ecosystem of data users across the enterprise. And by understanding how to extract LLM from the information, we could also how to extract metadata. Sorry, here's where the trap door comes into play, right? we could also project that on how or what good metadata looks like for humans interacting with the data. We have another initiative around semantic layer going on, which tries to model exactly that, and this provided a very valuable input to that initiative as well. But the immediate next step was basically just doing this kind of multi-context semantic search, right? People coming in, asking different questions, and having the system figure out what's the right context, what's the right information we need to bring them. And this is something that could already be packaged as its own product and delivered, and basically just do kind of a data finder and data owner finder, which is something that could take anywhere between 2 to maybe 4 weeks in an enterprise like Northwestern Mutual, just finding what data exists and who owns it so I can start the conversation with them. And the next layer was really about pulling in information and trying to do some light pivoting around the data. Each one of these steps, as you can see, also created an input to the following step, so that the research itself was kind of self-propelling, and there were incremental outcomes coming out of each one of these phases. The next one is more kind of setting it up for enterprise-level usage, so understanding roles of different users coming in, what they may be asking about, what type of access we want to give them, etc. And eventually, and this is still some ways to go ahead, building kind of a fully fledged Gen BI agent, which doesn't only quote information from existing reports, but can actually run SQL queries on its own, pull in more data, do more sophisticated joins between different data so it can answer more complex questions. So that's the roadmap, right? That's kind of the high-level plan. Now, why did that work well? Kind of quickly summarizing, we talked about, so we get value early and we get value often. Each one of this was a 6-week sprint, at the end of which we had a very tangible deliverable coming back to the business that we could decide to productize. And at any point in time, we could decide how we want to move forward. There was transparent progress. There was incremental business value. Each one of these steps allowed us to learn something that helped feed the next step. And maybe the most important part, and that's the bottom line here, and that's the part that executives really look at, how do we control the risk in continuing to invest in this type of research project? And this is really about eliminating things like sunk cost bias, right? We already paid, whatever, $1 million. Let's just get through the project, see what we get at the end. This eliminates the fear of competitors coming in, and maybe we don't need to continue investing in this, right? So everyone in the industry is researching Gen BI, and there are solutions like Databricks Genie that are coming up, and they're getting better and better. Maybe at some point in time, it's better for us as an organization to actually adopt Databricks Genie. But at that point, again, first, it's much easier for us to pull the plug and the funding, but we already have a good understanding of what good looks like. We have benchmarks that we used for ourselves when testing our own system that we can test a third-party solution with, and we know what to expect, right? We know what works, we know what doesn't, we know what a kind of fluffy demo from a vendor would look like, and we know where to drill in to ask the tough questions. So let's see kind of what it looks like under the hood and how we productize different elements of this architecture. And maybe kind of very quickly, why can't we just do it with ChatGPT? So, just dumping a schema into ChatGPT doesn't work. Usually schemas are very messy. It's not easy to understand the context and the meaning of things. And eventually governance is super important. So there was a lot of governance built into the architecture that was very hard to apply on ChatGPT from the outside, but even solutions like Databricks Genie is third party, much harder to govern from the outside than from the inside, but still TBD. So the stack kind of looks like this. We have a data and metadata layer that we produced. We have 4 different agents that are running across the pipeline. A metadata agent that understands the context, a RAG agent that finds the different reports, an SQL agent that can pull more data if we need that, and then eventually what we call a BI agent that takes all that information and delivers an answer to the question that was asked. On top of that, we slap governance and trust and orchestration, and eventually some kind of a contextual UI. And this is how the flow goes. So when a business question comes in, we push it into the orchestrator and basically decides how to facilitate the process. The first thing that we do is understanding the context. So that's where that metadata agent comes in, works with the catalog, works with all the documentation that we have across the system to understand what we're being asked about and what's the relevant information to share. Then we go to the RAG agent, which tries to find an existing report, again, out of a list of certified reports that we know are allowed for people to use, and people have spent a lot of time fine-tuning them and making them as accurate as possible. If we can't find the report, or if it's not exactly what we need to use, that's where we go to the SQL agent that basically tries to create a more exact query or a more elaborate query. And even if the report that we have is not usable as is, it gives us that initial seed of a query that we can then expand on rather than having to build one from scratch. So it's kind of like a few-shot example, but in this case, the example that we give is very, very close to the actual result that we're expecting to get. We then execute it against the database, push it into the BI agent, which translate that to a business answer and not just dumping data back on the user. And this is what goes into the final answer. Now, there's obviously some kind of a loop that says, if I'm in the same conversation, I'm probably talking about the same data, so we don't have to talk about this or do this again and again. Now, each one of these three components, each one of these three agents can be packaged as its own product and delivered to production with a very tangible and actual impact on business metrics, okay? And that's the kind of beauty of this approach, that after we productize each one of these, we could have basically said, stop, or let's move forward. And just some giving bottom line numbers around some of these. So just the RAG agent that pulls the right report allowed us to take about 20% of the overall capacity of the BI team that basically said, all we do is just share the right report with the right person. So we were able to automate around 80% out of those 20%, and we're talking about a team of 10 people. So roughly 2 people, full-time job, all they do is find the right report and send it to the right person. The metadata understandings that we got from learning how to interact with the data through an LLM allowed us to run A/B tests in the semantic layer project that we did. And that allowed us to prove back again to the senior leadership in the company that there is value and tangible value, measurable value in enriching metadata. And we did that basically by running a battery of questions against a database that had good metadata and one that didn't have good metadata. And we show how much better an LLM performs when having the right metadata in place. So basically proving the value of something that can be very fluffy, like, hey, let's bring in more documentation into the code. Right now, we're experimenting with the data pivoting bot. So once you have a dashboard or a report, be able to change the time horizon, some of the views, some of the segmentations and the groupings of the data. Again, kind of real time without having a person do that for a business stakeholder. And some of the next steps is really evaluating the tools that are out there for Gen BI, like Databricks Genie, for example. And we're going to go into a much more rigorous process of enriching our catalog with metadata and documentation. And that's also going to come out of a lot of the learnings that we got from the research that we've done. So even if we don't end up writing a Gen BI agent full-fledged end-to-end, we already got a lot of value back from this. And this is really what allowed our senior leadership team to continuously invest in this project quarter over quarter. One thing that I want to wrap up with is just a couple of thoughts I had about the future. So I think we talk a lot about how to prepare data. I think that's going to be a huge area in the market, and there are going to be probably a lot of companies and tools that are going to help us with that. Building very specific, task-specific models and applications. I think a lot of startups and companies are going to come up from that area. Copilot is really making sure that we meet the users where they are. And securing of models, obviously a very big thing. The last thing is the one I want to focus on the most, because that's kind of a recent thought that came to me a couple of weeks ago. How we do pricing of SaaS in the Gen AI era. This is really about the fact that one individual person today can be 10x more effective than they used to be in the past. And then do we price software based on seats? Or do we price software based on how much they used it? Or do we price software based on the value that they got out of it? Salesforce is already experimenting with that. So the data cloud product at Salesforce is starting to be usage priced and not seats priced. And I think this is going to have a big impact on just the kind of SaaS economics worldwide. And it doesn't even matter if the product itself is Gen AI. It's really about what does the person using the product can do and what can they do in their other time, and whether it still makes sense to price it by how many employees you have or how much work you get done with the employees that you have. That is me, and thank you very much for listening, and thanks for not opening the door on me.
Our next presenter is the head of technology infrastructure engineering at Bloomberg. He's here to tell us what they learned deploying AI within Bloomberg's engineering organization. Please join me in welcoming to the stage Lei Zhang.
All right, I don't have a joke about the dog. I don't have a joke about the hot dog either. So I would just jump to the topic right away. So my name is Lei. I lead the Department of Technology Infrastructure in Bloomberg. So we're basically a group of technologists focused on global infrastructure. Think data centers, connectivities, developer productivities, think SDD's tooling, and also reliability solutions, think telemetry and incident responses, right? So depends on the audience. Sometimes you're familiar with what Bloomberg is, sometimes you don't. So I thought it might be a good idea to talk a little bit about our company. So there's no better way to talk about our company by sharing some numbers. I want to highlight a few numbers. We have more than 9,000 engineers, and most of them are software engineers. We handle a lot of market techs, which in the billions and 600 billions, I believe. And we also have tons of folks focused on AI research and engineering. So we have more than, really today's 500 plus employees focused on AI products for sort of our customers. So takeaway here is we are, I guess, building a lot of software and use a lot of data to empower our flagship product, which is called the Bloomberg Terminal, and to really support our users to make the most important decisions for them to do their job the best. In the technical lens, a lot of time kind of to explain that we actually have one of the largest private network in the whole world. We also have one of the largest JavaScript code base in the world. Because the domain we're in, so Bloomberg Terminal is really, you can think of a software that supports thousands of different applications. We call them functions, right? Email is a function. News is a group of functions. Let's say fixed income price to yield calculation to spread calculation is another function. Trading workflows is another group of functions. So there's many, many, many different types of functions. As you can imagine, we kind of have to utilize different technologies to really support those functionalities. We also been increasingly more than use, but also contribute to open source communities. For this audience, I guess I want to call out, we kind of helped creation of the K-Serve, Envoy AI gateways, and among many, many other things that we deploy in-house and support the communities. Again, in summary, there's a lot of software, there's a lot of data. We kind of have to figure out how to make the best of AI tooling to support us to do our engineering work. All right, so get to what is AI for coding. We started about 2 years ago, maybe a little bit more than that. And as I guess the rest of the world, we look at the toolings provided. And I apologize if your logos are not here. But as you can imagine, it's kind of like overwhelming, right? There's so many things, and every day there's news about this is great, this is great. So at the time, we actually didn't know what all the AI solutions can help us to boost our productivities as well as stability. But one thing we knew at the time is unless we deploy and try, we wouldn't know what's the best way to benefit from all the awesome work and a lot of folks are contributing to. So at the time, we quickly formed a team of people, start kind of like release a set of capabilities so that people start iterating on utilizing the toolings. And then, of course, we are a data company, so kind of want to get a sense of how we measure the impact and what we can do from the capability we provide, right? So we look at the typical developer productivity measurements. We ran a few surveys. It was very obvious that people felt like there's much quicker proof of concept. People roll out tests. There's a lot of one-time use scripts being generated. And then the measurements dropped actually pretty quickly when you go beyond all the greenfield type of thing, right? And then we start thinking like, okay, so what are the things that we should really be doing using all those wonderful things so that we can really make a dent in the space? And then at that time, we also kind of like also be thoughtful of unleash a very powerful tooling, right? The benefits is it's very fast. The challenge is also it's very fast, right? For any of you who actually dealt with hundreds of millions of lines of code, you probably understand the system complexity is at least exponential or at least polynomial, I guess, function of your line of code or software assets, right? So at some point, you kind of want to be very careful what you do with your software assets. And what we thought, so maybe we should look at some of the basics. One idea we had is, all right, so AI for coding, there's a narrow definition of what coding is, but there's also a broader definition of what software engineering, right? And then maybe we can also look into some of the work our developers don't really prefer to do. For instance, some maintenance work, some of the migration work, some of the maintenance work and stuff like that. So I want to give some examples of the things that we've been trying and we think there's pretty good return on investment. So the question we ask ourselves is how do we evolve our code base, right? The first one is, wouldn't it be cool the day you get a ticket saying, hey, you know, this piece of software needs to be patched, and at the same time you have a pull request with the fix, with the patch, and also with the thinking why the patch happened that way, right? So it's kind of like we're trying to broadly deploy something called uplift agents, broadly scan through our code base and figure out what the patch would be applicable and be able to apply those patch. Step back a little bit, we did have a regex-based refactoring tool. It works to some extent, but it's limited, right? Now with LLMs and other tooling, so we are able to see much better results from the uplift agents. So there are a few challenges in case you also plan to deploy such capabilities. The first one is, I guess any AI or ML, it would be really nice if there's some deterministic verification capability. Oftentimes it's not so easy, especially if you have test cases, if you don't have good linter, if you don't have good verification. The patch can sometimes be difficult to be applied. And one thing we also realized when we deploy AI tooling is the average open pull requests increased and time to merge also increased because you're spinning a lot of new code and then still we have to review the code and merge the code, right? So time to merge become a challenge sometimes. And the last one is, I think it applies to any Gen AI thing is the shift becomes what do we want to achieve rather than how we want to achieve, right? So the second example that I want to share is the other area that people kind of like sometimes really impact our productivity in a negative way or impact our stability in a negative way is how we handle instance. So we're trying to develop and then deploy instance response agents. Now, the importance of this is, if you really think about GenAI tools, it's really, really fast, and it's also unbiased, right? In unbiased instance, it can go through your code base really quickly. It can go through your telemetry system very quickly. It can go through your feature flags very quickly. It can go through your call trace very quickly, and in unbiased lens. When we do troubleshooting, sometimes we have this biased view. So, okay, it must be this. It turns out to be not the case. So there's many, many interesting benefits by deploying agents from this perspective. And then the second question is, become interesting is, imagine you have an organization of 10,000 people, let's say 9,000 people, as I described. A lot of people trying to fix those problems, right? And you can have 10 teams who wants to build a pull request review bots. You have 20 teams who wants to build an instant response agents, right? They become very quickly chaotic and sometimes can have duplications. So before I talk about the paved paths, I'm going to give an example of the instance response agent. So basically, this is what a instance response agent will look like. The key part is we're going to need to build a lot of MCP servers to connect to the metrics and logs dashboards you have, connect to the topology you have, whether it's network topology or it's the your service dependency topology, your alarms, your triggers, right, your SLOs. And then we kind of don't want people just start building MCP servers without a paved path. So we created a paved path in partnership with our AI organization, and I will talk a little bit what that means. Before that, I do want to explain a little bit some of the platform principles. Some company allow teams to have a lot of freedom at the same time responsibility. In a sense, a business unit can build whatever infrastructure, whatever platform. Some organizations have a very, very strong, tight abstraction of the service infrastructure and typically kind of have to use their platforms, right? So Bloomberg is kind of in the middle. If you look at the golden ones, we kind of believe in provide a golden path with enablement teams. So my team is really a enabling team. And one of the guiding principles for us is we want to make easy things extremely easy to do. The right things extremely easy to do, and we want to make sure the wrong things ridiculously hard to do. Right? So that's the guiding principle here. Now, move on. So what is the paved path here? So the paved path is we have a gateway so that teams can easily figure out which model works the best. They can do quick experiments. They can, we can have visibility of what kind of models being used, and we can also guide through teams which model is the better fit for the problem they want to solve. We have a tool discovery, basically MCP directory via hub, so that let's say team A wants to do something, they will go to the hub. Will, okay, someone is building an MCP server already. Maybe I should partner with them to build it together, right? Tool creation and deployment is via a pass. It's basically a standard platform service where you can do your SDLC and we provide runtime environment for you as well, taking care of all the auth and side of things as well. So it really reduces friction for teams to deploy their MCP servers. And then this is kind of interesting is we want to make demo very easy so that, or I should really say proof of concept very easy so that people can try, have idea generation, because we believe in creativity come from some freedom of try different new things. But we also want to make sure the production requires some quality control because at the end of the day, stability and system reliability is at the core of our business. This is sort of the paved path that we deployed and enabled the rest of engineering, really the 9,000 software engineers, to do their job. Okay. And with all this, and then we start maybe, okay, yes, we got paved path. We have some good ideas of how to evolve our code base. How about our people, right? Now, this is where I find that any new things, any adoption of new things provide opportunity to leverage the strengths you have and also identify some of the weaknesses that you may have. So in Bloomberg, we have a well-established training program. It's more than 20 years. So there's onboarding training, depends on entry level or depends on senior level. So we have this whole training program to prepare folks before they join the team. And what we did is we just incorporate AI coding in onboarding training program and also show them how to best utilize them with our principles and our technologies, right? There's a huge benefit here because if any of you run into the challenge of adoption somehow run into a chasm, right? The rest of org is not adopt as quick as possible. Whenever we have folks join a company, they learn how to do things in a new way. That when they go back to their team, they were like, hey, why don't we do that? Right? They're going to challenge some of the senior folks as well to say, hey, there's a new way to do this type of thing, so why don't we do that? So we actually find this program extremely effective to be a change agent for anything we want to push out. And then a bunch of results. There's a lot more familiarity and comfort with the tooling. And also the important part is there's a lot more nuanced insights of where it's at value. Right? The second one is oftentimes we run organization to push new initiatives. So within Bloomberg, we have something called a Chen program and a guild program. That's basically across organization or tech communities where people have similar interests and similar passion. They get together and get stuff done. So we had this for more than 10 years now. We sort of bootstrapped engineering AI productivity community 2 years back, leveraged the community we have already, and then have a few results. Because we have this, pretty much everyone passionate about this and will be in that community. So organically, it deduplicates efforts and there's shared learning happening. And it also helps to boost inner source contributions and the visit engineer idea, right? Oftentimes, team A wants to do something, team B, let's say a platform team, have different prioritization. And the way we solve this is via inner source or via visit engineer, which is move someone over the team, work for 6 months, a year, get it done, and then we can move on. The last one is interesting. So our data shows individual contributors have a much better, stronger adoption than our leadership team. Now, if you think about this, a lot of software TLs and managers, in the age of AI, they kind of don't really have enough experience to truly guide their teams to build software, right? So oftentimes the stuff that they learned before might not be exactly applicable, still very valuable, but there's some missing piece there to make sure they can continue to guide the team to do the right thing. So we're rolling out leadership workshops to make sure our leaders are equipped with whatever knowledge they need to have to drive the technology innovation. So I'm going to close my part and to share with you what the part I feel most excited about. The part I feel most excited about is that with a lot of creativity and innovation in the Gen AI space, it actually changes the cost function of software engineering. Meaning, the trade-off decision of whether we do something versus we don't do something actually changes, because some of the work becomes a lot cheaper to do and some work becomes a lot more expensive to do. I tend to think it is a great opportunity for engineers and engineering leaders to get back to some of the basic principles and sort of ask a soul-searching question: what is a high-quality software engineering, and how can we use a tool for that purpose? So that's it. Thank you very much.
Our next speaker helped to reimagine a beloved browser from Arc to Dia by rebuilding it around AI native experiences. Please welcome to the stage Head of AI Engineering at the browser company, Samir Madi.
Hey everyone. Oh, wow. How's it going? My name is Samir, and I'm the head of AI engineering at the browser company of New York. And today, I'm going to talk a little bit about how we transitioned from building Arc to Dia and the lessons we learned in building an AI browser. But first, a little about the browser company. So, we started with a mission to rethink how people use the internet. At its core, we believe that the browser is one of the most important pieces of software in your life, and it wasn't getting the attention it deserved. Simply put, the way we've used a browser has changed over the last couple decades, but the browser itself hadn't. And think about this, we started this company in 2019, and so this is a screen cap of Josh, our CEO, sharing a little bit about our idea on the internet a few years ago, which we endearingly called the internet computer. So our mission has been to build a browser that reflects how people use the internet today and how we think the browser should be used tomorrow. So through years of discovery, trial and error, and some ups and some downs, we shipped our first browser, Arc, in 2022. It was a browser we felt was an improvement over the browsers of that time. It made the internet more personal, more organized, and to us, a little more delightful, with a little more craft. And it was a browser that was loved by many. It still is, by millions, many of whom are probably in this audience today. I've gotten a lot of questions about Arc today. It's great, but if we took a step back, we felt that Arc was still just an incremental improvement over the browsers of that time. And it didn't really hit the vision that we set out to create. And so we kept building. And then in 2022, we got access to LLMs, like the GPT models. And so we started, like we always do, with prototyping. We started trying new ideas and eventually shipped a few of them in Arc. But what started as a basic exploration turned into a fully formed thesis. In the beginning of 2024, our company put out what we called Act 2, a video on YouTube, where we shared that thesis that we believe that AI is going to transform how people use the internet, and in turn, fundamentally change the browser itself. And so with that, we started building again. But this time, we built a new browser with AI, speed, and security in mind and from the ground up. And earlier this year, we shipped Dia, our AI native browser. It allows you to have an assistant alongside you in all the work you do in the browser. It gets to know you, personalizes, helps you get work done with your tabs, and effectively get more work done through the apps you use. And while it hasn't achieved our vision yet, we fully believe it's well on the way to. So, it is not easy to build a product. You all know that. Let alone two, the latter of which an AI native one. We've had a lot of years of iteration, trial and error, and through that we've learned a lot. And I'm going to just talk about a few of those things here today. The first I want to talk about is optimizing your tools and process for faster iteration. From the beginning, Browser Company has believed that we're not going to win unless we build the tools, the process, the platform, and the mindset to iterate, build, ship, and learn faster than everyone else. And that, of course, holds true today, but the form it takes with AI and an AI native product has changed. So even as a small company, where are we investing in tooling these days? First is prototyping for AI product features. Second is building and running evals. Third is collecting data for training and for evals. And last, but definitely not least, automation for hill climbing. So let's start with tools. Initially, as we always do, we built some tools. The first was a very rudimentary prompt editor, and it was only in dev builds. What did this mean for us? Well, it meant a few things. One, limited access, as only engineers were able to access this. Two, slow iteration speeds. And three, none of your personal context. And as you all know, with an AI product, the context is what matters. It's what gives you the feel for whether a product is good or not. So we evolved. And since then, we built all of our tools into our product, the product that we as a company internally use every day. And that includes the prompts, the tools, the context, the models, every parameter, which has not only allowed us to 10x our speed of ideating, iterating, and refining our products, but it has also widened the number of people who can access and iterate on our products themselves. From our CEO to our newest hire can ideate and create a new product in Dia and also refine an existing one, all with their full context. And this holds true with all of our major product verticals. We have tools for optimizing our memory knowledge graph, which all of us use, and we have tools for creating and iterating on our computer use mechanism. We actually tried tens of different types of computer use strategies before landing on one, before even building it into the product itself. And I'll say, and I'll end this part with, it actually is a lot of fun. People don't talk about that a lot, but actually building these tools into our product has enabled so much creativity. It has enabled our PMs, our designers, customer service and strategy and ops to try out new ideas that are tailored to their use cases. And that ultimately is what we're trying to do. The next thing I want to talk about is how we evolve and optimize our prompts through a mechanism called JEPA. This, for us, is very nascent, but an important learning nevertheless. How we hill climb and refine our AI products is just as important as ideating them in the first place. So we're investing in mechanisms to help with this, to enable faster hill climbing, and one of those being JEPA. And this is based on a paper from earlier this year from a few smart folks. So the key motivation here is simple. It's a sample-efficient way to improve a complex LLM system without having to leverage RL or other fine-tuning techniques. And for us, as a small company, that's hugely critical. And how it works is you're able to seed the system with a set of prompts, then execute it across a set of tasks and score them, then leverage a mechanism called Pareto selection to select the best ones, and then leverage an LLM on top of that to reflect on what went well and what didn't, and then generate new prompts, and then repeat. With the key innovations here being around that reflective prompt mutation technique, the selection process, which allows you to explore more of the space of prompting rather than one avenue, and the ability to tune text and not weights. And here's a modest example of this at work for us. You can provide a very simple, simple prompt and run it through JEPA, and it's able to optimize it along the metrics and scoring mechanisms that we created to refine that prompt. And so if I take a step back and talk about kind of how we build for certain types of features, I would bucket it into a couple different phases. The first is that prototyping and ideation phase, where we have widened the breadth of number of ideas at the top of the funnel and lowered the threshold on who can build them and how. And so we try out a bunch of ideas every week, every day from all types of people, and we dog food those. And if we feel like there's actually real utility there, it's solving a real problem for us, and there is a path towards actually hitting the quality threshold that we believe we need to hit, then we'll move on to this next phase, where we collect and refine evals to clarify product requirements, and then hill climb through code, through prompting, and automated techniques like JEPA. And then dog food, as we always do internally, and then ship. And I do want to kind of double down on these phases. The ideation phase is extremely important, just as much as that refinement phase. And our goal is to enable faster ideation and a more efficient path to shipping. Because with all these AI advancements every week, new possibilities are unlocked in Dia. And it's up to us as a browser, as a product, to get as many at-bats with these new ideas and try out as many of them and explore as many of them as possible. At the same time, though, not underestimating the path it takes to ship some of these ideas to productions as a high-quality experience. Next, I want to talk about treating model behavior as a craft and discipline. So, what is model behavior to us? It's the function that defines, evaluates, and ships the desired behavior of models. It's turning principles into product requirements, prompts, and evals, and ultimately shaping the behavior and the personality of our LLM products, and ultimately for us, our Dia assistant. So I'd bucket into a few different areas. First, it's that behavior design, defining the product experience we actually want, the style, the tone, the shape of responses in some cases. Then it's collecting that data for measurement and training, clarifying those product requirements through evals. And last but not least, it's the model steering, it's the building of the product itself. It's the prompting, it's the model selection, it's defining what's in the context window, the parameters, et cetera, and so much more. And to us, that process is iterative, very iterative. We build, refine, we create evals, and then we ship, and then we collect more feedback and feed that into our iterative building process. That could be internal feedback, and that could be also external feedback. And so if I move on for a second, one analogy we've thought about is for model behavior is that to product design through the evolution of the internet. At first, websites were functional. They got the job done. But over time, that evolved. As we tried to achieve more on the internet and technology advanced, product design and the craft of the internet itself grew as well as the complexity. And so what might that be for model behavior? Well, at first, it was functional. We had prompts, we had evals, we had instructions in and output out. Now we frame it through agentic behaviors. It's goal-directed reasoning, the shaping of autonomous tasks, self-correction and learning, and even shaping the personality of the LLM models themselves. And so what might the future hold? I'm excited to see. But what we believe is that we are in the early days of building AI products, and model behavior will continue to evolve and into a specialized and prevalent function of its own, even at product companies. And the last thing I'll leave you with here is that the best people for it might just surprise you. One of my favorite stories about building DIA these last couple of years has been the formation of actually this model behavior team. As I mentioned earlier, engineers were writing the prompts at first. And then we built these prompt tools to enable more people at the company to actually prompt and iterate. And there was a person on our team, on the strategy and ops team, and he actually leveraged these prompt tools one weekend to rewrite all our prompts. And he came in on a Monday morning and dropped a Loom video sharing what he did, how he did it, and why, and a set of prompts. And those prompts alone unlocked a new level of capability and quality and experience in our product. And consequentially, it was the formation of our model behavior team. And so one thing I'd emphasize to you all is to think about who are those people at the company, agnostic of their role, who can help shape your product and help shape and steer the model itself. It might not be an engineer, or it might be. It could also be someone on the strategy and ops team. Next, I want to talk about AI security as an emergent property of product building. And today, I'm going to focus specifically on prompt injections. So what is a prompt injection? Well, it's a prompt attack in which a third party can override the instructions of an LLM to cause harm. That might be data exfiltration, the execution of malicious commands, or ignoring safety rules. And so here's an example in which you give the context of a website to an LLM and instruct it to summarize it. Little did you know that there was a prompt injection hidden in that website's HTML. So instead of actually summarizing the web page, the LLM actually gets directed to open a new website, extracting your personal information and embedding it as get parameters in the website's URL, effectively exfiltrating that data. So as a browser, prompt injections are extremely crucial for us to prevent. They're critical to prevent. Because browsers sit at the middle of what we can call a lethal trifecta. It has access to your private data, it has exposure to untrusted content, and it has the ability to externally communicate. And for us, that means opening websites, sending emails, scheduling events, etc. So how to prevent this? Well, there's some technical strategies we can try. First is wrapping that untrusted context in tags. You can tell the LLM, listen to these instructions around these tags and don't listen to the content around these tags. But this is easily escapable, and quite trivially, an attacker could still leverage a prompt injection on your browser. Well, another solution we could try is separating that data and that instructions. We can assign the operating instructions to a system role, and we can assign a user role for the content of the third party. And even layer on randomly generated tags to wrap that user content to be extra sure that the LLM listens to the instructions and not the content. And while this can help, there are no guarantees. And prompt injections will still happen. So what do we do? Well, it's on us to design a product with that in mind. We have to blend technology approaches and user experience and design into a cohesive story that actually builds them from the ground up and solves it together. So what might that be for a feature in Dia? Well, let's take the autofill tool in Dia. The autofill tool allows you to leverage an LLM with context, memory, and your details to fill forms on the internet. It's extremely powerful, but as you can imagine, it has some vulnerabilities. A prompt injection here could extract your data and put it on a form, and once it's on that form, it's out of your hands. So we try to build with that in mind. In this case, before the form is written to, we actually let the user read and confirm that data in plain text. This doesn't prevent a prompt injection, but it gives the user control, awareness, and trust in what is happening. And this is a framing we carry throughout our product and how we build every single feature. So here are some examples. Scheduling events in Dia, we have a similar confirmation step. Writing emails in Dia, we also have a similar confirmation step. So I've talked about 3 different things here today. First is optimizing your tools and process for fast iteration. Second, treating model behavior as a craft and discipline. And third, AI security as an emergent property of building products. But the last thing I want to leave you with, when we started on this journey to building Dia, we recognized a technology shift and we sought to evolve our product of Arc. We initially came at it from a, hey, how can we leverage AI to make Arc better, make the browser better? But what we quickly learned and adapted to was that it wasn't just a product evolution, it was a company one. And today I shared a glimpse of that, how we build and how it's changed, a team we've literally created around this, and how we think about security for AI products. But really, it's so much more. It goes beyond that. It's how we train everyone here. It's how we hire. It's how we communicate. It's how we collaborate, and so much more. And if there's one thing I'll leave you all with, if there's one thing we've learned over the last couple of years, it's that when you recognize that technology shift, you have to embrace it, and you have to embrace it with conviction. Thank you.
Our next speaker draws on over 20 years in enterprise developer experience to ask what will still matter when AI coding agents are everywhere. Please welcome to the stage Executive Distinguished Engineer at Capital One, Max Kanat-Alexander.
Hey, how's everybody doing? Still awake? Okay, great. So, like the robot voice said, I have been doing developer experience for a very long time, and I have never in my life seen anything like the last 12 months. But about every 2 to 3 weeks, software engineers have been making this face on the screen. Okay? And if you work in developer experience, the problem is even worse. You're like this guy on the screen. Every few weeks, you're like, oh yeah, here's the new hotness. And then somebody else comes up and they're like, well, can I use the new hotness? And people have been doing that for years. I've been working in developer experience for a long time. Everybody always shows up and they're like, oh, can I use this tool that came out yesterday? And you're like, no, of course not. And now we're like, maybe yes, right? And what this leads to overall is the future is super hard to predict right now. So I think a lot of people, a lot of CTOs, a lot of people who work in developer experience, people who care about helping developers are asking themselves this question: are all of my investments going to go to waste? Like, what can I invest in now that if I look back at the end of 2026, I'll be like, I sure am glad that I invested in that for my developers. And I think a lot of people have just decided, well, I don't know, I guess it's just coding agents. And I guess they'll fix every single thing about my entire company by themselves. Which, look, they're amazing, they're transformative, but it's not the only thing that you need to invest in as a software engineering organization. So we can clarify this by asking ourselves 2 questions. The first one is, how can we use our understanding of the principles of developer experience to know what's going to be valuable no matter what happens? Okay? And what do we need to do to get the maximum possible value from AI agents? Like, what would we need to fix at all levels outside of the agents in order to make sure that the agents and our developers can be as effective as possible? And this isn't like a minor question. These are the sorts of things that could make or break you as a software business going into the future. So let's talk about what some of those things are that I think are no regrets investments that will help both our human beings and our agents. So in general, one of the framings that I think about here is things that are inputs to the agents, things around the agents that help them be more effective. And one of the biggest one is the development environment. What are the tools that you use to build your code? What package manager do you use? What linters do you run? Those sorts of things. You want to use the industry standard tools in the same way the industry uses them, and ideally in the same way the outside world uses them, because that's what's in the training set. And look, yes, you can write instruction files and you can try your best to try to fight the training set and make it do something unnatural and unholy with some crazy amalgamation or modification that you've made of those developer tools. Like you invented your own package manager. You probably should not do that. You probably should undo that and try to go back to the way the outside world does software development, because then you are not fighting the training set. And also, it means things like you can't use obscure programming languages anymore. Look, I'm a programming language nerd. I love those things. I do not use them anymore in my day-to-day agentic software development work. As an enthusiast, I do sometimes go and I code on frontline software engineering languages, but not in my real work anymore. So what people ask me sometimes, does that mean we're never going to ever have any new tools again because we're always going to be dependent on the tools that the model already knows? Probably not, because like I said, there's still going to be enthusiasts. And also, but I would like to make a point. The thing that I'm talking about has always been a real problem. There's always some developer at the company has always come up to you and be like, can I use this technology that came out last week and has never been vetted in an enterprise to run my 100,000 queries per second service that serves 1 billion users? And I'm like, no, you can't do that now, and you can't do that yesterday. It's still the same. Another one is, in order to take action today, agents need either a CLI or an API to take that action. Yes, there's computer use. Yes, you can make them write playwright and orchestrate a browser, but why? If you could have a CLI that the agent can just execute natively in its normal format that it understands the most natively, which is text interaction, why would you choose to do something else, especially in an area where accuracy matters dramatically and where that accuracy dramatically influences the effectiveness of the agent? One of the most important things that you can invest in is validation. So any kind of objective, deterministic validation that you give an agent will increase its capabilities. So yes, sometimes you can create this with the agent. I'm going to talk about that in a second. But it doesn't really matter how you get it or where you get it from. You just need to think about, how do I have high quality validation that produces very clear error messages? This is the same thing you always wanted, by the way, in your tests and your linters, right? But it's even more important for the agents, because the agents cannot divine what you mean by 500 internal error with no other message, right? They need a way to actually understand what the problem was and what they should do about it. However, there is a problem here. So you think, okay, I'll just get the agent to do it. They'll write my tests and then I'll be fine. But have you ever asked an agent to write a test on a completely untestable code base? They do kind of what it's like is happening on the screen here. They will write a test that says, hey boss, I pushed the button and the button pushed successfully. Test passed. So there is a sort of a larger problem that a lot of enterprises have in particular, which is there's a lot of legacy code bases that either were not designed with testing in mind, or were not designed with high quality testing in mind. Maybe they just have some very high level end-to-end tests, and they don't have great unit tests that the agent can actually run iteratively in a loop and that will produce actionable and useful errors. So another thing that you can invest in that can be perennially valuable both to humans and to agents is structure of your systems and structure of your code bases. Agents work better on better structured code bases. And for those of you who have never worked in a large enterprise and seen very old legacy code bases, you might not be familiar with what I'm talking about. But for those who have, you know that there are code bases that no human being could reason about in any kind of successful way, because the information necessary to reason about that code base isn't in the code base, and the structure of the code base makes the code base impossible to reason about by looking at it. Yes, the agents can do the same thing human beings do in that case, which is sort of go through an iterative process of trying to run the thing and see what breaks. But that decreases the capability of the agent so much compared to just it having the ability to just look at the code and reason about it the exact same way that human capability is decreased. And of course, like I said, that all has to lead up to being testable. If the only thing I can do with your code base is push a button and know if the button pushed successfully and not see the explosion behind it, like if there's no way to get that information out of the code base from the test, then the agent's not going to be able to do that either unless it goes and refactors it or you go and refactor it first. And there's a lot of talk about documentation. There's always been a lot of talk about documentation in the field of developer experience, in the field of improving things. And people go back and forth about it. Engineers hate writing documentation. And the value of it is often debated, like what kind of documentation you want or don't want, do or don't want. But here's the thing. The agent, let's just take this in the context of the agent. The agent cannot read your mind. It did not attend your verbal meeting that had no transcript. Okay? Now, there are many companies in the world that depend on that sort of tribal knowledge to understand what the requirements are for the system, why the code is being written, what is the specification that we're writing towards. If things are not written down, and that sounds like blatantly obvious, but there are a lot of things that are fundamentally written. Like if the code is comprehensible, like all the other steps are in that we've gotten to so far, you don't need to re-explain what's in the code. So there's actually probably a whole class of documentation that we may not need anymore, where you can just ask the agent like, hey, tell me about the structure of this code base overall, and it'll just do it. But it won't be able to ever know why you wrote it unless that's written down somewhere. Or things that happen outside of the program. Like, what is the shape of the data that comes in from this URL parameter, as an example? Like, if you have already written the code, there's a validator, and that does explain it. But if you haven't written the code yet, it doesn't know what comes in from the outside world. So basically, anything that can't be in the code or isn't in the code needs to somehow be written somewhere that the agent can access. Now, we've covered sort of a few technical aspects of things that we need to improve. But there's a point about software development in general, and that's always been true. And that's, you've heard this, we spend more time reading code than writing it. The difference today is that writing code has become reading code. So even now when we are writing code, we spend more time reading it than actually typing things into the terminal. And what that means is every software engineer becomes a code reviewer as basically their primary job. In addition, as anybody who has worked in a shop that has deeply adopted agentic coding, we generate far more PRs than ever before, which has led to code review itself, the big scale code review, being a bottleneck. So one of the things that we need to do is we need to figure out how to improve code review velocity, both for the big code reviews that where you send a PR and somebody writes comments on it and you go back and forth, and also just the iterative process of working with the agent. How do you speed up a person's ability to look at code and know what to do with it? So the principles are pretty similar for both of those, but the exact way you implement them is a little bit different. What you care about the most is making each individual response fast. You don't actually want to shorten the whole timeline of code review generally, because code review is a quality process. It's the same thing with agent iteration. Like, what you want with agent iteration is you want to get to the place where you've got the right result. You don't want to just be like, well, I guess I've hit my 5-minute time limit, so I'm going to check in this garbage that doesn't work, right? But what you do want is you want the iterations to be fast, not just the agent's iterations, but the human response time to the agent to be fast. And in order to do that, they have to get very good at doing code reviews or knowing what the next step is to do with a lot of code. At the big code review level, one thing that I see that I think is sort of a social disease that has infected a lot of companies is when people want PR reviews, they just send a Slack message to a team channel and say, hey, could one of the 10 of you review my PR? And you know what that means is one person does all those reviews. That's what really happens. There's when you look at the code review stats of teams like that, there's one person who has 50, and the other person have 3, 2, 5, 7. Because there's just one person who's super responsive. But what that means is, if you start generating dramatically more PRs, that one person cannot handle the load. You have to distribute it, and really the only way to distribute it is to assign it to specific individuals, have a system that distributes it among those individuals, and then set SLOs that have some mechanism of enforcement. And another thing is, like that GitHub, for example, is not very good at today, is making it clear whose turn it is to take action. Like, I left a bunch of comments on your PR. You now responded to one of my comments. Should I come back again now? Oh, wait, no, now you pushed a no change. Should I come back now? OK, no, now you've responded to more comments. What I rely on mostly is people telling me in Slack, I'm ready for you to review my PR again, which is a terrible and inefficient system. And another thing you've got to think about a lot is the quality of code reviews. And I mean this once again, both for the individual developers doing it with the agent and the people doing it in the code review pipeline. You have to keep holding a high bar. I know that people have other opinions about this. And yes, depending on the timeline that you expect your software to live, you might not need as much software design. Like, look, software design is not the goal of perfection. It's a goal of good enough and better than you had before, right? But sometimes good enough for a very long-lived system is a much higher bar than people expect it to be. And if you don't have a process that is capable of rejecting things that shouldn't go in, you will very likely actually see decreasing productivity gains from your agentic coders over time as the system becomes harder and harder for both the agent and the human to work with. The problem is this. In many companies, we have the people who are the best code reviewers not doing any of their time doing code review. They are spending all their times in meetings, doing high-level reviews, doing strategy. And so we aren't teaching junior engineers to be better software engineers and to be better code reviewers. So we have to have some mechanism that allows the people who are the best at this to do this through apprenticeship. If somebody else has a better way of doing this than doing code reviews with people, I would love to know, because in the 20+ years that I've been doing this, I have never found a way to teach people to be good code reviewers other than doing good code reviews with them. Now, if you don't do all the things that I talked about, what is the danger? The danger is you take a bad code base with a confusing environment, you give it to an agent or a developer working with that agent. The agent produces relative levels of nonsense, and the developer experiences more or less frustration, and depending on how persistent they are, at some point they give up. And they just send their PR off for review. They're like, I think it works, right? And then if you have low-quality code reviews or code reviewers who are overwhelmed, they go, I don't know what to do with this. I guess it's okay. And you just have lots and lots and lots of bad rubber stamp PRs that keep going in, and you get into a vicious cycle where what I expect to occur, and what my prediction is that if you are in this cycle, your agent productivity will decrease consistently through the year. On the other hand, we live in an amazing time where if we increase the ability of the agents to help us be productive, then they can actually help us be more productive, and we actually get into a virtuous cycle instead, where we actually accelerate more and more and more and more. And yes, some of these things sound like very expensive fundamental investments, but I think now is the time to make them, because now is one of the times you're going to have the biggest differentiation in your business in terms of software engineering velocity if you can do these things versus other industries or companies that can't structurally do these things. So, to summarize, here's a few things. Not literally everything in the world you can do that's no regrets, but you can standardize your development environments. You can make CLIs or APIs for anything that needs a CLI or API. Those CLIs or APIs have to run at development time, by the way, too. Another big thing that people miss is sometimes they have things that only run in CI. If your CI takes 15, 20 minutes, and agents are like way more persistent and patient than a human being is, but they're also more error prone than human beings are. So they will run the thing and then run your test and then run a thing and then run your test and then run a thing and then run your test. And they'll do it like 5 times in a row. If that takes 20 minutes, your developer's productivity is going to be shot to heck. Whereas if it takes 30 seconds, they're going to have a much better experience. You can improve validation. You can refactor for both testability and the ability to reason about the code base. You can make sure that all the external context and your intentions, the why, is written down. You can make every response during code review faster, and you can raise the bar on code review quality. But if you look at all of these things, there's one lesson and one principle that we take away from all these things that covers even more things than this. And it's basically that what's good for humans is good for AI. And the great thing about this, one second. The great thing about this is that it means that when we invest in these things, we will help our developers no matter what. Even if sometimes we miss on helping the agent, we are guaranteed to help the humans. Thank you very much.
Ladies and gentlemen, please welcome back to the stage, Alex Lieberman.
Let's give it up again for Max. We have one more break now, and then the last block of sessions where we'll have speakers talking about AI consultancies, paying engineers like salespeople, and how to make your company AI native. So be back here at 4 o'clock, or if you're watching the live stream, be back online at 4 o'clock, and we'll see you then. Thanks, everyone. How we doing? We are officially 7 hours in. How's the energy level 7 hours in? Let's hear it. There we go. There we go. So this is our last block of sessions before you all get to enjoy the Graphite after party. More coming on that in a few. And for this block, we're going to cover a lot. AI consulting in practice, paying engineers like salespeople, as I mentioned earlier, leadership in AI-assisted engineering, and how to build an AI-native company. You guys ready for this? Oh, come on, let's go. So with that, please join me in welcoming our next speaker and one of last year's MCs to talk about helping organizations transform with AI. Let's hear it for NLW.
All right. Great to be back here, guys. For those of you who are here in February, I had the privilege of emceeing. And today I'm excited to talk about something a little bit different. So right now, there's been, the last couple of months have been an interesting time in AI. There's been a sort of surge in the narrative of an AI bubble, a lot of it driven by dubious studies like the MIT report. And so what I wanted to do today is get into not so much the practice of consulting and transforming, but what organizations are actually finding value in right now. So for those of you who don't know me, there's kind of two contexts I bring to this conversation. The first is as the host of the AI Daily Brief, which is a daily news analysis podcast about AI. The second is as the CEO of Superintelligent, which is an AI planning platform. And so the different perspectives are sort of very high-level macro, thinking about the news that's happening, and then a much more kind of ground-level view where we're spending a ton of time interviewing executives about what's going on inside their organizations. And what we're going to talk about is sort of one, kind of briefly in the first part, just the status of enterprise adoption as it currently stands, and two, and the more interesting part is we've been live with a study in the market for about a month now, collecting self-reported information about ROI around different use cases. And this will be the first time, this week was the first time I did some analysis on it. And so I'm going to share what people have told us around the first kind of 2,500 or so use cases that they've shared. So it should be pretty interesting stuff. Talking about kind of enterprise AI adoption first, I'll go through this pretty quickly because it's pretty well-known stuff. The short of it is, enterprises are adopting AI in a growing fashion. Pretty much everyone is using it at least a little bit, and increasingly they're using it a lot. This year, I will need to tell none of you that there is a major inflection around specifically adoption in the coding and software engineering, right? You saw a huge uptick in this. There's a lot that's interesting about that from an enterprise perspective because it wasn't just with the software engineering organizations. Other parts of the organization are also now thinking about how they can communicate with code, build things with code. But that's a huge theme of this year. Coming into 2025, one of the big sort of thoughts that many people had was that this would be the year of agents inside the enterprise, right? That big chunks of work would get automated away. And on the one hand, I think it's pretty clear that we didn't see some sort of mass shift towards automation writ large across different functions of the organization. But when you dig into the numbers, there has been actually pretty significant shifts in the patterns of agent adoption. So this is from KPMG's quarterly pulse survey, and it's a measure of how many enterprises that are a part of their survey, which is all companies over $1 billion in revenue, have actual sort of full production agents in deployment. So this isn't pilots, this isn't experiments, this is where they consider some agent that's actually doing kind of work in a full way. And it's jumped from 11% in Q1 of this year to 42% in their most recent study for Q3. So you actually are seeing pretty meaningful uptake of agents inside the enterprise. In fact, I would argue, based on our conversations, that that it's moved more quickly through the pilot or experimental phase than people might have thought. So much so that you're actually seeing now a big shift in the emphasis around kind of the human side of agents and how humans are going to interact with agents. And it's involving a shift in upskilling and enablement work. You're seeing a decrease in the sort of resistance to agents as people start to actually dig in with them. You're seeing more experiments like these sandboxes where people can interact with agents. So this is a big theme, even if it wasn't necessarily the dominant theme that some thought it might be coming into this year. At the same time, it is absolutely the case that many, if not most enterprises are, broadly speaking, stuck inside sort of pilot and experimental phases. There is a lot of challenge around moving from some of those first exciting experiments to something that's more scaled. So this is from McKinsey's State of AI study, which came out, I think, a couple weeks ago now. And you can see only 7% of the organizations that they talk to claim or sort of see themselves as fully at scale with AI and agents. And something like 62% are either still experimenting or piloting. Interestingly, big organizations are, in general, a little bit ahead in terms of the organizations that are scaling as compared to small organizations. This has been a thing that we've noticed kind of throughout the trajectory of AI adoption over the last couple of years, that you would think that perhaps smaller, more nimble companies would be more kind of quick to adopt these things, but in fact, it's often been the opposite, with the biggest organizations making the biggest efforts. You can also see from the chart on the bottom that there's very sort of jagged patterns of adoption, right? You're starting to see from last year, if you looked, there's very similar kind of rates of experimentation across lots of different departments. You're starting to see some pretty big breakouts now with, for example, IT operations kind of jumping out ahead of other functions. I won't spend too much time on this sort of high performer piece, but I think the thing to note, because it comes back in some of the stuff that we found with our ROI study, is that you are also starting to see a pretty significant bifurcation between leaders and laggers when it comes to AI adoption. And one of the things that tends to distinguish the companies that are leading is that they are just doing more of it, and they are thinking more comprehensively and systematically about AI and agent adoption. So they are not just sort of doing spot experiments, they're thinking about their strategy as a whole, they're doing multiple things at once, and importantly, they're not just thinking about sort of the very kind of first tier time savings or productivity types of use cases, they're also thinking about how do we grow revenue, how do we create new capabilities, how do we create new product lines. Overall, it's very clear that despite what is sort of the concerns in the media, that spend is going to do nothing but increase on this. So the bottom is the KPMG Pulse survey again, and this is an estimation of the amount of money that these organizations intend to spend on AI over the next 12 months. The beginning of the year was 114, which by the way was up from like 88 in Q4 of last year. It's now up to, in their last study, 130 million is what they expect to spend in the year ahead, which obviously the total magnitude doesn't matter as much as the change. You also see the green charts are from Deloitte, and you can see 90% plus of organizations intend to increase their spend on AI in the next 12 months. And as part of that, I think that you're going to see a much more determined conversation around impact and ROI, which is a particularly thorny topic. But interestingly, there has been an increase in optimism over the course of this year around the realization of AI. So this is from a different KPMG study, their annual CEO survey, which interviews tons and tons of CEOs. And if you look at the 2024 numbers, 63% of those polled thought that it would take between 3 and 5 years to realize ROI from their AI investments. 20% said 1 to 3, and 16% said more than 5. This year, in that same survey, the number that said 1 to 3 years had gone up to 67%. There were now 19% who said 6 months to 1 year, and 3 to 5 years was down to just 12%. So huge kind of pull forward of expectations of ROI realization. The challenge is that ROI is really tough. So this is back to the Pulse survey. 78% of those polled in that survey said that they thought that ROI is going to basically become a bigger consideration in the year to come. But also 78% said that traditional impact metrics and measures were having a very hard time keeping up with the new reality that we were living in. And this is something that I've heard constantly over and over from CIOs and other people who are in charge of these investments, that the ways that we have measured impact of previous technologies and just previous initiatives are kind of falling flat with AI. And so that got us thinking about the overall need that we have to just have more information. I'm not even talking about good, systematic information, just more information around what ROI looks like, what impact looks like. And, I've got this great podcast audience, they're super engaged. And so we just decided, screw it, we're gonna ask them. We're just gonna ask them to report on what ROI they're finding from their use cases. So this went up at the very end of October. Like I said, as of this morning, or when I last looked, we've had over 1,000 submissions, 1,000 individual organizations rather submit, something like 3,500 use cases. And this is some of the first observations that we had around kind of the first 2,500. So the impact categories, the way that we divided things was into sort of 8 broad categories of impact, which will all, I think, be very intuitive to you guys. Time savings, increased output, improvement in quality, new capabilities, improved decision-making, cost savings, increased revenue, and risk reduction. So basically, we're trying to think of like kind of a broad, simple heuristic for kind of dividing or subdividing the different ways that people are thinking about ROI. And TLDR is that people are finding ROI right now. Now, again, the caveats are that this is a highly enfranchised audience. They're listening to a daily AI podcast, and they are voluntarily sharing this. So I think that there's some caveating there. But you have 44.3% saying that they're seeing modest ROI right now, and then you have another 37.6% seeing high ROI. For the purposes of a lot of these stats, high ROI will be significant plus transformational. Only 5% or so are seeing negative ROI. And keep in mind, negative ROI doesn't mean that they think programs are failing. That just means they've spent more than they've gained, or in terms of how their perception is. More than that, expectations are absolutely sky high. 67% think over the next year they will see increased and high growth in their ROI. So we have a really optimistic sense from the ground view of where ROI is going to be in AI. You even have the teams that are currently experiencing negative ROI, 53% say that they're going to see high growth. So very, very optimistic. As you might imagine, time savings is the default. It's the starting point for so many organizations. It represents about 35% of the use cases. After that, increasing output, quality improvement, basically all those things that you would imagine around productivity are sort of like the dominant categories when it comes to these use cases. When it comes to the specifics around time savings, you see a real cluster between 1 and 10 hours, especially right around 5 hours. And I think this is interesting to call out because it's so obvious to all of us who are inside building these things, whether you are a developer or an entrepreneur or just someone sort of in and around it, how the vast breadth of opportunity that AI represents, new capabilities, things unimagined yet. It's easy to forget that if you save 5 hours a week or 10 hours a week, you're talking about winning back 7 to 10 work weeks a year. And that's very, very powerful. And when it comes to a lot of these enterprises, that is a very meaningful thing, even if it's not what they're ultimately in it for. Interestingly, though, it's very clear that the story, although it might have a concentration in time savings, is about much more than time savings. So this is the ROI distribution category, ROI distribution by organization size. And this starts to get really interesting where you can see that there are some differences in where different size organizations are focused. So for example, the organization size between 200 and 1,000 people has a higher portion of their use cases concentrated in increasing output. Now, we haven't taken the time yet to really figure out exactly what this means or even speculate on what this means. But I think it's interesting that this is a category of organization that has often reached a certain scale, but is still very much striving for more, and so seems to be focused more on use cases that expand their capabilities. Same thing with when you start to divide things by role. You see a real kind of variance where, for example, C-suites and leaders are less focused on those time savings use cases and more focused on other things like increased output and new capabilities. In general, we're finding that C-leaders and just sort of C-suite and leaders in general are even more optimistic and excited and seeing transformational impact than people who are in more junior positions. Now, some of this might be sort of selection bias in terms of what types of use cases you are focused on. If you are in that C-suite, you're thinking about things that inherently, if they work, are more transformational. But it is notable that 17% of the use cases that people in those leadership positions have submitted, they say have transformational impact and ROI already. I'm going to skip this because we don't have time for too much. You're seeing, interestingly, a concentration where the smallest organizations are getting more of that transformational benefit early. One of the things that I want to do following this study is maybe do a sort of second round where we dig into what this 1 to 50 person size really looks like. I actually think that whereas there might be a lot of similarity between a 1,000 and a 2,000 person organization, there could be a wild difference between a 3-person, small company and a 40-person company. And so I'd really like to dig into that more. But you are definitely seeing a lot of impact in those sort of more small, nimble moving organizations. As you might expect, coding and software-related use cases have a higher ROI than average and a lower negative ROI than average. One really interesting kind of pulling on a specific category of use cases, risk reduction is our lowest category in terms of the percentage of use cases that was their primary benefit. So when you're filling out this survey, which is, by the way, at roisurvey.ai if you want to check it out, you basically only get to pick a primary ROI benefit. We didn't want it to be super sort of, we wanted you to pick and hone in on the thing that was seemed most important or most significant. And so only 3.4% have risk reduction as their primary benefit in terms of ROI categories. But it is by far, those use cases are by far the most likely to have transformational impact as their outcome. It's at 25%, so a full quarter of those have transformational ROI. And interestingly, I was having this conversation with a couple of my friends who work in sort of back office and compliance and risk functions, and this has been their experience as well, where there are a lot of the challenges for those organizations involve sheer volume and quantity in ways that AI can be really helpful for. We also are finding some interesting patterns among organizations. And again, this is where we get into some of the limits of this, just being a whoever walks through the door of my listeners. We have a pretty heavy concentration among technology, as you might expect, industries, and among professional services. But we still have fairly decent sample sizes for some others. And in both healthcare and manufacturing, the use cases are meaningfully higher impact on average than the average across all organizations, which I think is it was kind of worthy of further study. Last sort of part of this, as I wrap up, a lot of these use cases, as you saw, have to do with that sort of first tier that most enterprises are going to be in, increasing the amount of content that you output, increasing the quality of that content, just finding ways to win back your 5 hours a week. But increasingly, there are automation and agentic use cases, and we are absolutely seeing that where those are the focus, where those use cases mention certain types of automation or they mention agents, they wildly outperform in terms of the self-reported ROI from them. That's both on automation and it's on agents. And I think that that's sort of a trend towards where we're headed with sort of the next layer of more advanced use cases. The last thing that from this sort of first look of observations is there is clearly benefits, and this goes back to what we saw with that McKinsey study as well, of thinking about AI and agentic transformation in systematic, cross-organizational, cross-disciplinary types of terms. Effectively, pretty much directly, the more use cases that a person or an organization submitted, the better they tended to see ROI for. Now, there's lots of reasons for that, but I do think it speaks to that core idea that once you move beyond kind of your single spot experiments, there's a lot of opportunity to sort of grow the impact of the organization. So like I said, that is the first look. It's kind of the first 2/3 of these use cases. Will be open for another week, and then we'll have the full study out at the beginning of December. I'm really excited, I think, heading into next year to see how we move from sort of generic conversations about impact and our gut senses about impact to a lot more random experiments like this to figure out where the impact really is and where we go next. So look at that. I'm going to end 27 seconds early and really throw off the time. But appreciate you guys all being here. And again, if you want to check this out, it's at roisurvey.ai.
As AI changes our business and engineering landscape, do we need to rethink how we incentivize and compensate engineers? Here to provide us with a case study for scaling output, not overhead, is the co-founder and managing partner at Tenex, Arman Hezarkhani.
How's everybody feeling? It's been 7.5 hours. We doing okay? Yeah. Awesome. I'm Arman, like the voice of God, apparently. That's what they're called, voice of God, apparently. So my name's Arman. I'm one of the co-founders and managing partners at a company called Tenex. My co-founder is Alex, who's been kindly announcing everybody all day. We do a lot of cool work. We help companies with their AI transformation. We have incredible clients all over the world, but I'm not going to talk about any of that today. I'm going to talk about something much more niche. I'm going to talk about how we pay engineers. And we pay engineers like salespeople. Earlier, I was just in the green room with a bunch of distinguished engineers that I've grown to respect for my entire career. And we were talking, and I was telling them that we pay engineers based on the story points that they complete. And we had a lot of people roll their eyes and laugh. And they asked, what do you mean? And I said, clients pay us for the number of story points that we deliver, and we pay engineers based on the number of story points that they complete. And similar to the looks that I'm getting from some of you, there was skepticism. And I know this sounds crazy, but it's working. We've been able to hire incredible engineers, many of whom have started and exited companies before this. We have been able to hire world-class machine learning and AI researchers. We've hired rocket scientists from NASA. We are shipping code incredibly quickly, and it's maintainable and high-quality code. Of course, that is everyone's dream. Everybody wants to hire great people. Everyone wants to deliver really fast code. So my goal here is not to convince you all to adopt our model. My goal is to show you what compensation looks like in AI and hopefully provide a new perspective on the fact that things might change as we introduce this technology. Before I jump in, though, I want to talk about how we got here. So I'm a software engineer by training. I went to Carnegie Mellon, and then I taught there in their School of Computer Science. After that, I went to Google, and I helped them scale their AI, cloud, and mobile practices internationally before starting a few venture-backed startups. And in my last startup, I would work out of a WeWork. And I was sitting in this 33 Irving WeWork. If any of you are from New York, you might have worked out of that WeWork. And they have these big tables, and there were 12 of us kind of sitting around. No one's talking. Everyone has their headphones in. And I look to my left, and I see somebody with Visual Studio Code open, right? I'm like, okay, I have a fellow engineer to my left. And I see that he was typing, but I didn't see a chat window. This person was typing into the code editor. They were typing F-O-R, like a caveman. This poor person was typing, like with their little chopstick fingers, individual characters. I couldn't believe it. On my computer, I had 45 agents, 3 were ordering me lunch, 2 were writing code, 1 was doing research. Just different worlds were happening on my computer versus this person's computer. And I felt bad. I thought maybe we should do a GoFundMe or something. But I tried to look deeply at what is actually causing this difference. Why am I using AI in the way that I am, and why is this person not? There are different ways that people try AI, and there are different reasons why people don't use it. We've all heard people who have tried it and have said it's not as good as me. We've all heard people who have not tried it because they don't want to. But regardless, my belief is that this is an incentive issue. For me, I was a founder, and I wanted to squeak out every bit of incremental value and efficiency that I could. And so I would sit on Twitter and LinkedIn and read blog posts and try to understand what is the cutting edge in software engineering and what's going to give me the ability to output more code, higher quality, faster. And because of that, I was using all these different agents. But this person probably worked at a startup, probably had a base salary with an annual bonus and some equity. And that was supposed to be the model that incentivized people to be innovative and to work smarter and faster and harder. But it wasn't working. And so in order to understand how we got to where we are, I'm going to do a brief history of compensation. And this is by no means accurate. I'm making a lot of things up here. It's all illustrative, okay? So back in the day, we had some cavemen who were writing code. We were probably inscribing C in a tablet somewhere, and we were paying people hourly, right? This makes sense. I look at somebody sitting in a chair, and I'm going to pay them some amount of dollars for some amount of time. That makes sense for me, and it makes sense for the engineer. But why is that broken? I want to hear from people. Why is hourly broken? It's slow. Output. There's no upside. There's no reason to work faster, right? And in fact, there's a disincentive to work faster. And so what if I notice this as the buyer of this technology and I say, okay, how long is it going to take you? It's going to take you 5 hours? Okay, so I'll pay you $500, right? Hourly, $100, multiply that by 5. And then you as the engineer, if you work faster, great. You get to keep the $500. And if you work slower, that's on you. As engineers, we're really, really bad at estimating how long things are going to take. And so because of that, I'm not going to say it's going to take 5 hours. I'm going to say it's going to take 15 hours, 20 hours, so that I have no downside. And so again, as the buyer, I don't want to pay you based on the project. So what if we hire people on salary and give them a bonus, right? Well, we in the startup community know what happens in that when this is the case. People punch in at 5, leave, or 9, leave at 5. And so I'm Larry Page. I notice this, and I see, why am I working so hard at Google? Why am I putting my blood, sweat, and tears into this? It's because I have some of the upside. I own the company, right? And so when we exit for many, many dollars, I'm going to see that. So what if I can share that with my employees? And that's when equity comes in. And this has worked. This has worked for many, many years to incentivize employees. This is the foundation of the startup community that we all know and are a part of. It's incredible. But not every company is Google. In fact, for every one Google, there are many, many failures, and software engineers know this, right? For those who want to take the risk, many will just go to YC or start their own company. And for the ones who don't want the risk, they're opting for cash over equity. Many of us who've hired engineers know that the cash is non-negotiable. Equity, yeah, sure, I'll take some upside. And so my contention is that this model needs to be reinvented in the age of AI. We need to directly incentivize people to use these tools and to use them well and to still maintain really high quality standards of code. And so here's how it works for us. So we basically, just to take a step back, we do 2 types of work at Tenex. One is road mapping and one is execution. So companies come to us and they say, hey, we want AI. That's generally the request. Sometimes it's more specific. It's like, hey, I want my customer service team to have 10% more output using AI, right? But generally they come to us with a request. We do a bunch of studying and learning, and then we output a roadmap. And based on that roadmap, they can take it and work on it on their own, or we can do it. For a lot of things, we're taking off-the-shelf tools, but a lot of what we do is custom builds, and that's where the story point model comes in. So we will build a roadmap for a lot of our clients, but once they see that, then they're putting in requests on their own as well. And we have 2 roles in the company that are client-facing. One is the strategist, and the other is the AI engineer. The strategists are mostly technical. And so we have former PMs, we have former engineers. They are doing PM type work, consulting type work. They're the ones that are taking the product requirements and distilling that down with the client. Then they hand that over to the engineer. And the engineer puts together an architecture design document. They spend a lot of time doing that. In fact, that is where most of our engineering time goes. Then they write code and they start implementing. That architecture design document includes tickets, and each ticket is graded on some number of story points. This is a very traditional method of doing work, right? And when that ticket is accepted, the engineer gets paid a fee per story point that they complete. Our engineers have a flat base that they're paid, and then every quarter we round up based on the story points that they've completed. And again, this has led to us being able to hire incredible people, but we've also been able to do incredible work. So I'm going to walk through a couple of projects that we've done. So this is one. This is a billboard company. If you go to Times Square right now, you'll see some billboards that they've sold that inventory for. They sell in 2 ways. One is you can call them up, traditional sales, you can buy that inventory. But the other is they have like an Uber for billboards type of product where you can go online, you can upload a PNG, you can choose where you want this to run and for how long. Similar to like a Facebook or Google ad, it's very similar to that experience. And they came to us and they said, hey, we think that there's some opportunities for AI in our product. We did an analysis and we found a few. One of them is this. We found that when an image is uploaded to their system, it has to go through 2 rounds of moderation. One is internal to the company, and the other is with the billboard owner. Internal to their company, they're spending money on that to actually hire the people to do that, and there's a lot of inaccuracy, and it takes a lot of time. So that costs them money, and it costs them revenue, because every moment that the billboard is not running, they're not making money. And so we found, what if we could build an AI model that can actually do this moderation for them? We scoped that out, we built the architecture, design doc. We broke it down into tickets. And we built this for them. We did it in 2 weeks, and we got to 96% accuracy when compared to the human moderator. We've done a lot of other projects with this company as well. This is another company. They work with retailers all around the world. And currently, they have devices in these retailers. And they're low-power devices. And so because of this, they're able to run one AI model on device. And what this model does is does heat mapping. So imagine there's a camera in this room, looks down, and it can basically generate a heat map of where the traffic is throughout the day. And for retailers, of course, this is very, very useful. But there's other things you can do too, right? If we just sit here for a few minutes, we can probably come up with a lot of ideas of if you have a camera with a chip, you can make a lot of money from that. You can show really useful information. And so that's what we did. We came up with what are some of the things that we could do with this. If you put a little bit more power in that chip, if you make the models, if you quantize them so they can run in parallel, what could you do? And so we gave them this report, and then we built them 5 models that can run in parallel. It does everything from heat mapping to queue detection to theft detection and more. And again, we start with the product requirements doc. We break this down into architecture, then we build it, and then we pay engineers based on the output. This is the big question. What are the risks, right? I just talked about dandelions and rainbows, right? So I promised you that my goal is not to convince you to do this. And part of this is showing you what the potential risks are. These are a few that come up. One is, what if an engineer inflates the story points, right? What if an engineer says, okay, you want me to add a button? 45 story points, right? What if an engineer rushes and quality drops? You're saying that it took 2 weeks to do that? Well, was it good? Did it work? And what if engineers get sharp elbowed? I started this by saying that we compensate engineers like salespeople. It's not a culture that we necessarily want to emulate in software engineering, right? So how do we make sure that that's not happening? First of all, I mentioned that we have 2 different roles, and we compensate like a counterbalance. So strategists are compensated based on NRR, which really is like customer happiness. And every single ticket has to be approved internally with multiple rounds of QA, of which the strategist is involved, but also by the client. And so there's a counterbalance to every single ticket that is delivered. I skipped to the second one. For the first one, inflating story points, the strategists are the ones who scope it. And again, we have to review all of that. And for the third, how do you make sure that all of this is correct? And how do you make sure that there's no sharp elbows? How do you make sure that everybody is happy and the dandelions and rainbows are continue throughout this parade of joy? Well, you have to hire the right people. And this is what I tell everybody. We make hiring incredibly difficult for ourselves so that everything else is easy. And that is a principle that we all know and we all stand true to, and this is incredibly important with AI. My co-founder Alex always says AI makes people look like one of those crazy mirrors where any one of your attributes, it makes it 10 times larger. If you're a great engineer, AI makes you great. If you're not, it makes you sloppier. And this is the case with all of these things. You have to start with hiring. Our belief is that AI gives people superpowers, and it makes all of us smarter, faster, and better at what we do. But my belief is that the current way that we compensate people is actually holding them back. And I would invite you to think about how can you compensate people on your team differently, whether it's software engineering or anything else. If you want to unlock your employees' potential, feel free to reach out at armon@tenex.co. Thank you.
Our next presenter is Deputy CTO at DX, the engineering intelligence platform designed by leading researchers, speaking about effective leadership in AI-enhanced organizations. Please join me in welcoming to the stage, Justin Rioch.
Hello. Thanks for joining me in one of the later day sessions. Looks like we kept a lot of people here. This is a nice full room. Great to see it. We're going to go through a lot of content in a short amount of time, so I'm going to get right into it. If you want to get deeper into any of this stuff, we have published this AI strategy playbook for senior executives. And a lot of the content that I'm going to go through, I'm not going to have time to get quite as deep, but this is just a nice PDF copy that you can come and refer to later. If you missed this QR code, don't worry, I'll show it again at the end. So what is the current impact of Gen AI? Nobody knows, right? We've got Google on the one hand telling us that everyone's 10% more productive. That's interesting. Now they're Google. They were already pretty productive to begin with. But we have this sort of now infamous METR study, which has some flaws in the way that study was put together, that showed actually a 19% decrease in productivity using coding assistance. So there's a lot of volatility, a lot of variability. What was really interesting about this study, even though I mentioned there were some flaws, but every engineer that took part in this study felt more productive. But then the data actually bore out that they were less productive. Kind of interesting, right? We've got this induced flow that makes us feel really good about what we're doing. So we need to address this. Dora's put out some really good research on this too, but this is based on industry averages. This is impact based on what do we look at when we see a large sample and an average of how certain factors are being impacted by, in this case, 25% increase in AI adoption. We see these modest but positive leaning indicators, 7.5% increase in documentation quality, and increase in code quality by about 3.4%. At least that's not leaning in the other direction, right? And when we started digging through some of DX's data, we have, we're the developer productivity measurement company. We have lots of aggregate data that we can look at with this. We found the same thing when we looked at averages. We see about a 2.6% increase in overall change confidence, which is a percentage of people who answered positively that they feel confident in the changes that they're putting into production. Similar positive leaning average when we looked at code maintainability, another qualitative metric, a 0.11% reduction in change failure rate, which when you think about the industry benchmark being 4%, it's not insignificant. But this is not the full story, because this is what we saw when we broke the same studies down per company. Every company here is every bar represents a company, right? We have some that are seeing 20% increases in change confidence, while others are seeing 20% decreases. We're seeing extreme volatility, which is why these averages look so innocuous, but they're belying the greater story of variability. See the same thing with code maintainability, the same thing with change failure rate. So this is a 2% increase in change failure rate up here at the top. Again, with an industry benchmark of 4%, that means shipping as much as 50% more defects than we were shipping before, right? We want to make sure we're on the lower end of this, but how? Like, what should we be doing? Well, we found some patterns here. We see that some organizations are seeing positive impacts to KPIs, but others are struggling with adoption and even seeing some of these negative impacts. Top-down mandates are not working, right? Driving towards, oh, we must have 100% adoption of AI. Great, I will read my file every morning and I will be compliant, right? We're not actually moving the needle anywhere when we do that. We also find that lack of education and enablement has a big impact on sort of negatively impacting this. Some organizations just turn on the tech and expect it to just start working and everybody to know the best ways to use it. And a difficulty measuring the impact or even knowing what we should be measuring, like what metrics should we be looking at? Does utilization really tell us much about the full story of Gen AI impact? This is another graph from Dora. This is a Bayesian posterior distribution, which is an interesting way of representing data. Basically, you want your mass to be on the yellow side of this line, the right side of this line for the audience, yeah. And you want a sharp peak, which is telling you that we're pretty confident that this initiative will have this impact. And if we look at some of the top line initiatives here, these are things like clear AI policies, all right? We want to make sure we have that. We want time to learn, not just giving people materials, but actually giving them space to experiment, right? And so these types of factors are the ones that seem to be moving the needle the most. So we're going to go over some quick tips on how we can do all of these things. And again, the guide will go deeper into this. We want to integrate across the SDLC. All right? For most organizations, writing code has never been the bottleneck, right? We can increase productivity a bit by helping with code completion, but our biggest bottlenecks are elsewhere within the SDLC. There's a lot more to creating software than just writing code. We want to unblock usage. We can't just say, well, we're worried about data exfiltration, so we can't try this thing. Like, no, get creative about it. We've got really good infrastructure out there now, like Bedrock and Fireworks AI, that can let us run powerful models in safe spaces. We have to have open discussions about these metrics. We need to evangelize the wins, and we need to let our engineers know why we're gathering metrics and data. What is it that we're trying to improve? We have to reduce the fear of AI. right? We have to make sure that people understand that this is not a technology that is ready to replace engineers. This is a technology that's really good at augmenting engineers and increasing the throughput of our business. We have to establish better compliance and trust, and we need to tie this stuff to employee success. These are new skill sets. AI is not coming for your job, but somebody really good at AI might take your job. And so as leaders, we have the opportunity to help our employees become more successful with this technology. So how do we reduce the fear? Well, first of all, why do we need to do this? Well, there's a lot of good reasons, but I love to point to Google's Project Aristotle. This was a 2012 study where Google wanted to figure out what are the characteristics of highly performant teams. They thought that the recipe was just going to be what Google had, this combination of high performers, experienced managers, and basically unlimited resources, and they were dead wrong. Overwhelmingly, the biggest indicator of productivity was psychological safety, okay? And so that very much applies now. We also have data, like this is SweetBench, I'm sure a lot of you have seen this, and there are some impressive benchmarks that the agents can do like a third of the things they're asked to do without any human intervention. That means that they're not able to do 2/3 of them, right? Again, we are augmenting, we're not replacing, we're not ready, we may never be ready. So we need to be very transparent with what we're doing. We need to set very clear intents. Why, are we using this to augment, not to replace? We need to be proactive in the way that we communicate that and not just wait for people to get upset and possibly scared. We need to say, no, we are here to help you, to give you a better developer experience, and to increase the throughput of the business. And again, we have to have these discussions about metrics. Now, what metrics? What should we be looking at? Well, DX again, developer experience and productivity measurement company. There are two sort of classes of metrics that we can be looking at, really two levers that matter here, and that's speed and quality, right? We want to increase PR throughput, we want to increase our velocity, but not by just creating a bunch of slop that's going to give us a bunch of tech debt later that we're going to have to deal with. And we'll just kick the bottleneck down the road if we do that, right? So we want to be looking at things like change failure rate, our overall perception of quality, change confidence, maintainability. And we have three types of metrics that we can be looking at here. We have our telemetry metrics. These are the things coming out of the API, and they're good for some stuff, but they're not always accurate, right? We know like accept versus suggest was kind of like all the rage until we realized that engineers need to click accept in the IDE in order for the API to know about it. Even if they do click accept, who's to say they didn't just go back and rewrite every line that was suggested, right? So that's providing us some context, but we also need to do some experience sampling. We need to, like, for instance, add a new field to a PR form that says, I used AI to generate this PR, or I enjoyed using AI to generate this PR, and get some data that way. And then self-reported data or survey data. We are big on surveys, but let me underscore, we're big on effective surveys. 90% plus participation rates, engineered against questions that treat developer experience as a systems problem, not a people problem. Because that's what it is. W. Edwards Deming, 90 to 95% of the productivity output of an organization is determined by the system and not the worker, okay? So foundational developer experience and developer productivity metrics still matter the most, right? Our AI metrics like utilization and things are telling us what's happening with the tech, but these core metrics that we've been able to trust are telling us whether these initiatives are actually working, right? Are we actually moving the needle and having the outcomes that we want to see? So top companies are looking at different things, right? We are seeing like adoption metrics coming out of Microsoft. They've also got this great metric called a bad developer day. I'm not going to go into it, but there's a really good white paper that shows like all the different telemetry that they can look at to determine what makes a bad developer day. Dropbox is looking at similar stuff, adoption, like weekly active users, daily active users, that sort of thing, but also looking at quality metrics like change failure rate. And Booking is looking at similar stuff as well. And so we built a framework around this. We were first to market with what we call our DX AI measurement framework. And this is very much inspired by things like Dora, Space Framework, DevX, just like our core 4 metrics set, which you can ask me about later. And we take these metrics and we normalize them into these 3 dimensions of utilization, impact, and cost. And you can kind of think about this as a maturity curve too. A lot of people start just figuring out, okay, what's happening? Who's using the tech? What's the percentage of pull requests that we're getting that are AI assisted, maybe through experience sampling? How many tasks are being assigned to agents? But then we can mature that perspective a little bit and we can correlate that utilization to impact. what is this actually doing to velocity? What is this actually doing to quality? And this is when we start getting more mature in our picture of our impact. And then finally, cost, although I like to joke that we're 15 years past the last hype cycle, which was cloud, and we still have new companies spinning up that are teaching us how to understand and optimize our cloud costs. So we will see if we get there, although I also hear horror stories about people burning through $2,000 worth of tokens a day, so we probably do need to hit that as well. What about compliance and trust? What can we do to ensure that the output that's being generated is something that can be trusted by our engineers? We have a lot of levers to pull here, but one of the ones that I'd like to talk about is setting up a feedback loop for our system prompts. So these could be called system prompts, cursor rules, agent markdown. Pretty much all of the mainstream solutions have something like this, where you can go and provide a set of rules to control how these models behave. And I won't get too much into the technical details here. We have an example where like the models have been providing outdated Spring Boot stuff. We want Spring Boot 3. It's been sending us Spring Boot 2 stuff. The big takeaway here is to have the feedback loop. Have a gatekeeper, right? Have somebody or a group in the organization that can receive this feedback, that understand how to maintain and continuously improve these system prompts, right? And that way, we're always maintaining the way that these assistants or models or agents affect the whole business. It also pays to understand the way that temperature works, especially when we're building agents, right? We do have some control over the determinism and non-determinism of these models. Again, like when a model is predicting a next token, it doesn't just have like one token. It has a matrix of tokens, and those are associated with a certain probability of that being like the right token. And so we have this setting called temperature, which is heat, which is entropy, which is randomness, that can control the amount of randomness involved in actually picking that token. This is sometimes called increasing the creativity of the model. And it's a number between 0 and 1. For those reasons I just mentioned, don't use 0 or don't use 1. Weird things will happen, but you want some decimal in between 0 and 1. When we have a lower temperature, like we're seeing here, 0.0001, we give it the same task twice, and it gives us the exact same output character for character. When we set that temperature higher, this is an example of 0.9, I'm asking the agent to create a gradient for me, simple task. It's giving me two relatively valid solutions. I did ask it for a JavaScript method, and this is the only one that's giving me a JavaScript method. But the point is, they are wildly different approaches to the same problem when I've increased the creativity of that model. So we need to think about, like, use case-wise. Where should we have more creativity, and where should we have more determinism? And temperature is another setting that we have that can help control this. You can experiment with all this using, like, Docker Model Runner, Ollama, LM Studio, that sort of thing. How can we tie this to better employee success? We have to provide both education and adequate time to learn. So we put together a study where we sampled a bunch of developers that were saving at least an hour a day, an hour a week. And we asked them to stack rank their top 5 most valuable use cases. And we built a guide around that. A guide that effectively goes through code examples, prompting examples of what we determined using this sort of data approach, where we should get more reflexive about our best practice and about the use cases that we're becoming reflexive in our use of AI. And so that's what this guide was about. And we've had this become required reading in certain engineering groups, and proud of that. And this is another way that we can help educate, but we need to give time. We don't have time to go through all of this. I do think it's interesting that the #1 use case for this was stack trace analysis, right? So not a generative use case, actually more of an interpretive use case. And we see some other ones here that are not too surprising, and there's examples of each of these. What about unblocking usage? How can we make sure that we can creatively ensure that engineers can take the most advantage of this? Well, leverage self-hosted and private models. That's getting easier and easier to do. Partner with compliance on day 1, right? Make sure that what you're doing is in line with your organization's compliance. You may find that you're making a lot of assumptions about things that you don't think you can do, that you can actually do, right? And then think creatively around various barriers. Finally, how can we integrate across the SDLC? What should we think about doing there? You know, and I'm a big Ellie Goldratt theory of constraints fan, probably have some others in the audience. An hour saved on something that isn't the bottleneck is worthless. And when we look at data across, in this case, almost 140,000 engineers, we find that there are definitely good, like, annualized time savings with AI that are being eclipsed by sources of context switching and interruption, meeting heavy days, these other things that it's like, yeah, we can save time here, but we're losing so much more time over there. So find the bottleneck, fix the bottleneck, right? Morgan Stanley's been very public about their building this thing called DevGen AI that looks at a bunch of legacy code, COBOL, mainframe natural. I hate to admit Perl because I'm an old school Perl developer, but apparently that's legacy now too. And basically creating specs for developers that can just be handed to developers to start modernizing the code without having to do all that reverse engineering, right? And they're saving about 300,000 hours annually right now doing this. There's a Wall Street Journal article about this, Business Insider article about it. They're very public about that. Zapier. Zapier should be the example for everyone. They have a whole series of bots and agents that are doing things like assisting with onboarding. They can now make engineers effective in 2 weeks. Industry benchmark on the good side is like a month. On the medium side is like 90 days. And because they're able to increase the effectiveness of the engineers that they're bringing into the organization, they realized that they should be hiring more, right? As opposed to trying to maintain status quo by like cutting headcount and trying to make individual engineers more productive, they said, no, we could get more value out of a single engineer. We should be hiring faster than ever, and they are. And it's really increasing their competitive edge. I think that's the right attitude. Spotify's been helping out their SREs by pulling together context when incidents are detected, and then taking things like run but steps and other areas of context and documentation and pushing them directly into SRE channels, so that those critical minutes of trying to get to the bottom of what's actually happening and what we should do to resolve the incident, they just eliminated that time, right? It's significantly increased their MTTR. So let's get creative about areas in the SDLC that are our actual bottlenecks. All right, next steps. Distribute this guide as a reference for integrating AI into the development workflows that you have. Determine a method for measuring and evaluating Gen AI impact. It's really important to make sure that we're not on the bad sides of those graphs that I showed you earlier. And then track and measure AI adoption and see how that correlates to overall impact metrics and iterate on best practices and use cases. And here's the guide again. Thank you so much.
Our closing presentation will teach us how to build an AI-native company, even if that company is 50 years old. Please join me in welcoming to the stage the founder of Every, Dan Schipper.
Hello. How's it going, everybody? I'm the last speaker of the day, so I'm just between you and dinner or drinks, so I'm going to try to make this fun and hopefully a little bit short. So first of all, I just want to say I'm very glad to see everybody, and I'm actually kind of surprised to see so many people here because I live here, but I've been traveling. I was in Portugal last week, and I was on Twitter, and someone said that everyone was moving to San Francisco. But it's great to have everybody here instead, because I fucking love New York. Come on, come on. So I'm supposed to talk today about how to build a playbook for how to build an AI native company. And I actually don't have one, unfortunately. And that's because I think the playbook is actually being invented right now. So we're doing it at the company that I run, Every, but all of you are doing it here today as well. And so I don't want to do this talk from the perspective of I have all the answers and I'm going to tell you the framework and the playbook and all that kind of stuff. But I do think it is helpful when we're in this beginning stage of learning how to use AI to do engineering, to build companies, to share like the personal experiences that we're having inside of our companies, and sort of collaboratively figure out the playbook together. So I think the best that I can offer is really just sort of dispatches from the future, notes on what I've figured out and the work that we've done inside of Every. And I think the first big thing, the first big thing I really noticed is that there is definitely there's a 10x difference between an org where 90% of the engineers are using AI versus an org where 100% of the engineers are using AI. It's totally different. I think the big thing is if even 10% of your company is using a more traditional engineering method. You sort of have to lean all the way back over into that world. And so it prevents you from doing some of the things that you might do if everyone was not typing into a code editor all the time. And I know this because this is what we do at Every, which is the company that I run, and it has totally transformed what we are able to do as a small company. And so I think of us as like a little bit of a lab for what's possible that I'm excited to share with you. So for people who don't know, I run Every. Inside of Every, we have 6 business units. We have 4 software products. We run 4 software products with just 15 people, which is kind of crazy. And these software products are not toys. We've grown at Every, we've grown MRR by double digits every month for the last 6 months. We have over 7,000 paying subscribers and over 100,000 free subscribers. And we've done this in a very capital light way. We've only raised about $1 million in total. And very importantly, for this audience and for this discussion, 99% of our code is written by AI agents. No one is handwriting code. No one is writing code at all. It's all done with Claude Code, Codex, Droid, what have you, coding agent of your choice. And also really importantly, for the size of team we are, each one of our apps is built by a single developer, which is crazy. And these are not like little apps. Here's an example. This is Cora, which is a AI email management app. It's sort of it's an assistant for your email. On the left over here, it summarizes all of your emails that come in, so you can kind of read your email that way. This is what my inbox looks like. On the right is a email assistant that you can ask questions, like I asked, when's my AI engineer talk today, and it just gave me the answer. And this is built primarily by one engineer. He's got 1 or 2 contractors that have helped in certain ways, but like almost all of this is built by one guy. Same thing for this app, which is another one that we make called Monologue, which is a speech-to-text app. It's sort of like Super Whisper or Whisperflow, if you know of those. Again, one guy, thousands of users. I love it. It's just a beautifully done app, and it's not simple. It's complicated. There's a lot of stuff to it. Same thing for this app called Spiral. You can see it's big, and again, one engineer. So obviously, this would not have been possible a few years ago. It would not have been possible even a year ago. And I think the big change that happened that we're all starting to catch up to is it started with Claude Code, this sort of like terminal UI that gets rid of the code editor. Really pushed us into a place where we are delegating tasks to these agents. And that allows us to work in parallel and do much more than we would have ordinarily. So some of the things that I've noticed that we can do that I assume people in this room are starting to see, but I think is sort of important to put our finger on is the reason we can go much faster is we can work on multiple features and bugs in parallel. And I think that there's like a little bit of a meme of the vibe coder on Twitter that is, oh, like they have 4 panes open, but they're not actually doing any work. And you can do it that way, and I think there are also definitely engineers, and I know that they are because they work at Every, that are productively using 4 panes of agents at the same time. And that's crazy, and that contributes a lot to the ability for a single developer to build and run a production application. Another really important thing about this, a really big unlock, is because code is cheap, you can prototype risky ideas, and that allows you to do more experiments than you would ordinarily, and that lets you make way more progress because the starting energy to try something is so much lower because you just say, oh, go do this, go do some research on this big refactor I might want to do, and then you go off and do something else, and that's a really big deal. And another really interesting thing that I love about this stuff that I've noticed inside of our organization is we're moving a bit more toward a demo culture. where instead of, previously, if you wanted to make something, you'd have to be like, maybe write a memo or do a deck or convince a bunch of people that it was a good idea to spend time on. Because you can vibe code something in a couple hours that sort of shows the thing that that you want to make, it allows you to show everybody, and I think that being a sort of demo culture allows you to do weirder things that you only get if you can feel it, which is, I think, really amazing. And beyond just like sort of the basic productivity unlocks, AI and the way that we use it has caused us to sort of invent an entirely new set of engineering primitives and processes, which I am sure that everybody in this room is starting to do already. I think everyone is sort of approaching the same things from different angles, and a lot of them definitely do echo engineering processes from the past, but I think it's really helpful to try to put our finger on, okay, what is the new way of programming if we're moving up a level of the stack and we're moving from Python and JavaScript and scripting languages up into English. And the name that we've given to this process is compounding engineering. And the way that I talk about compounding engineering is, in traditional engineering, each feature makes the next feature harder to build. In compounding engineering, your goal is to make sure that each feature makes the next feature easier to build. And we do that in this loop. The loop has 4 steps. The first one is plan. And if you've been here today, you've been paying attention, you know how important it is when you're working with agents to make a really, really detailed plan. So I think everyone is doing that. Second step is delegate. Just like go tell the agent to do it. Everyone's doing that too. Third step is assess. And we have tons and tons of ways to assess whether the work that the agent did is any good. There's tests, there's trying it, there's having the agent figure it out, there's code review, there's agent code review, there's all those types of stuff. And then the last step, which is, I think the most interesting one, is codify. And this is kind of like the money step, which is where you compound everything that you've learned from the planning stage, the delegation stage, the assessment stage, back into prompts that go into your Claude MD file or your subagents or your slash commands. And you start to basically create this library. You take all the tacit knowledge that you pick up, that all your engineers are picking up, as they find bugs, fix plans, delegate work, and you make it into an explicit collection of prompts that you can spread for your entire organization. And when you do that really well, there's a lot of really interesting second order effects that are not, I think, that well understood or that commonly talked about, that I think would be interesting to bring here, because my guess is that some people are already seeing this, but maybe it needs to be pushed on a little bit more to really be brought out. And some people, it might be an interesting way to get more of your organization to buy into using these tools 100% of the time. So the first thing that you notice if you set up this process and you're 100% bought in on something like compounding engineering, is that tacit code sharing becomes much easier. So we have multiple products at Every. A lot of products a lot of times need to implement similar things, even if they use different technologies or implementing similar things like a Teams feature or a certain type of OAuth or whatever. Previously, in order to share code, you'd have to abstract out whatever you did into a library and then allow someone else to download it, and it'd be hard to do, or you'd have to talk about it. With agents, you can just point your Claude Code instance at the repo from the developer sitting next to you and learn the process that they went through to build the feature that you need to re-implement, and re-implement it yourself in your own tech stack, in your own framework, and in your own way. And that's really, really cool to kind of have this. The more developers you have working on different things inside of the org, the more you can share without any extra cost, because AI can just go read all the code and use it. Another really cool thing that I've noticed is that new hires are productive on their first day, because you've taken all of the things that you've learned about okay, how do I set up an environment and what does a good commit look like and all this kind of stuff. And on the first day, they have all that set up in their Claude MD files or their cursor files or Codex files or whatever, and the agent just sets up their local environment and knows how to write a good PR. That's really cool. It also helps if you want to hire like expert freelancers. Like there's one guy, there's one person who just is really good at this one specific thing. You can have them come in for a day and like do that thing. I think of it a little bit like a DJ or whatever can like go in on like a couple bars of a song. Like you can just sort of drop in, and that's really helpful. It would ordinarily be like too hard to collaborate because the startup cost is too high, but you can do that a lot better now. Another thing that I've noticed, which is really cool too, is developers inside of Every commit to other products. So we have 4 products that run internally. Everybody uses all the products. If someone runs into a bug or a paper cutter, like a little minor quality of life thing that they want, they will often just submit a pull request for it to the other GM of the app because it's very easy for them to go download the repo and figure out or have Claude or Codex figure out, okay, this is how we fix the bug or this is how we fix the paper cut. And that's really, really cool because you have this much easier way of collaborating across apps that I think over the next couple years, I imagine that you will also be able to let customers do this to some extent. Like if you run into a bug, this is speculative, but if you run into a bug, you can have your little agent fix it and submit it as a pull request. It's a weird open source thing, but yeah, this is really, really cool and definitely is happening a lot inside of our company. Another really cool thing is we have not, this may get different as we scale, but we have not yet had to standardize onto a particular stack or language. We instead let everyone who's building different products like pick the thing that they like best. And the reason is because AI makes it much easier to translate between them. And it makes it much easier to jump into any language and framework and environment and be productive. And so it's easier for us to let people just do the thing that they like and let AI kind of like handle the translation in between. And the last thing, which is my favorite, but like is also the horror, I think, of some developers and to some degree maybe the horror of my team, is that managers can commit code if you're technical, even the CEO. And for me, like I have no business committing code because we've got 4 products, we've got 15 people, we're growing really fast. I'm doing tons and tons of other things, but I can, and I have like committed production code over the last couple months. And the reason for that is AI allows engineers to work with fractured attention. So previously you might have needed like a 3 or 4 hour block of focus time in order to like get anything done. But with Claude Code, you can kind of like get out of a meeting and say, hey, like I want you to investigate this bug and then go do something else and then come back and you have like a plan or like a root cause fix. And then you can submit a PR. And it's not easy, it's not magic, but it is actually possible. And I think that's just a totally new way of thinking about how managers interact with the products that they make. So just to summarize, I really think there's a 10x difference in how things work when you hit 100% AI adoption. I think from what we've seen, a single engineer should be able to build and maintain a complex production product. What we call compounding engineering, but I think what all of us are sort of pointing to is, I think it really works to make each feature easier to build and then creates all of these sort of non-obvious second order effects that makes it easier for the entire organization to collaborate together. And very importantly, many people in San Francisco don't know this yet. So you're the first to hear it. So that is my talk. So if you're interested in what we do, I run Every. Every is the only subscription you need to stay at the edge of AI. You can find us at every.to. We have a daily newsletter about AI, so we do ideas, apps, and training. On the ideas side, we have a daily newsletter. We review all the new models when they come out and all the new products when they come out. the apps you already saw. We've a bundle of all these apps, and then we do training and consulting with big companies to help them use AI, and it's all bundled into one subscription, so you get everything for one price. And that's it. Thank you very much.
Ladies and gentlemen, please welcome back to the stage, Alex Lieberman.
Okay, 8 hours in. We did it. I have some housekeeping. We have to finish the day with housekeeping, but first of all, I want to thank you all. It has been phenomenal to be on this journey with you all. But let's give a shout out just to you all for being here, going through a full day, listening to the programming. So round of applause for everyone in the crowd, everyone online who's been watching. Let's also keep it going for all of the team in production, behind the scenes making this possible. I watch them work tirelessly throughout the day to make this happen. And then finally, let's give a huge shout out to Swix and Ben, who made this whole thing happen. So get comfortable for a second. I have some housekeeping, make sure everyone knows where to go. And then we have one final speaker who's going to chat right after I hop off stage. So let's just dive in for a sec. Tomorrow is the engineering session day. I will not be your MC, so you will be taken care of by Jed, who works at Google. I spent the day with Jed. He is incredible. He's just like a taller, better looking version of me, and he's actually an engineer, so you get a true engineer tomorrow. If you have a bundle pass, your ticket includes tomorrow's track, so we'll see you tomorrow at 8 a.m. here. If you have the leadership pass only, your ticket does not include access to the sessions or the venue tomorrow. However, we have organized an offsite brunch for you on us at a restaurant not far from here, so check your calendar for the invite and the location. But right now, we are headed into the after party, and not only is there an after party, but there are after parties. There's a lot of side events, so your entire night is planned for you. And we have Graphite to thank for sponsoring the after party. So here to give us the last word for a brief message is the co-founder and CEO of Graphite, Meryl Lutzke.
Good evening, everyone. My name is Meryl Lutzke, and I'm the co-founder and CEO of Graphite. We're the AI-powered code review platform for this new age of agentic software development. Now, I know you guys heard a lot today about agents and how to make them as effective as possible in generating code and building features faster than ever. And they're incredible at this, but I think everybody who's built software in a professional environment knows that writing the code is only the first part of the story. Every code change then needs to be tested, it needs to be reviewed, merged, deployed, and oftentimes that second half of the process takes just as long, if not longer, than actually generating the code. And that's what we do with Graphite. We're applying AI to the entire development process and making code review as quick as possible. We have an agent that's integrated fully into our pull request page. It's like reviewing code in 2025 and not, it doesn't feel like 2015 anymore. That's what we build. We're super excited about it. If you want to come check it out, we have our booth in the expo hall, and also we're going to be around all day tomorrow. We're the official sponsors of tonight's after party and also tomorrow's event at Public Records. So we wanted, all you guys who came from out of town, we wanted to show you a good time in New York. So we have 2 events for you to make sure that you have a good time and see what New York is all about. Want to give a big shout out to Swix and Ben and the whole AI Eng team for organizing. And we're excited to see you guys all at the party tonight. Thank you very much.
We invite you to stay for the Graphite after party, taking